We will commence the event shortly. We request everyone to take their seats. The event is starting now. Another reminder, the program agenda can be seen in the website, the DIR-V website. Any help required, please do come to any volunteer with an ID tag. Thank you. A very good morning to our participants, attendees, sponsors, and organizers. A very warm welcome back to Day 2 of the Digital India RISC-V Symposium. I'm Ashrit.
And I'm Asha.
And it's a privilege to have you with us for the second half. Yesterday was a landmark occasion. We dove into the heart of the RISC-V ecosystem, discussed hardware security, and witnessed 4 brilliant teams showcase their visions using the RISC-V processor ecosystem.
And today, we build on that foundation. We had an electrifying schedule ahead, with the remaining 9 teams presenting their work and insightful panel on India's AI challenges.
That's right. We also have more illuminating insights from our sponsors. Between sessions, please do explore the stalls of the sponsors and the participants. Their work and networking and learning are the pulse of the symposium. It is now time for the grand challenge presentations. To introduce each team and their work over the past few months, we request Mr. Kotishwaran Ekambaram from the Shakti Processors RISE Lab to take the stage.
Good morning, all. Able to hear me? Yeah, good. So, thanks for coming and participate in this event. So, we are starting with the grand challenge session. So, the main lessons that you need to learn from the grand challenge session is how the people got motivated and make their products from this. That is the learning for the student participants. Also, I am expecting the team GC 2025 participants to learn from the, it's a first outreach for them. You can learn from the industry venture capitalists and the industry people. You can get the valuable feedback from them. So with that, I am starting mine. So the hackathon actually is basically to motivate the people and fill the gap between the academia and the industry. So we have conducted one more hackathon in 2020. The main difference between the 2020 hackathon and this hackathon is the extra is the startup registration. So how it is started. So the Chip-in team has come up with the proposal, and IIT Madras, CDEC and Chip-in team has discussed. Then we came up with we joined hands and we published in the social media website. We got some 1,100 plus registrations. Of that, we have conducted the quiz program and shortlisted 100 teams from that. We have requested a team to come with their own proposals. One very good panel team has been formed, and they have focused more on the strategic applications and the innovativeness of the proposals shared, and we have shortlisted 30 teams from that. Then after the selection of 30 teams, FPGA boards has been given to the teams, and then they started with the startup registration phase. Parallelly, we have started with the webinars. We have published our GitHub repos from which they can take the necessary files, hardware, Verilog files, as well as the Shakti SDK C codes, so that they can take it and test it. We have provided the PPTs and documents as well. We have created the forums group as well as WhatsApp group to get the issues resolved quickly. So this was a very good opportunity to convert theory into practical. So the people got very good experience in learning the FPGAs. In colleges, you have studied only some very simple projects based on FPGA and simulation, right? So here we had the experience in handling the FPGAs. They have gone through the complete FPGA design flow. They have learned the embedded C sessions. they have learned how to make the PCBs, how to make the schematics, how to make the layout, how to go through the data sheet and select the components required for their application. So the hackathon has been divided into 3 stages. They need to complete their startup registration. Once they have done with the registration, they got the seed fund of 1 lakh rupees. So with that, they can buy the required components for their making their product. Then the second phase is minimum viable product. So they need to showcase their application is working as expected with their individual sensor with discrete components. So after the MVP stage, the panel, again, we have formed a panel which have gone through all the demos which happened online, and they have recommended and give valuable feedbacks to convert the startup into a very good product structure. So they advise them to focus on the form factors, who are all the competitors, what is the revenue model they need to take care of, then how to do the marketing, sales, analysis, how to make the road mapping. So they have been asked to taken care of all those things. Then in the second stage, proof of concept, they came up with the, initially in the MVP, they have tested the product as discrete components. With POC, they integrated all the components and tested it and bring it to the demo. So after POC stage, few of the teams which are in the second level, bad level, they came up very good, and they are very able to showcase their very fine products in the finals. Especially, I congratulate Byte Gladiators and Cognilith, which are coming into this category. And also the finals, as 5-member committee has been formed, and the finals happened from 29th to 31st. The people traveled to Trivandrum and participated in the final. The evaluation is done. Then the team came to IIT directly for the symposium events. I want to thank all the teams which joined with us. So with this experience, so the people who are participating in the today's symposium can go to the stalls. You can learn from them what are the issues they have faced during startup registration, when they are converting from academia to industry, what are the issues we may face. Also, the making startup is not easy thing. In college, we'll be doing some simple projects, right? Simple practicals. For example, we might have written with some simple adder and subtractor multiplication like that, right? So here we need to assemble all the components, generate the bit stream. We need to test the product. So all these things will, during the compilation, will face some logical errors, implementation errors. We need to resolve all of them. So you can discuss with the team whatever the challenges they have faced, also whatever the milestones when they have met, the feeling and the excitements that they have, all those things you can learn from them. So also I am requesting the industry and the VCs to visit their stalls and supporting them by giving your valuable feedbacks, suggestions, and funding support. So with this, actually, I am finishing my introductory speech. So today, for today's session, we are going to have presentation and demo for some 9 teams. So I have divided the teams into, we saw actually during the evaluation, we saw 2 teams actually are very much self-interested, interacted with all the teams. So I want to call one of the team as the first participant today, and I will be calling the other team as the last team. So I am calling the first team who are doing the flight controllers. Yesterday we have seen one team, right? Byte Gladiators. They have done the flight controllers. So there are 2 concepts. One, we can take the simple example of helicopter and aeroplane, right? Helicopter can fly from the beginning itself. So Byte Gladiators has taken the concept and bring the flight controllers with the same concept. They have that drone that will fly immediately, right? So the second team, Cognilith, also have their flight controller mechanism, which follows the aeroplane concept. It will start flying with stages. So they are using the fixed wing technology. So they are the second flight controllers, which Sakti, They have successfully demonstrated in the evaluation also. I am having excitement in calling the team Cognilith to come to the stage and give their presentation. So they have formed a company called Swan Systems. The members are Vedang Dwivedi and Vinayak Vinith. I am giving the control to the session. Yeah. I am welcoming them. So please motivate them by clapping.
I hope I'm audible. Amazing. Okay, before we start, I would like to thank Kotesham sir for the warm welcome and everyone present here to actually attend our session about what we are going to do. And I'll start briefly. Open the timer. Okay. Okay. Before we start, so we have, as sir said, we have made an indigenous flight controller based on the Shakti processor. But before we talk about the specs or why it exists, we need to understand the reason that we need a product like this, right? And we are one of the first in India to build a component of the shelf that is a product that you can buy off the shelf without any modifications for defense applications. Recently, India announced around 2 billion USD for the Indian Armed Forces to actually acquire drones. Now, whenever we talk about drones, we need to understand that any company you look at, Agam, Dark Matter, Aero GCS, there are hundreds and hundreds of companies in India creating flight controllers for defense applications. But what do you realize is that 95 to 98% of those flight controllers use the STM32H7 architecture or the chip or NXP semiconductors, right? What does this lead to, right? This leads to a dependent supply chain risk on the US or the European states. Did you know that during the Kargil war, GPS was denied to India by the US and we were unable to use missiles or planes? The same thing can happen during the next conflict where US can deny us STM32 chips and we will run out of drones, interceptor drones, missiles, and a lot of other critical components that we need for our defense. What do we present? We have a very simple solution, right? We are bridging two gaps. First of all, we are using the Shakti processor made in IITM, being manufactured in SCL Mohali. We take that chip, so even if tomorrow the supply is cut off, imports and exports are cut off, we still are not dependent. We can still create more drones, more missiles, more anything that we need because the semiconductor is being manufactured in India, right? We are also bridging another very critical gap. If you're a defense startup in India and you want to make a drone, a loitering munition, you need to make a surveillance drone, where will you get the flight controller from? Most startups end up building the same controller again and again and again. What we aim is to provide a certified board. You might not know this, but a lot of boards that are currently being used are not certified to the standards. So even if you are able to sell to the Indian Armed Forces, you might not be able to export it. We're trying to fill that gap and essentially give you a board for defense purposes that can be used by the Indian Armed Forces. If you're a startup, you can use it for your own product. You don't have to worry about electronics. You have to worry about your own product, right? And you can export it later on without having issues of will it be compliant, will it pass compliances or not. So more than the specs, it really matters what is the value we provide. You never buy a phone because it has 480 megahertz. You buy the phone because it feels fast. You buy the phone because it has good UI. So I'll tell you the main value that we provide, right? First is it's very easy to integrate. We are trying to make a plug and play solution. So essentially, if you're a startup, you can take a solution flight controller and you can switch it out with whatever flight controller you're using currently, and we are trying to give support to almost all softwares that exist, right? We have talked to many startups and they have told us these are the softwares we are using, and we are making sure that Shakti doesn't stand back and we can actually go toe-to-toe with foreign processors such as STM32H7, right? And it makes it a must-have, especially when you're selling to defense. Having our flight controller will make your product more attractive to the Ministry of Defense, because almost everyone is going to give you the same product, but only one product will be the one with an indigenous chip, right? So we need to understand that a lot of people understand that you need standards, right, to actually pass the standards, and there are hardware standards that you need to pass. But you also need to understand that there are software standards as well that you need to pass. if you want to sell it to the Indian Army or abroad, right? So what we have done is we have rewritten a lot of code from scratch. We are ensuring that even the software is compliant with international standards such as JSF or MISRA, C++ standards, right? We are ensuring that if you buy a product, you can sell it abroad, globally, or to the Indian market without having any issues in the hardware side or the software side. These are the sensors that we are using. You can, of course, come to our stall and we can show you a demo, but we'll go ahead with this. We'll talk about the high-level system architecture that we have, right? So we have 4 basic architectures that we are currently using. We have the I2C interfaces for all the sensors. We have UART. We have PWM interfaces. So currently, we'll show you the demo that we have with a fixed-wing aeroplane. But essentially, this can be used for anything: quadcopters, hexacopters, anything that needs control, right? It can even be used for robotic arms or UGVs, UMVs, anything that needs a control, this flight controller can be used for.
Okay, next up for a little bit of background on the software architecture of the thing. So we've developed a custom RTOS, a real-time operating system, to be able to execute every single task that we require on the board, right? So you can see there's a lot of different tasks like arming the motors. So that's a really like safety related feature. Then we have other things like receiving the data from the ground station, sending back telemetry. So each of these are different tasks that we've made sure are isolated. So if one task fails, the rest of your board will not fail along with it. So we have a lot of fail-safes such as this in place in the software. Yeah.
So as Vinayak said, we have introduced a DIR-V. It's a specific custom thing that we have written. So what we are essentially trying to provide is, if you have a software that's running, and if the software fails, it's very likely that your drone or plane is going to crash. What we are trying to do is we introduce a layer between the actual hardware and the software that you're communicating. And this DIR-V, defense-based RTOS, essentially works in between. It takes the input from the sensors directly, and you can hard code things. Let's say your software stops working in the air. That doesn't mean your drone's going to crash. DIR-V is going to ensure that it's able to land safely. You can add features. Currently, we have many features as angle of attack, stall prevention, self-stabilization in the air, and other such features, right? We'll show you a video. So we are testing this in Bangalore. This is a 2-meter wingspan plane that we have actually tested our flight controller with. The range that we can provide is a lot. So any transmitter-receiver pair that you have, you can use it with a flight controller without having to worry if it will work. Currently, we support ELRS. It's the most standard and it's the most popular and standard industry protocol that's used. This plane has a range of up to 15 kilometers without any deterioration in, signals. So as you can see that it's a very big field, right? When we fly the plane on the ground, it's very hard to actually see where the plane is going, but we have a very large range and you can see that. Recently we went to Trivandrum and we flew it near the beach with winds that were up to 40 kilometers per hour. So we are able to self-stabilize it in the air. So what self-stabilization essentially does is it gives you the ability to stabilize in the air. So if wind knocks you off course, the pilot doesn't have to worry about correcting the course. The flight controller can automatically correct the course with the sensors on board. So essentially we are making sure that you can command the plane to go somewhere and the plane will go there. You don't have to worry about driving it there. Essentially, you just have to point and the plane goes there. So this is one of our better videos that's shot on drone. Yeah. So we have a stall below. We have a live demonstration where you can come, you can try out a TX15 with a simulator that we have created to understand the workflow and get a real feel of how the flight controllers work. It doesn't matter if you have ever used a flight controller or not. You can come, you can have an experience, and you can understand how easy and integratable our solution is. Instead of saying that it's easy, integratable, we want you to come and experience it firsthand at our stall. And yeah, you are feel free to, if you feel like you can collaborate with us, you can talk to us, and if you have any suggestions, feedback, you can visit us at our stall, or you can scan the QR code, you can follow us on LinkedIn, whatever suits you. Even if you are students and you want to try new projects in flight controllers, you want to make fixed wing planes, you want to try UAVs, do not hesitate, reach out to us. If you're a company who's looking to help us or collaborate, if you're a drone company, a flight controller, feel free to reach out to us, and we can always take the conversation further. That's me signing off. Thank you so much for being such an amazing audience.
A kind request to the audience, please keep your mobile phones on silent as the audio is hampering the live stream. Also, a gentle reminder for all teams to keep their presentations to a limit of 8 minutes max. Thank you.
So hope you enjoyed with the first demo, right? You see the motivation from the people also, right? So we are switching over to the second applications. The next two teams basically are doing some image processing and video processing part. So as you all know, image and video processing is very difficult to do that, right? I am calling the first team Hexa-Hive. So who has taken the tiny ghost YOLO algorithm to make the image processing and infer the object. So I am calling the team members. Just a second, sorry. So Shalla Gandhi sir, Pranay Manjusri and Satya Srija to showcase their presentation and a video demo. I am welcoming them. Please, we can clap and welcome them. So one more announcement. So this is the only guy who took part in all the panel sessions. So we need to clap him for this.
First of all, good morning to everyone. We are team Hexa-Hive. We are from Chipletics Private Limited. Firstly, I need to thank Kodeswaran sir for the warm welcome today we have. So coming to Hexa-Hive, we had a journey of about 8 months what we have briefed from Kodeswaran sir, and it was really motivating. And we ourselves has been driven into learn many new things on FPGA, and we continuously focused on how we can improve and make sure that the product comes out, not just a prototype comes out. So we need to thank them for all the continuous support and motivation what we have been for the last 8 months, I hope so. So coming to Chipletics Private Limited, so as sir mentioned, we are focusing on image processing. So what we do actually in this company is that we focus on manufacturing the payloads, not the hexahopter. So we provide the payloads for all kinds of drones, where we do like an edge AI based system, where we are trying to get the alert based system, which helps us to avoid large video transmissions what we have during right now what people are using it. And this comes up with completely indigenous, so which we can use in smart drone surveillance, what our initiation taken by the central government at Bangladesh border. So we have many use cases where we are providing the edge intelligence to the drones. So my teammate will continue.
Good afternoon. Good morning. At Chipletics, we are building an indigenous edge AI payload that transforms conventional drones into a surveillance platforms for defense, disaster, and infrastructure systems. In last few years, India have witnessed increase in drone intrusions, cross-border attempts, and also several security threats. During defense operation, one challenge emergently repeated, which is they don't need a continuous video transmission. Instead, they just need an immediate alert. The existing solutions rely heavily on continuous video transmission, which increases to send it to the cloud or GPUs. This increases the bandwidth, latency, and consumes more power. And also in remote surveillance areas, it requires internet connectivity. Our payload contains 3 major components, which is a camera for visual sensing and an FPGA that accelerates AI interface, and Shakti, which acts a controller in our product. The camera is used to capture the real-time video, which is processed into the FPGA. Here FPGA performs all its computational tasks, and Shakti processor controls, accelerates, reads, and detects results through AXI4 light interface. Here we can see the hardware architecture, where we use a CMOS camera OV7670, and we perform some conversions, which is a grayscale conversion, and resizing it into the 64x64, and we were able to generate the bounding box to show as an output. While coming to the software sector of our side, we have completed the booting of Shakti and working of a Shakti as well. These were the images which we have worked and the detection of humans and the data sets which we have worked on. While coming to the business commercialization, our primary focus is defense sector, and also disaster management, and infrastructure monitoring. Instead of building an entire drone, we are building what goes into it, which is why Chipletics is focused on building the payload. As we were relying on a processor-based Indian origins rather than the foreign countries, we have a huge market opportunities. Apart from selling a payload, we also generate revenue through OEM platforms, partnerships, and also software upgrades. Our main goal is to make it scalable and completely accessible. Today's India's push towards smart borders, there is a need for technologies that can analyze real-time situations. Let me show the demo of our product.
For surveillance and emergency response. Camera captures the scene and the RISC-V FPGA performs image pre-processing and lightweight CNN-based object detection on board. The Shakti RISC-V processor controls the accelerator through AXI4 Lite, sends commands such as start, enable and threshold, and reads the detection status and bounding box coordinates. When a person, vehicle, or mission-specific object is detected, the system highlights it with a bounding box and sends only an alert to the ground station instead of continuously transmitting full video. This reduces latency, bandwidth, power use, and cloud dependency while improving data security. The platform can be adapted for border surveillance, disaster response, search and rescue, and infrastructure monitoring. Our goal is to convert this prototype into a compact, secure, and field-ready product for Indian UAV platforms.
On behalf of Chipletics, I extremely thank you all for giving this opportunity. I must be thankful for the DIR-V Symposium for giving us an opportunity to showcase our product. And we will be ever grateful for this Grand Challenge team, whole team. And I could only say one thing, that we get motivated and we have a broad mindset, like we are looking after the entrepreneurship and make in India to be a grand success in India. Thank you all. Thank you for this opportunity.
So, thanks Hive team for their great presentation. Hope you have enjoyed. So, he is a big fan of our director as well. So, he attended all the symposiums happened here. So, thanks to them and all the best for them. Next, I am calling the team Digital Titans. They have came up with their startup, Viscripta Technologies. I am welcoming Shyam Ahmed and Hish Kapoor to take the control. So, they are doing the image surveillance system. It's called quantum based image surveillance system. So basically again it's targeting for defense application. I'm calling them to the stage.
Good morning everyone. Good morning everyone.
Yeah, good morning everyone. We are the team Digital Titans from IIT Patna. We are developing a post-quantum secure surveillance for strategic applications. And these are the team members you have seen. Moving to the problem statement. Modern surveillance system process sensitive video, multiple untrusted components like networks and cloud, creating risks of data leakage and unauthorized access. To address these solutions, we proposed a hardware-based end-to-end encrypted hardware system for AI surveillance system. Our aim is to build India's first indigenous 60 processor-based edge AI-enabled quantum secure surveillance. And this is our system which we are developing right now. So moving to the existing challenge. You heard about the recent US-Iran attack, that how Israel attacked their supreme leader by compromising their street camera, which is a national threat for there. So the question is come to our mind that it's okay that surveillance should be secure should be relevant towards the defense and critical infrastructure or national security. Then why we care about them? Why the normal people care about that? So we fund this relationship that every day millions of users hit the UPI payment every day, and wherever they are hitting the payment, there is a surveillance is already seeing their feed, that what they are or their payment, their UPI payment, their password, their banking credential, which should not be get by the attackers. And our Indians, and this research paper demonstrate that by just one single footage, 6-digit PIN can be extractable by 11%. And if attacker get multiple visuals, it get up to 80%. This will be huge problem for the people who are sitting here. So moving to the existing challenge about supply chain. India heavily relies on the foreign IPs, foreign chips, which has hidden backdoor. So software backdoors can be detectable, but hardware backdoors no one can detect. And this is the exactly issue faced by the Iran street cameras. Their cameras compromise more than 8 years, which is a national security threat. Moving to the next, quantum attacks. So we already know about that quantum computers will be the futures. Quantum computer is coming, and they are significantly milestone is completed about like it's achieved 200 qubits. So to address this, the modern cryptography relies on ECC and RSA, which is already broken by Shaw's algorithm, which runs on the quantum computer. And future will be quantum resist cryptography. So address this, we propose the quantum secure surveillance. That is why our novelties lie here. That even our camera, if anyone installed today, the camera will be secure even after 5 years. So the relevance of problem statement is that security threat is real. It is a national security. It is matter for you as well, because you are exposing your phone password, your UPI pins, your bank credentials every day, and maybe your password is already sold there in black market. No one knows right now until the attack will come to you. Regulation also for forcing change. From April 1, 2026, India mandates the STQC certificate to ban the Chinese brand like Hikvision and Dahua. So we have seen that the hike of 20% of camera prices. Moving to the post-quantum era is already started. Recent Google papers demonstrate that the only 10,000 qubits is enough to break the modern cryptography. And Microsoft and Google is already shrink their deadline from 2030, which is established by the NIST, from to 2029. So moving to our key innovations. We established a post-quantum key based key exchange mechanism. Then we design indigenous based Shakti processor. All crypto accelerators are self-designed, no third parties IP in the security path. Moving to the hardware software. So we've seen that the computational intensive block we offloaded towards the hardware side, and the lightweight process runs on the software side. And we have designed a smart schedule because their UDP collision is there. So we reduce the UDP collision by smart scheduling. Over to Ish.
So this is our overall system architecture. So we have a FPGA which contains the Shakti processor along with the camera accelerator and all the other crypto accelerators required for the post-quantum cryptography and encrypting the video. The authenticator app, we have two apps, user app and authenticator app. The authenticator app is responsible for running a two-stage AI inference engine and also managing and authorizing the clients. Okay. And on the software side, we are using a Kafka broker to manage the managing the threat detection notifications, and also we have a smart fine-tuned scheduler which manages multiple client requests to reduce UDP collisions.
So let's talk about our SoC hardware architecture. So you can see the purple one is our Yamuna Shakti processor, and the orange one is generated by the Vivado IP, and yellow one is developed by our own. So there's a XI Kekak, which is a SHA-3 family crypto accelerator. So it's a unified SHA-Shake accelerator. Then the right one, there is a XI entity accelerator, which is used for the post-quantum algorithm. And there is a XI point-wise multiplication. It is also a cryptographic algorithm, which is used for the MLKEM, which is post-quantum cryptography. And there is a XI TRNG. It is not a TRNG, but it's a new TRNG because FPGA is not allowed to sample the noise. And there is a camera interface module accelerator. And then there is a XI AES, which is also developed by our own self. Then there is a XI packet, which converts the AES data into UDP packet. So yeah, this is our hardware architecture. And there we have used 3 interface: XI4 stream for peripheral connections, XI4 full to high memory bandwidth, and then XI Lite for configuring the accelerator. Let's talk about the publication potential IP patent. So one paper is already accepted in IS-VLSI conference. Then we submit a journal paper in TCAS paper 1, which is under review. And this is our potential patent we are discovering future. So yeah, this is our product completion status, what we have developed right now. And yeah, thank you. Yeah, there's a video.
They have a small video which demonstrates their surveillance system.
So this is the user application. The camera is already on, and there is an admin app. Now this user is trying to authorize himself for the admin. Okay, so let's cut it quick. He filled the details, and now he is waiting for the admin to approve it. Only when the admin has approved, then only he will be able to log in with the same credentials and watch the video feed. Okay, and we have a second bit for the ML detection. So suppose like we used YouTube videos, random YouTube videos of fighting, Bulgari, and we like checked the AI detection. Okay. Okay. Now this is a robber who is trying to rob the ATM bank, and AI engine has detected it. So this feed is totally encrypted. Only the authorized users are able to see this video and get the notifications. We have also tried man-in-the-middle attack by sniffing UDP packets. So if a person tries to sniff the packets, he can only see noise until and unless he has the right key. And that right key is post-quantum secure through post-quantum secure key exchange. So thank you, that's all.
So let's talk about the man-in-the-middle attack.
Getting the request.
So yeah, if someone try to sniff their attack as a man-in-the-middle attack, they see exactly same visual. They can't see the exact video. They see normal noise. So this is exactly what we are developed. So you can see. Okay. Thank you. Thank you, guys.
Thank you, Digital Titans. So the next two teams are basically doing the image garbage collection. So we can see in the roads, right, PVC covers is a treat for us in ponds. So two teams come up with a solution for them. The first one is Curious Minds, which focuses on collecting the garbages on the road. Basically, in the current product, they are focusing on the plastic garbages in the road. They have plans to extend it to the other garbages as well. I am welcoming Mr. Darshan from Curious Minds team to come and present it on the stage. He has formed a startup with name Kritam Yandra Limited. Welcome him by giving some claps for him.
Hello. Yeah, myself is Darshan, assistant professor from Sri Venkateshwara College of Engineering, Bangalore. Okay. First I like to give the thanks to my mighty Minister of India of Information Technology and Chip to Startup. Okay, as well as for Digital India to give me the opportunity to build up my product using the RISC-V processor. Okay, so here my product is, my problem is, first I am going to focus on the garbage where it is going to fall on the public places, which is related to the plastic covers. I am mainly focusing on the plastic covers and plastic bottles. Okay, so here what is the problem in the day-to-day we are seeing in the environment is the decaying of the plastic is, so it is taking more millions of time to decay. And in order to overcome that, I had to pick up from the public places, and I had to make the segregate process sort out. And using that sort out process, we can do the recycling process. So using that concept, I developed this product here. Okay, and here I am going to implement the concept of the autonomous vehicle using the Bluetooth connections along with the RISC-V processor here. Okay, so next is, this is what about my picture, what I am going to showcase here. This is about my product, what I developed using the RISC-V processor. Okay, and about my team members, this is Kirtana, Manasa, Vanita and Veena. These are my team members. Along with that, I am the mentor of this product, Darshan Abate, and assistant professor from Sri Venkateshwara College of Engineering, Bangalore here. And here the problem of my statement is, mainly I am focusing on the plastic pollution which is creating in the public places. I need to give the awareness to the public where I need to collect the plastic places and reduce the pollution which is going to cause effect on the animals. Mainly it is going to cause animals, okay, street animals and all. So along with that, one more the problem is it is very difficult to sort out process, segregate process, because it is very clumsy process we need to perform. It is not easy to perform the segregate process because the plastic is always come with different solutions. So in order to segregate process, that is also the main part, we are focusing on the sort out process. That is what we call, in order to overcome the manual segregation process. Okay, so this is the concept we kept in my project in order to overcome that. And when you come into my product, this is about my product. In my product, we are using the RISC-V processor where I am going to perform the image processing concept. Along with that, I am going to connect the motors. Along with, I am going to use the actuators, linear actuators and IR detector sensors. Okay, and here what is the process which is going to happen is here I am going to use the rotating brush where it is going to pick the plastic carry bags from the surface ground level. Once it is going to pick from the ground level, it is going to place into the slant conveyor. we are going to use two types of conveyor. One is called slant conveyor, other one is called horizontal conveyor here, where it is going to place the plastic carry bags in the slant conveyor. Once it is going to place the slant conveyor, put up in the horizontal conveyor, where in the horizontal conveyor we are going to use the camera to detect the plastic or non-plastic objects. Okay, once here we are going to use the IR sensor. Using the IR sensor, what it is going to do? First, it is going to detect the object is there or not in the horizontal conveyor here. Once the object is detected, the camera will capture the image. Using the using the image processing, we are going to detect whether it is a plastic or non-plastic object. Based on that, we are going to give the command or instruction to the linear actuator in order to dump the plastic or non-plastic item into the dustbin. This is the complete process what we achieved in the RISC-V processor here. And this is what about my system architecture, what I am going to use and implemented in my whole project model here. Okay, here I am going to use the FPGA, nothing but I am going to implement the RISC-V processor, nothing but we call that a silicon on chip we implemented. And we are going to use the 24 volts battery source, where I am going to supply to my linear actuator as well as my DC motor. The DC motor 24 volts which is connected to the wheel supply. Okay, and along with that, whatever the commands I am going to give to this this is the linear actuator and the motor which is coming from the FPGA using the H-bridge connector here. Along with that, I am going to use the conveyors, whatever the conveyor I am going to use, the slant conveyor and horizontal conveyor. That is for I am going to use the buck converters. I am going to reduce the power supply from 24 volts to 12 volts and 5 volts here. Okay, this is in order to control the conveyors control, I am going to use the relays. Using the relays, I am going to control the slant conveyor and horizontal conveyor using the command which is going to given by the RISC-V processor which is implemented on the FPGA processor here. And here the IR sensors and the proximity sensor directly I connected to my RISC processor, nothing but FPGA board. Okay, and I am going to control my robot using the Blink app, nothing but through the ESP module 32, which is nothing but I am going to make the command to make autonomous. Instead of manual movement, I am going to make this as an autonomous movement here. I am not performing any manual movement operation here. So this is my complete operation of my project model here. And this is what working principle, what I taught, what I explained here. So first it is going to collect the garbage from the waste from the floor, and once it is going to collect from through the collecting rotating brush, it is going to place on the conveyor belt. After that, it is going to place on the horizontal conveyor, the IR sensor which is going to detect the object, which is the object is there or not in the horizontal conveyor. After that, the image will capture by using the camera, OV2670 camera. After that, once the camera is detected whether it is a plastic or non-plastic, it is going to give the command to the actuator which is going to dump into the bin separately sort out in order to reduce the sort out operation. That is what the complete operation which is going to happen in the project model. So this is what I am going to play my video here. Once again. This is what autonomous controlling. I am going to give the command to the Blink app in order to make the movement easily. First, it is going to pick the plastic carry bag from the rotating brush. Once it is going to place, it is going to place on the slant conveyor, where we are going to give the support in the slant conveyor. We are giving the support because in order to pick the garbage from the rotating brush, we are giving the support. If we don't provide any support for that, again it is going to fall down. That is what we are fixing, that support for the carry bags here. And also we are covering that because whenever the heavy air flows, again it is going to fall down. That is what we cover up that case using the plastic cases. Once it is going to fall on the horizontal conveyor, it is going to detected by the conveyor. It is going to detect by the IR sensor as well as the camera. Once it is going to classify if it is a plastic or non-plastic, it is going to dump into the dustbin using the linear actuator process. So this is the complete process which is going to happen here. The application where we are going to implement is the smart city, railway station and parks, public places, college campus and industrial area and tourist place, where we can implement all this product. Thank you for me giving the opportunity to give the project model demo here. And thank you for quotation, sir.
So thanks curious mind for their presentation. All the best for them. We can have the question session actually once we have done with all the teams. We have another 4 teams. So we'll try to have the Q&A session after that. Sorry. So next we are going with the second team. So both the teams are basically become the mechanical engineers. You can see many mechanical parts there, right? So I am calling the other team. So they are targeting to collect garbages from the ponds. So I am calling the team Digital Dogs. They have made their startup with the name Me Visai Technologies. I am calling V. Raghav, Hari Varasan, Sasta Rajan and Santoshar to start with their presentation. Thank you.
So, good morning, everyone. Our Indian water bodies are being polluted with floating debris like floating water bottles and food wrappers, polythene covers, which directly affects our ecosystem and affects the aquatic lives and slowly turns into microplastics that get into our food and water. So, you can see these are the targeted water bodies. And the formal cleaning method right now which we use in India are manual cleaning and diesel skimmers. People have to get inside and they have to collect all the waste and they have to get out. So these methods are currently inefficient, unsafe for the laborers, and it's inconsistent too. So that's where we come. We design Aquabot Shakti, an autonomous, affordable solution for getting into shallow water bodies and collecting the floating waste autonomously. Yeah, so how it works, you define the area once, you define the boundary of the water body, and our Aquabot plans the mission. It plans the coverage waypoints, and it autonomously travels through the waypoints and collects all the floating waste that are on track, and return back to the home point where we left autonomously. And yeah, we also have live IoT telemetry where we can see the position of the bot and how much waste it has been collected, and the GPS location and the battery charges and everything. Yeah, so.
Okay, now we'll see about the features of our Aquabot. Actually, before starting with that, we'll see the dimensions of our Aquabot. It's 5 feet cross 5 feet. And before we start to manufacture it, we were doing the buoyancy calculations for the area to be covered and the weight we should add. So as of the calculations, we calculated up to 200 kg, and the bot of no load is 120 kg, and it is capable of collecting 25 to 30 kg of waste. And we'll see the features of this. We had integrated a GPS module for all GPS locations, and the module has an inbuilt magnetometer for the coordinates to be, for reaching the coordinates effectively. And then we integrated a water sensor to internally monitor the water ingress if there is any ingress of water inside our hulls. So then we have a remote control. We use FlySky i6 RC for remote control for this Aquabot. If there is any interruption need to be done for the user, the operator, the remote control is provided. And whenever you interrupt the bot in the autonomous mode, it actually commences where it left the autonomous mode. And then we have used a NEMA 34 motors for high torque. And we have connectivities like Wi-Fi and GPS. Wi-Fi is for IoT telemetry, for live data transfers. And speed up to 1 meter per second is the maximum speed of our bot. And then the bin collection is actually easily removable and replaceable. When the bot collects the waste and it returns to home as its own, and we can easily replace the bin by collecting it. And we use 48 volt, 52 volt lithium and batteries. It has a runtime of 8 to 10 hours, and we tested for 8 to 10 hours, and we added the data for us. This is our dashboard where we can just give the points of the coordinates. This is like our G maps. There you can enter the location of your pond, and you can select every points in the points to be covered. The algorithm we made, which will convert these points into a coverable map, which will form a map and lanes. These lanes will be covered, and we can track the survey area and the track length, estimated time estimated time to be covered. And we have that BMS calculations, BMS data also in our dashboards. Okay, we use a Bostrom coverage algorithm with a crosstalk error. This crosstalk error we applied because we don't need to have any crosstalk error of crossing the lanes automatically. And also we have a PID control to manage the water drift and due to air and other reasons. So these PID controls will automatically change the bot's motion if it is any interrupted, and to normal lanes to be followed, and we have also the fail-safe return to dock. Whenever the battery is low, for 20%, this is a threshold we set. When the battery is down to 20%, it will return to home. And if there is any water increase, the water sensor will alert and it will return to home as well. Okay.
As you mentioned, our entire autonomous system sits on Shakti's Yamuna SoC, which is implemented in RTI-7 FPGA board. And our product's autonomous navigation depends based mainly on GPS and magnetometer sensors, which uses UART and I2C for its efficient communication and providing the heading informations. And in addition to it, for propulsion, we use PWM controlled closed loop BLDC motor control system. And also we have the entire system is powered with a single 48 volt lithium ion battery with integrated BMS. And also we use water ingress sensors to continuously monitor any water leakage inside the hulls. And apart from using the flash for storing our program, we also use flash to store our progress of the bot's navigation, so that in case of any unintentional power loss, the bot resumes from the recent progress. And the validation we achieved at 98% telemetry uptime. Also, we saw the bot can actually cover 2200 square feet in an hour, with actual battery endurance being 8 to 10 hours per charge. And also we are able to cover 95% of the bounded area we tracked. And these are the two places where we tested our bots near Tanjavur.
So these are the estimates of market projections. In the next 3 years, we aim to attain an market revenue of 1.8 to 3.6 crore. This is backed by the recent government initiatives and corporate initiatives towards a greener future and cleaner future. So currently we are in the stage of TRL level 5, and we plan to move towards our TRL level 7. So this is our recent demo, recent testing video which we have taken in a pond next to our campus. This clip shows how we can collect the waste using our remote control mode. So this is a clip of our bot moving autonomously in a predefined path generated by itself. So once after completing the collection, we can easily remove the bin and replace it, and we can go for the next cycle. Our bot can operate for a time period of 8 to 10 hours in a single charging cycle. Yeah, we take this opportunity to thank the organizing team of Grand Challenge and Symposium for giving us this opportunity to bring our team to this stage. Thank you.
Thanks team. So here you have seen the teams completely converted from electronics to mechanical domain. So next we are going to the medical field. So two teams are coming under the category. Both the teams are using Vega processor. The first team is Binary Bandits. So they are coming with the solution with digital stethoscope. So I am calling the team to come to the stage and present. So they have formed the startup with name Digiscope LLP. I am welcoming Yajala Yamuna Kumari, Medlin M. Saji, Shreya RS, Jaswin Joseph, and Gopika Gopakumar to come to stage and present. So we'll welcome them by motivating by clapping them.
Yes. No, this is okay. A very good morning to everyone present here. We, the team Binary Bandits from ERN DCI Institute of Technology. It is a privilege to present Vega Chikitsa, a digital stethoscope built to bring intelligent AI-powered cardiac and pulmonary auscultation into everyday clinical practice. This is not a concept. What we see today is a working end-to-end system, hardware, firmware, and a companion application built entirely by a team under the mentorship of Divya DS and developed under our startup entity, Digiscope LLP. Our vision is simple, a digital future for the oldest tool in medicine. So let us begin with why this matters. The analog stethoscope has remained functionally unchanged for over a century. It depends entirely on subject hearing of clinician, which means outcome vary with experience, with hearing capability, and with noise in the room. It cannot record, it cannot document, it cannot review later or shared with a specialist 100 kilometers away. We surveyed 74 clinicians directly on this question. The single most required capability by a wide margin was simply the ability to record heart and lung sounds. Close behind that, we have murmur identification, flagging at-risk patients, and heart and lung capture. Everything in a single device. This tells us something very important. Clinicians do not want a replacement for the judgment. They want a tool that augments it. This is exactly what we have built. So presenting you a Vega Chikitsa, a smarter stethoscope. It captures capture of heart and lung sounds with real-time noise filtering, data storage, remote healthcare support, and ML-based murmur detection. The key innovations are real-time digital noise filtering for clean auscultation, ML-based cardiac murmur detection on captured audio, the remote healthcare and telehealth support, persistent recording, and digital documentation. So let me give you an overview about the system architecture that we've built with this product. So what we see in the picture here, we have a chest piece in which is embedded with a MEMS microphone. A digital mic carries all the analog data or sounds from the heart. That has been processed with a dedicated hardware. And our hardware consists of different peripherals, as you can see in this picture. We have RAM, ROM, I2S RX, I2S TX, and UARTs, and SPI. This complete hardware is being dedicatedly used by Vega 81051 processor. And we thank the entire CDAC team for giving us the opportunity to work with a specialized processor that is Vega 81051. And after the dedicated hardware, we have 3 output audio paths. That is audio output path for the immediate hearing for the doctor, and a wireless output Bluetooth, which is connected to an app application where you can do the audio playback, murmur prediction, and patient report. And we have a display which indicates the volume and mode changes. So if we want to talk about a little more about the hardware architecture and dig deep into the engineering of this project, we have completely integrated the system and implemented the device in RT-A700T board. As you can see here, we have used the Vega core, that is 81051 processor, connected with an Axie crossbar and different peripherals as I mentioned earlier. So the output path through I2S TX and I2S RX connected with the DAC and through the earphone for the immediate hearing. And then we have a Bluetooth module which is connected to our companion application which helps the patient to record the data. And we have an SPI display which helps us for the volume indicators and mode indicators. So coming to the hardware utilization, we have utilized almost 62% of LED and 58% of BRAM. And the rest all is being displayed in the picture here. Okay, since I've told you we have a companion application connected over the Bluetooth. So how is it working? So initially once the power is on and the initialization is done, the display setup and the startup screen will display the Digiscope LLP. And then through a touch sensor, we could hear the sounds of the heart through the two output paths. That is, one is for the local speaker output and the other is for the Bluetooth streaming. So coming to the companion application, once the Bluetooth is connected to the device, we have audio received via the Bluetooth. So once the data has been received via the Bluetooth, we have a capability of recording the heart sounds. So we can have an option of recording for particular duration. Once the data has been recorded, we'll be storing it for the fixed duration amount of time. And we have an ML model also embedded into this application, which will help us detect if there is murmur detected or murmur absent. And then we have a report generation that consists of waveform, MEL spectrogram, and the prediction result. As you can see here, my team shows you the product in his hand. The one that you're seeing right here is the diaphragm which is holding with a Digiscope LLP logo. And that is exactly where the doctor can put it on a patient's heart where he can capture the heart sounds. And then you have a display, that is an SPI display, which helps us to show the different types of modes of the complete application. We have 3 different modes, that is wide mode, lung mode, and heart mode. Wide mode depicts that it has both heart and lung sounds, and then the lungs only dedicated to the lungs, and heart is only for heart. We use a specialized filter to separate the heart and lung sounds. So that is the end-to-end demonstration flow of my application. And coming to the companion app, what we can see in this picture here, you have that graph that you can see here is the MEL spectrogram graph of a normal heart, what is being captured through our mic. So whatever the data that I send through this text audio file can be captured and you can predict whether a murmur is present or murmur is absent. So the live recording will allow us to connect to the Bluetooth. The live recording will allow us to connect to the Bluetooth and we can listen to the heart and lung sounds and predict if the murmur is present or murmur is absent. So as far as we've come here, what we have accomplished in this product is the audio output path, the Bluetooth integration, and the ML murmur detection, and the final UI integration for the entire system design. So the novel features and IP potential is we have pruned this design on an FPGA RTA700T board. And next we are trying to migrate it to a low-cost microcontroller for compact protection and ready deployment with a custom ASIC planned in the later stages. We did not publish anything yet, but IP filing is planned around SoC designs as the project matures. So why this is important for the Indian market? Whatever the digital stethoscope that are available in the market have a huge cost. As you can see in this picture, we have 70,000 to 15,000. And stating that it will be very difficult for any student or a practitioner to actually put that much amount of cost and buy a digital stethoscope. So that is where we have benchmarked the product to get the target device under 8,000 to 10,000 in India with a real-time filtered auscultation, app recording with cloud-side ML murmur screening and the companion application. So who are the target customers? So the main is the medical colleges and training institutions. Let us say a professor is explaining to us, maybe a student, about the murmur detection and stuff. What a professor hears will not be what the student hears. So that is exactly where this helps. The recording capability will help the student to understand correctly what the professor is meaning to say. The telemedicine and rural healthcare workers and primary care clinics and hospitals. The telemedicine where the doctor is not available but the patient should be diagnosed. There exactly we can send this recording to a Bluetooth companion app and thereby send it to a clinician who is 100 kilometers away. From prototype to clinical grade product. The initial prototype was an FPGA development board with a lot of long cables that we've validated the core concept. And then we had a custom PCB that you can see as my friend holds it on the device. And then we have a final product that we are planning to do with a purpose selected microcontroller and a full minimized enclosure. Single integrated chess piece. Thank you. Our vision is simple, to create a digital future to the oldest tool in medicine. Thank you everyone for hearing us and giving here. Thank you.
So thanks Binary Bandit Sims for making a real doctor assistant systems. Next I am calling Mr. Sam Stabridge. So he is giving the solution for ECG based solution. He is from Neuronics team. He has formed a startup called NeuraWave System Private Limited. He is going to show his live demo also. So please we motivate him by clapping. We are welcoming. Come. Stabridge to the stage.
I will need something to keep there and a chair also.
Okay. One people can be there.
Okay. That should be in the middle.
You can start. They will make that. I will keep it there. Let me keep it there. I want to show.
Yes, sure. You can keep it there.
You want to showcase and then take it.
Yes. So when I will showcase, I will need one person to show the mobile in front of me. Not now, when I will be presenting. I will need a chair also there to sit down and then show.
Chair you want? Okay.
Yes, when I will bring the presentation.
Okay, you finish this and then we'll bring after this.
Sure. So, good morning everyone. I am MD Sam Stabridge and I am the founder and director of NeuraWave Systems Private Limited. Our product name is Tarang. Its full form is Temporal Analysis and Recognition of Anomalous Neurocardiac Gradients. So imagine somewhere in India there's a woman and she is feeling pain since morning in her chest, and there is a cardiologist who is 250 kilometers away from her. So she will do what millions of people do. She just waits till she feels fine. And for millions of people, the waiting is very much fatal. So heart disease is #1 killer in India, taking about 1 out of 4 of all the deaths that are in India. So all of these deaths are preventable just by being seen in time. The devices that we have are very much costly in hospitals. So one single ECG device generally costs around 30 to 70K for a single patient. The rural areas sometimes lack electricity, stable network connection, and access to expertise and cardiologists. In India, we have less than 5 number of cardiologists per million patients. So that's what we are solving. Yeah. So we have developed a device that is solving all of these problems. So first of all, this device acquires ECG signals directly from the patients, and there's a FPGA station and a wireless module. So we have two form factors. The first is the FPGA station. That station costs around 30,000, and it does the classification and disease detection part. And the wearable node is there, which cost around 5,000 to just acquire the ECG data and transfer the ECG data wirelessly to the FPGA station. So in this illustration, we can see that we can have several wireless nodes across the rural hospital ward, where several wireless nodes can be connected to different patients, and all of the ECG data will be wirelessly transferred to the base FPGA station. The FPGA station then classifies all of the ECG data simultaneously, and then will be generating report in the app. So this is the complete system on chip. We are using Vega 801051 RISC-V processor, which is developed by CDEC. And in the yellow that you can see is the Tarang accelerator that we have developed. We have other peripheral IPs also, we have QSPI, because the model that we have trained contains about 1.1 millions of parameters, which are impossible to store inside the FPGA while performing efficiently. So that's why we are storing all the weights outside of the FPGA platform in a SPI flash memory. And to access that, we are using a QSPI flash IP. Along with that, we are using a central DMA to transfer the weights directly to the Tarang accelerator, so that we can offload the workloads of Vega processor. So in our IP, our SoC, the Vega processor is acting as a coordinator to transfer the ECG data directly to the Tarang accelerator. And the main brain of our SoC is the Tarang accelerator. This is the architecture which is inspired from Google's TPU. It contains a systolic array architecture at the core, which does the matrix and multiply application. Then in a single cell inside that systolic array, we have just a matrix multiplication and addition unit. So in the product demonstration that I'm going to show you, I will connect the 5 leads to my body, and then I will acquire ECG data and show it in the mobile app, and then I will generate the report so that we can send that report to the doctor. So this is the UI of that app. You can see here, we can enter the patient details, then we will acquire the ECG data, then we will generate the ECG report, and the last photo is the doctor's dashboard where all the patient's ECG data is there. So we will be generating 2 different kinds of ECG reports. First one is a 1-page ECG snapshot that we get generally in the hospitals. So here you will be getting a 10-second ECG snapshot of your body along with the morphological features. In the full report, you will be getting, along with the ECG snapshot and morphological features, you will be getting a normal and abnormal flags of all of the features and intervals. Along with that, you will be getting a classification class and the scores. Our device also does multi-level classification, which means if you have 2 to 3 diseases in the same patient, then the device can classify those multi-level classes also. Along with that, you will get a reasoning and summary that why that disease is occurring inside the patient. And then in the second page, you will be getting some trends, like some of the heart intervals, like PR intervals, RR intervals, and also heart rate variability and beats per minute. So according to competitive positioning, our device, that is Tarang, stands among all of the. So the features that we are providing is not present in every devices present in the market. We are providing 24/7 continuous monitoring of every patient. The device works with no external electricity power supply. The device is low power, and then we are classifying 8 different classes on a single device. Also, the device costs very low. So per patient, one device will cost around 7,500. So we will be selling the devices for 7,500 per patient, and then For a free version, we will be providing the one-page ECG snapshot report that you will be getting from any hospitals, but a pro subscription, which is a monthly subscription basis, you will be getting the full ECG report, and in your app you will be getting a feature to store that report and then send the reports to the to the doctors for further actions. Thank you. Now I'll be showing the live demo of ECG acquisition. Along with that, one RTX7 FPGA is there. Along with that, a ECG DAC module, which is made using Texas Instruments ADS1293, which help us acquire 3 lead ECG data simultaneously. Along with that, this is the wireless module we have. So this wireless modules runs in a battery, and then it can transfer data wirelessly to the FPGA. So we can have 9 such wireless modules to acquire 9 patients in different rooms, and one data acquisition system in the FPGA station also. So we'll be acquiring 10 patients simultaneously, and we'll be doing the classification of 10 patients. To make this FPGA station work, you just have to connect this with your mobile and it will be powered on. You don't need an external electricity power supply. So you can see here that so here you can see that the device is connected, and at the bottom you can insert the patient details and demographics and then start the ECG recording. So here you can see that the ECG data is streaming in the app, below which you can see the live morphological scores, after which at the bottom you can see the live classification scores. The green line which is showing that the device is confident that I am normal. So whenever you want, you can stop it. So I will stop it now, and then you can generate the report. So you will generate the report, you will get something like this. This is the report, the classification score. See, you can see here, I am normal with 99% confidence scores. You can see the reasoning and summary and some of the trends. So you can get a PDF also and the ECG snapshot. Along with that, you can send the report to the doctor. So whenever you click send the report to the doctor, you will get all the saved doctors in your list, and you can directly send the report to the doctor. That's it. Thank you.
Thanks, Bridge for his medical demo. Next, we are switching over to next team, Silicon Stars. So they are taking LWIR sensor and making a solution for unmanned vehicles. So I'm happy to welcome Mr. Sidambaresh, Sharukesh, and Divya to come to stage and present their product. You can motivate them by clapping them. They are from SRM College.
A warm welcome and a very good morning to all the delegates, students, organizers, and our peer presenters. So we team Sidaspire Private Limited are here to present our idea and solution, the Smart Proximity Alert System with zone-based speed-aware response. So before briefing our solution, we would like to thank a few important persons who help us through this project. We would like to thank Mr. Kotishwaran sir for his guidance and the Shakti team for helping us through this product, the solution that we have developed. And we would like to thank for the opportunity given by Maker Village and the Grand Challenge Hackathon team and the Chip to Startup program. And we'd also like to thank our mentor and our university, SRM, our mentor, Dr. Sudhanya ma'am, for guiding us through this project. So basically, our product, Smart Proximity Warning System, is a technology demonstrator of our core architecture. So we are going to trying to build a foundation for building an ADAS solution in the near future. So what is the problem that we are actually addressing here is, we can see nearly 1.3 million people are dying annually because of road accidents. And almost nearly 2/3 of the fatalities that are happening are among the working age group, that is from 18 to 59 years. So more than half of all road traffic deaths that are happening are very much including the pedestrians, the cyclists, and the motorcyclists actually. So the risk of pedestrians hit by the cars are rapidly increasing too, day by day. So there are various reasons for these road accidents to happen. So one among the prominent reasons for this is the delayed driver response and distracted driving too. So our solution that we have built is primarily focusing on addressing this delayed driver response to the obstacles. So we are trying to build a system that is going to address this specific problem of driver response, and we have built a very small module or a model which is going to be developed as a product in the near future to address the ADAS market. So who are the target users? So we are targeting the original equipment manufacturers, the four-wheelers that lack a proper collision avoidance system, and we're trying to build a low-cost proximity warning solutions for them. So
we'll be briefing through the product demo and the other technical parts of the slides further.
So coming to the solution overview, like our problem statement is an intelligent proximity warning system that fuses a MM-wave radar sensor and a wheel speed sensing. Through those two sensors, we have made an on-chip ML model which uses to classify the objects into the classes into object, pedestrian, or vehicle. This is based on a Shakti SOC, and our key innovations are like embedded ML interfaces, as I said, and also real-time fusion of wheel speed sensor and an radar sensor. Using that, we have achieved a zone-based PWM modulation for adaptive throttle responses. So we have implemented it in a low-cost FPGA architecture. Our main motive is to implement this product in a low-cost market. And you can see the block diagram over there where we have our MM-wave radar sensor. Using that, we have passed the radar data, and we have taken a few feature vectors. That feature vectors has been given to the GBM model, which we have tested and trained by ourselves. We have taken the data set by ourselves, and we have trained that ML model. Using that ML model, we have classified into object, pedestrian, and vehicle. And using that classes, we have made a PWM response for that. And also we have given a LED and alarm for, and also we have given two zones which is greater than 3 meter or less than 3 meter. We have set a threshold of 3 meter in our prototype. So when the object is captured over 3 meter, the vehicle will move with a higher speed, that is 100% duty cycle. When the object is captured less than 3 meter, it is a critical stage, and the vehicle will stop, that is 0% duty cycle. So here's a detailed technical block diagram where we have taken the raw data from the IW6843 and we have parsed it using our parser logic. That is like it will be formatted from TLV format to point cloud format. The point cloud format is a readable format, and from that point cloud format, we have taken a feature extractions, and that features has been given to a GBM-based ML model. Using that model, we have classified our classes into 3 classes, and using those classes, we are taking an actuation over there, and we have developed our own application using Shakti SDK. And we have deployed our ML model into an ML IP in Shakti FPGA also. Here you can see the PWS response for 100% duty cycle and 0% duty cycle based on the threshold we have set, that is 3 meter.
Discussing about the product demonstration, we have a product demonstrating the real-time object detection using the MM-wave radar sensor, followed by the classification of different classes, vehicle, pedestrian, and object. And we have also implemented the zone-based proximity alerts, followed by the actuation on the same, using the PWM duty cycles. And our end-to-end workflow is that first we have acquired the radar data from the radar sensor, and we have converted to the point cloud, and later we have extracted the important features for the ML being developed. We have about some 52 features that are used for training and testing the model, GBM model, which we have developed, followed by we have converted the our ML model to an ML IP and integrated the same with the Shakti SOC, and this takes the action according to the threshold we have set, and we have used the mini-term serial console for our user interface. And talking about the technical validation and performance, we have about 87.93% overall classification accuracy, and we have also trained and tested the same with the 5-fold cross validation with of accuracy 97.74, and we have about 0.99, which is close to 1 ROC AUC score, which is very perfect to differentiate different classes. And we have we have consumed very less power, that is 0.981 of total on-chip power, and we have used the LUT of 86.20%. As you can see in the figure 7, the bar graph, you can see it is of mean closer 97.74, which means that it can detect any unseen data. It doesn't take a guess. It can classify it well.
So here we have, I will be showing the video demonstration of our solution here. So when the pedestrian moves away from the proximity warning system at a range of more than 3 meters, it will stop, and once it approaches, the proximity warning system automatically reduces the speed to 0 duty cycle. So as a pedestrian is present, he is at a 3-meter gap, and if the pedestrian is within the 3 meters gap or within the 3-meter gap, then the LED and buzzer will be glowing, and you can see the PWM completely reducing to 0 duty cycle. Yeah, you can see the buzzer also buzzing. So our future enhancements, we are trying to implement a lane changing logic as well, and integrating it with the multiple sensors to improve the accuracy further. And we thank all the audience and everybody present here for listening to our presentation. And we do have our stall in 6th floor. So please be free to visit our stalls. We can interact and share knowledges for sure. Thank you.
Thank you, Silicon Stars. So next we are going with one agricultural based demo. As we all know, agriculture is the backbone of our country. So we are welcoming Silicon Shakti, who formed a startup with name Irrigate Agri Solutions. I am welcoming Ojashwini Sharma, Prakar Sharma, and Utkarsh Gupta to stage. As I told you in the beginning, this is the second team who are very much interested in occurring things and exploring things. They are actually going to develop their own sensors as well.
Good morning, everyone. So, how many are like plant lovers? Please raise your hands. Oh, nice. I'm seeing my audience. Okay. So, I'm Ojashwini Sharma, and I'm founder of Irrigate Agri Solutions. And here is my team, Silicon Shakti. We are working over to give you the best one-stop solution for automating gardening and agricultural tools and techniques. So, like, if we start, like, how did we came up with this idea? So, going back to 2 years, my mother and my teammate's mother were suffering from schedule balance or something, and they didn't get time to cater their plants. So, they were plant lovers, but they didn't have a tight schedule, and because of that, they were like not able to take care of their plants properly. And also, we being far away from the homes, we were not able to cater the plants and the garden. So as an undergrad engineers, we came up with a simple automated solution like this, as you can see on the screen. And it was just an that monitors the moisture, automates water, sunlight, and the fertilizer as for the starting prototype. Then the words spread through, and our college came to know about our simple setup. So we like move into the problem statement deeper, and then we saw the market. We saw that our device just not only goes well with the potted plant, but also goes with the commercial farms, nurseries, high-value crops, and polyhouse greenhouse. So these operations are on tight margins and are highly motivated to affordable automation that protects their water and expensive fertilizer and save their resources. So what we decided is to dwell deeper, and in that phase, C2S Grand Challenge came in. We saw the first problem statement, that is to monitor the plant care growth, and then we logged in up, build it, and today I can proudly say that we have built our product TRL 6 level ready, and we already have 40 plus customers, alpha customers, to test our devices over in their plants and gardens without any ads and running and all. We just got responses just by hosting the website on the Google. That's it. And I would like to say that the competitors, they already have this kind of solution in the market. But how are we different is that they just give you the insights, and they just give you the dashboard and just give you notification that says nitrogen is not right in the soil, give that, and that's it. It does not automate and care that is very much needed in the agriculture or in the garden. So, and they also charge heavily for the online cloud server and SaaS based charges. But our device is it automates care and affordable and smart enough to cater all the things that is required in garden and agriculture. My friend will now tell you about our product Sichai A12.
So Sichai A12, automated smart irrigation and monitoring system. So it is a multinodal mesh setup that sends soil telemetry data, has edge level processing, and it is almost maintenance free. This is an indigenous hardware built on two processors that we have used. It's Vega ET1031. That is the smaller node that senses, that connects to the sensors and gives us the data. Then we have the bigger node, that is the master node, that has the AT1051 Vega processor, that along with our own AI accelerator processes this data and gives us insights based on this telemetry data. What happens is we get this data and we quantize it into 8 bits, then perform the analysis based on ICAR data that is already present on the device itself. There is no need for cloud connectivity. Then based on what is required for the soil, the nutrients, they get mixed into the soil using the automation nodes. So we have automation nodes that connect to the existing water delivery systems and mix fertilizers that are required and then deliver it. Also, one more advantage that we get from the system is the AI-based crop recommendations. So let's say one season you planted a certain crop, it will automatically recommend you the next best crop based on the nutrient levels in the soil currently. So this is the analysis for the 30 days of data that we deployed this device in our own college field, and this is the 30 days of data that we collected. Then running the analysis on the device itself gives us the recommendation. If we see, it says the current baseline levels are very low and cannot sustain crop growth because it's an open area. It can only support shrub growth. So it suggests us to add some nitrogen, phosphorus and potassium so that we can grow ashwagandha and aloe vera. It will, most of the time, it will recommend higher values or medicinal crops so that the farmer can earn a better income.
And I just want to say that our Sichai A12, which is also not only for the irrigation Sichai, but also it says solar integrated crop health AI. So what I wanted to say is Sichai A12 is not just a node that would stand in the farm and that's it. It would, like a small scale farmer can take the one node, plant it in their farm and take it for map the data for 10 days. Again, it can pull it up and go out another location of the farm and it plant it and can get whole map area. And this is so affordable and portable that a Sichai A12 is a product that every garden and agriculture want.
So you can visit us at our website, irrigate.in. And if you have any queries or anything, you can reach out to us using the form given below.
And all I just want to say at last that every startup starts with a story. And we also started with a real life incident, saw our mother suffering. And no, everyone is now disconnecting from our soil and plant, and they don't know how to take care of plants and gardens. All they just overwater or kill their plants. So irrigate is a one-stop solution from one potted plant to garden to field to farms at minimal cost required. And it also saves the resources, optimizes and affordable, does not charges you subscription. And our main motive is, when your greenery is not great, you are not great. And so Irrigate comes to the rescue because it cares, so you don't have to. Thank you.
Finally, we would like to thank the C2S Grand Challenge and everyone from Vega and the Grand Challenge team. So they supported us a lot, gave us very valuable insight, and they supported us to do this.
Also, our company card has flowering seeds. So when you save the number, plant it in the pot, and you will get to remember Irrigate. Thank you.
Thanks all the teams. So we'll go with a short Q&A session for 10 minutes. So if you have any questions, you can go and ask them in the stalls. Requesting people to assemble here. Requesting all the teams. Requesting all the teams to come to the stage. We can start with the QA sessions.
So hello crews. So I have a doubt based on the defense drone system. So yeah, you have told the drones can be used for the defense drones. So when it comes to the harsh climatic situations and the harsh air resistance, so how will the drone withstand that air resistance?
Hello. Okay. So we are a flight controller manufacturer. So let's say we don't make the drone, we give you the electronics for it. So when your question is about harsh climatic conditions, our boat can survive all types of conditions that it's designed for, right? But ultimately, if you're a startup and let's say you're making a drone for Ladakh, very high altitude, very low temperatures, we have heating sensors, we have heating pads to ensure that our electronics will work. But the drone itself, how the drone will survive the harsh conditions depends on the way the startup decides to build it. We essentially provide the electronics to ensure that startup is able to build drone for any kind of things. Let it be Thar Desert, let it be in Andaman or very humid places, or let it be Ladakh where it's very cold. Thank you.
Yeah, got it.
This is a question generally to all the teams, right? So I'm assuming most of you have used the Shakti and the Vega process, right?
So what were the challenges that you faced, and what else can we do better to help, use our processes for, startup ideas like this? Or to put it differently, what are some of the challenges that you faced when you started using our Shakti process?
So I think us as students, we started off, right? So using an architecture Shakti, it took some time to understand it. And then, of course, we run into small issues here and there. And I would say there are really no big challenges that we face. At best, the challenge we face is that in FPGA, we cannot emulate at the speed that the chip will be at tape out, right? In the FPGA, we can only emulate it at 50 megahertz. But the chip itself will work at 400 megahertz. So we are severely limited as to our capabilities we can show. So other than the limitations of the FPGA, I would say that Shakti processor works pretty well. You just have to understand a few things here and there, maybe a little bit more documentation, because we were privileged enough, because we were from Grand Challenge, that we had sessions directly with the IITM team, Shakti team, Vega team, respectively. But I think if we did not have that, then it would be a little difficult for someone outside to just try. Other than that, I think it's pretty good.
To the team who were developing stethoscope, digital stethoscope for doctors.
Yes, sir.
Yeah, don't you feel that the machine is too heavy for them to carry around, because the current setup that they have, it's just a wire around their neck, but in your setup you had a complete a big box than a machine which takes at the heart, and then headphones connected to it. So isn't that bulky? Can you put it in a small SoC kind of a thing wherein it can just have it around a neck band and make it more usable for the doctors? Because
Yes, sir, definitely we are trying to build the same thing. But since this is a prototype kind of stage, we only could do it on deployment on the FPGA board. Once the project matures, we are definitely want to convert this into, as you've said, a normal, even a normal ASIC kind of thing, which will be even more smaller compared to our pod box that we have nowadays. So it will be very carry friendly for the doctors as well as the students as well.
yeah, I understand. Yeah, that's an answer, and I think that applies to everybody. So you guys have a prototype demo with you, which is bigger, and then when you have to convert it to FPGA, what are your plans? Do you just want to drop this and convert the POC and just hunt for somebody to get you a SoC, or you would, or who are the folks who are trying to get into that SoC mode aggressively, and what are the market challenges you have from converting your prototype to SoC? What is that journey? Do you have any plans around that? I just wanted to know.
So in the Grand Challenge itself, we use the FPGA board. Along with it, we use the Vega old SoC that was available. So we are already trying to move to the SoC level. So like from the support that we got from Vega, it was relatively very easy to build around it. So that is what I'm saying, that we can build around it relatively very easy. It won't be a massive thing.
Yeah, your product was mature. Anybody else would want to highlight their journey from prototype to SoC, or their plans for converting from prototype to SoC?
So we are the team that makes the defense, like controller said. So space is quintessential when you are flying. We cannot have such a big FPGA, right? So for the competition, we had to show within FPGA. But currently, we are already having designs which have a SoC at the center, because we know what is going to be the dimensions. We know what the pinout is going to be, right? We have talked to the Shakti team. They have told us what the things are. So we have already designed for it. All we are waiting on is right now, almost all the teams who are working with Shakti are waiting on the actual chip out to come out, and we expect it to have the chips with us by the end of this year. So when we have those chips, we can actually move further along, and we can actually push to TRL7 very easily. So everything around that, we are already creating. FPGA is just for demonstrating that we are actually able to do it.
Understand, yeah.
Yeah, sir. Actually, I am focusing on little bit on SoC because it is cost effective. Further, if we are going to expand our product to the next level, and also it is going to catch up our market. So that is what we are focusing. We need to work on that.
Good. So happy to know that you guys have plans to go to SOC and you are trying to overcome the challenges associated. Big thanks for that.
Thanks. As we are running out of time.
I have a question. It's for the agri-tech team. Especially for the, it's a great thing you are doing for the farming and plants. So it will be good if you can, that is critical, right? The input data of whatever you collect for the different plantations, what kind of soiling is required, what kind of, you guys can hear, the agri-tech team? You guys can hear?
Where are you talking?
Yeah, so it's basically the data what you're getting, the inputs what you get for the different kind of plantations. India is a very vast country, right? Every gardening or every region, every plants require different kind of data. So what kind of data you're getting? What are the inputs you're collecting to inculcate in that for the AI model? That is what my question is basically. Have you done what is the sources of the data from where you're getting this data and how these sources are collected and how accurate they are? And especially because the accuracy is important for the plant's health, right? Or the garden's health or the farm's health.
So for the data, we are looking for the ICAR data and Food and Agricultural Organization data that they provide for plant health. And further, for the different varieties of soil in India, similarly, ICAR has provided data for that also. We are using that only. Then comes the nutrients that we are checking in the soil. For the prototype, we showed with NPK, nitrogen, phosphorus, potassium. We used pH, EC for salinity and soil moisture content. Then for the surrounding, we take sunlight exposure, the temperature, the humidity of, around the plant.
Thanks team.
A small feedback, sir. So small feedback for you guys is if you can just also have some kind of tie-up with the organizations which you're working with in the back end, so that whenever any people would like to utilize your products, they can have flexibility to reach out to these organizations so that they can quickly test their plants or the soils and everything and come back and help give the feedback. It's become a complete full loop for the users and also the people who are providing this data.
Sure, sir. Like we are striving for that only, and your feedback is valuable for us. Thank you.
Thanks for a huge response. As we are running out of time, we are closing the session now. Please visit the stalls and ask the questions and motivate the people. Thank you, all the teams. One photo they want to take one photo.
What an exhilarating showcase. This caliber of innovation we witnessed is truly inspiring. Let's have one more massive round of applause for all 13 teams. We wish them the very best of luck for their semiconductor startup journeys. We are now officially in the AI era. From simple circuits to complex agentic infrastructure, AI is transforming various aspects of our daily lives. However, India presents a unique challenge from a system building standpoint. Use cases such as governance, law, education, and healthcare require data analysis capabilities that can operate at scale, while the resources available to build, deploy, and manage these systems remain scarce. That is the theme behind this upcoming panel discussion. We are now going to hear from the experts on how RISC-V can help solve some of India's AI challenges. Quick note for the audience, lunch will be started to serve from 12:30 to 12:45. To moderate this conversation, we are privileged to have Professor Gopalakrishnan Srinivasan, Assistant Professor at CSE Department, IIT Madras. Dr. Gopalakrishnan is currently an Assistant Professor and Narayanan Family Foundation Fellow in the Department of Computer Science and Engineering at IIT Madras. He received his BTech in Electrical and Electronics Engineering from NIT Calicut, Masters in Computer Engineering from North Carolina State University, and PhD in Electrical Engineering from Purdue University. His research entails developing bioplausible or neuromorphic machine learning algorithms and hardware architectures for energy-efficient neural computing and secure processors. Gopal has also had a distinguished career in industry prior to venturing into academia. He has worked at Cirrus Logic, NVIDIA, MediaTek, and Apple in the US, and as an architect and designer for machine learning applications. He subsequently moved to India and joined Mindgrove Technologies, a startup specializing in RISC-V based SoCs. He currently serves as their lead architect and consultant, responsible for driving the architecture and design of a multi-core SoC for vision applications. He is also part of the RISE Lab leadership and the Shakti processors, and is instrumental in the development of the Shakti processor ecosystem.
Please join us in welcoming them. First we have Sharan Srinivas Jagatrakshakan, co-founder and CTO of Mindgrove Technologies. Sharan is the co-founder and CTO of Mindgrove Technologies. He holds a degree in computer science from Anna University and masters in computation science and engineering from ETZ Zurich, where he specialized in high-performance scientific computing. He is currently pursuing a PhD at IIT Madras under guidance of Professor V. Kamakoti, with research focused on approximate computing for edge vision applications using RISC-V ISA. Sharan began his career at Lucid Software Limited, developing machine vision pipelines, GPU accelerated computing applications, and X-ray CT solutions for the non-destructive testing industry. Over the years, he built deep expertise in high-performance computing, computer vision, and system software. In 2021, he founded Mindgrove Technologies with Shashwat TR. While building advanced hardware system, the founders realized there wasn't an Indian commercial processor that met performance requirements. Rather than compromise, they decided to build one themselves. This became the foundation of Mindgrove's vision building world-class silicon from India. As CTO, Sharan has led architecture and development of company's silicon portfolio, including Secure IoT, India's first commercial-grade high-performance microcontroller, helping establish a significant milestone in India's semiconductor ecosystem. He is a strong advocate of software-driven co-design, believing hardware acceleration should only be pursued when software optimization reaches its limits. Outside of work, Sharan enjoys exploring emerging technologies and is always eager to discuss the latest developments in computing, semiconductors, and AI.
Next, please welcome Chitra Hariharan. Chitra Hariharan is a serial entrepreneur and techno-commercial leader coming with rich industry experience with a unique mix of corporate companies and startups in the electronics and semiconductor domain. Currently, Chitra is heading startup collaborations, university relations, and government affairs at Renaissance. She serves as the secretary for the prestigious industry body, VLSI Society of India. She has had 2 leadership stints at Intel and successfully built 4 semiconductor and electronics product startups, being part of the founding team carrying out technical, commercial, and operational roles. All the 4 startups, Intel Microelectronics, Open Silicon, Concept to Silicon, and Sensopt, had successful exits. Chitra is the proud recipient of the Women Achiever Award by VSI and star of GCT Award from Government College of Technology, Coimbatore.
We are also joined by Lavanya Jagdishwaran ma'am, CEO and founder of Yoma Systems. Lavanya Jagdishwaran ma'am is the CEO and founder of Yoma Systems and an official RISC-V international ambassador. With over 15 years of experience in processor verification, she has worked with leading semiconductor organizations including IBM, ARM, and Rambus, contributing IBM Z, ARM Microtex M, and RISC-V processor development. She currently leads processor verification initiatives at Shakti Group, IIT Madras, and is actively involved in advancing India's open source semiconductors ecosystem. She holds an MS in Computer Science and Engineering from IIT Madras.
And finally, we have Professor Kunal Kurgaonkar, Assistant Professor in the Department of Computer Science and Information Systems at BITS Pilani, KK Birla, Goa campus. Professor Kunal holds the Assistant Professor role in the Department of Computer Science and Information System in BITS Pilani, where he leads the Confluences of Computing Lab. His research focuses on next-generation computing systems, AI, computer architecture, and emerging technologies with applications in with applications in healthcare, education, cybersecurity, and sustainable computing. Professor Kurgankar holds a PhD in computer science from the University of California, San Diego, UCSD, an MS from IIT Madras, and has completed postdoctoral research at the Technion, Israel Institute of Technology. He actively collaborates with academia, industry, and government to translate cutting-edge research into impactful real-world solutions, contributing to India's growing deep tech and semiconductor ecosystem. Over to Gopal sir to continue as session chair.
Good morning, everyone, and thank you for the kind introduction, Arshad. It's always a pleasure to be among bright young minds whom we want to inspire and provide useful insights. So I'm very excited to be moderating this panel. What is even more heartening for me is we have 3 of our Shakti alumnus, right? Sharan, as was introduced, is Professor Kamakoti's PhD student.
Technically not yet an alumnus, but hopefully we'll get
soon
there.
to be alumnus, okay. And of course, you have graduated from a startup standpoint. You'll soon graduate from, hopefully, with the PhD standpoint also. Okay. And of course, Lavanya is a product of our lab. Professor Kunal is a product of our lab. So it's so heartening that we have such distinguished people. Okay. And anyway, we'll get started.
Just to add to what Gopal said, sorry to interrupt, your introduction started with RISE. I take pride in telling the first RISE lab check was personally handed over to Kama at that time I was at Intel Microelectronics. I take huge pride in that because that is the one that created so much of transformation for India. So thank you, Gopal, for having me.
Yes, thank you for reminding that. So, Ms. Chitra is also now a part of RISE now. Okay. Okay, so the topic for today is, of course, can RISC-V address India's AI challenges? I mean, that should ring a bell, right? Usually the way we teach computer architecture is, of course, CPU should be good for general purpose applications. Okay, you have scalar core, okay, you eventually make it super scalar, out of order, and so on. Even when I teach my course, I said, okay, when you move to AI, you should build, a specific class of special purpose hardware that works very well for a niche class of applications, right? Of course, we have GPUs today, dominant by 1 or 2, incumbents. So that should ring a bell. Why are we talking about RISC-V of all things to address, of course, India's AI challenge? So I'll start with, 2-point. What I feel are the reasons. Of course, I'll get our opinions also. One is, of course, RISC-V is based on an open source instruction set architecture that has been, emphasized multiple times. So it's out there, and then anybody is free to develop a processor or a system on chip and complete product using RISC-V based chips, right? So that is one advantage. And even within the processor community, there's always specific extensions that have been proposed to work well for different classes of applications. So one such is the vector extension in RISC-V, where a single instruction will operate on multiple data points, and of course a RISC-V foundation is in the process of ratifying a matrix extension unit also. So which means that very soon we'll have RISC-V based AI solutions that are compelling, and of course we have startups like TensorRent, which are already championing complete system solutions built out of RISC-V, right? So essentially, there is an example to show that RISC-V can be used for AI solutions. So the real perspective here is where are we right now? We'll try to get the landscape, and of course we have people who have served in the leadership position. We have people in academia. We also want to find out what are the technical challenges in building the entire stack, or what is that entire stack going to look like? And of course, the leadership position, how do we reach out and let's say commercialize or get multiple users for the solutions we are planning to build? And of course, with Kunal, we want to find out where does or how can academia play a big role in championing that adoption, right? So RISC-V, as Professor Kamakoti also mentioned, has been adopted as a national ISA. So hence, there will be a strong push from the Indian government as well as hopefully the investment ecosystem to support RISC-V based development. The real question is to survey where we are and what do we need to do as different aspects to be able to have this complete sovereign or indigenous solutions, and which are compelling also. So with that as the context, maybe I'll start with, of course, Sharan. Sharan, I've been knowing him since 2023. So I decided to move back and I shot an email. I was very inspired by what Professor Kamakoti's team has achieved. So I emailed only two people. One is, of course, the CTO of Mindgrove and the CEO of Incore. And I eventually joined Mindgrove, worked there for some time, and still continue to have an associationship with them. So it's also, formally communicating what we have been discussing for a long time on how to really build. I mean, I've spent a lot of my time building special purpose compute, which probably Sharan doesn't want to do. Maybe he'll share his perspective also. I tempted him multiple times. He said, no, I will only do RISC-V, not even custom and so on. So let's first understand what is the RISC-V landscape in India looking like, okay, because they have a successful tape out, they have gone for production, and they have multiple RISC-V based solutions in the pipeline also, I assume. So why don't we start with just your take on the landscape of RISC-V technology creation and adoption in India, and then we'll take it from there.
Thanks, Gopal. Definitely thank you for that introduction. But let me just give you an overall setup of software systems and hardware that solve a problem to set context so that we can have a discussion in that context, since I've been the first one who's allowed to talk. So the thing here is that every time you look at a problem that is digital or can be solved with electronics, you look at three things. You look at the hardware that will solve for it, you look at the software stack that would solve for it, and you look at the ability of the user to very easily pick it up and utilize it in the field in order to solve whatever they want to do. And that, so there are three aspects to it. The first is the hardware, which is where RISC-V comes into play. Then there is the entire software stack, the compiler stack, the operating system stacks. And if you're looking at specialized industry with specialized needs, like the automotive industry, for example, I think this was briefly touched upon in a keynote yesterday. There are specialized software stacks called AUTOSAR. There are specialized operating systems that are certified for specific use. And these things, while are already available on x86 and or ARM as appropriate, the question is it now available for the RISC-V scenario? So that is a context that needs to be established, and that discussions need to be taught in that thing. The third point, and this is where I'd like to introduce the topic of today's discussion, is the ability of a user to take both software and the hardware and deploy it in some scenario. We just had a session with a whole bunch of student teams solving different things. And the key thing that sells is you buy something when it solves your problem, or you buy something when it takes care of something that you don't want to do, essentially. So the context of AI and RISC-V should be set up and discussed, I suppose, in such that how does it make it easier for us to adopt software, hardware, or utilization? How does it make it more convenient in that if it takes, say, 20 hours to do something today, can the combination of hardware and software tools help us get it done 5 hours, 1 hour, 5 minutes, as the case may be? And the classic question in India, is it cost effective? So that's the context that from which everything Mindgrove does comes into play. And there is this saying that we've given a lot to investors when we did our seed round and Series A round. We deployed this phase called software-driven co-design. A lot of academic institutions know this thing as hardware-software co-design. This is where you develop the hardware while you are developing the software and they play into each other. This is slightly different, slightly more lazy, where it says the basic principle is that if you can get away by doing something in software, then you have no business doing it in hardware. And yes, I am the de facto engineering head of a hardware startup saying that if you can get away doing it in software, do it. Because software is just that important. Software gives you a level of robustness and versatility that hardware never could. And it is much easier and much faster to turn around software, to adapt software than it is to do hardware. That is both a blessing and a curse in the context of AI. And so Mindgrove's products, the first product that we built is Secure IoT. Secure IoT is how we called it when we built the first chip. Secure IoT is now a whole class of processors which will going forward be known as the S-class series. Of which the chip is S2401. It's a classic old school crossover MCU, very general purpose one at that. It has a RISC-V CPU, the Shakti C-class processor, classic 6-stage with branch predictors and all of that, runs at 700 megahertz. And in our stall downstairs today, we have an application for, we call it automatic number plate recognition. That is running on a 700 megahertz microcontroller unit that costs less than $5 depending on how much you want to buy it in bulk. So that creates the context that I would like to speak in for this whole topic, which is you can't look at AI as AI, that's too broad. You have to look at it as the so-called LLM layer where your Claudes and Geminis and ChatGPTs and their underlying models live. And then you have to look at it from a mobile layer, which is what I kind of think of as the mid-grade. You do advanced stuff, but not as heavily advanced as what you would do with Claude and Claude Code and all of that stuff. And then you have the tiny embedded layer where you do keyword detection, proximity detection, time series analysis. An example was said by in the keynote yesterday by Dr. Saurav Roy, where he's mentioned that they were experimenting with analyzing the thermal factors and parasitics of chips at NXP in real time. Now that does not need a very, it does not need an NVIDIA GPU. It barely needs a compute unit. And the context of how RISC-V comes into play and the context of how India plays into it, I think, should be looked at that from each of these three buckets, at least according to me. And we have to go, and everything has to be dealt with separately.
So thank you, Sharon. I think the many points that you mentioned, which we'll revisit in the course of this discussion. So I'll go to Chitra Hariharan next. So you have been in leadership positions trying to build, let's say, companies, some teams from scratch. So I'm pretty sure you've been in this position of trying to, so you have incumbents, you have been using a solution for a while, and then you are going to pitch in a new solution. So with RISC-V, the typical things I hear is adoption, right? I already have the company has been working with a certain system on chip for a while. So what do you think needs to be done? Let's say I have to prepare a compelling solution I have. So when you build teams, talk to customers, is there an inertia, or how is the landscape to pitch in and promote a new solution? I mean, you can take RISC-V or in general also, because I feel one is the technology part split across a stack, and a whole different ball game is how do you now pitch it in when you have incumbents and companies have been using it for years to say, oh, have a compelling product and the necessary stack, assuming. Is there still inertia, or what is the challenge If we understand it, I think there is some, since we have startup teams also, right, we'll understand more as to how to pitch in a solution, right? So.
Sure, Gopal. Thanks for asking that question. See, the incumbent displacement part, right? Like, I mean, I'll handle it this way. That definitely comes with a challenge. The first time when you go and sit in front of the customer, right? Like, I mean, you want to sell the technology, right? You want to sell the technology, that comes with challenge, definitely. But it's up to you to turn the challenge into the opportunity. That's where the secret sauce lies, right? So it's sensing the customer needs and then giving a spin that customer is expecting, right? That's the theme that I would pick on, and then I'll come to how the technology is shaping up and then moving towards and stuff like that. So just on the technology part, I'll have the answer split in three buckets. One is technology, then other one is people, students actually, and then the products, right? So just on the technology part, I would say we've been living in this world of Edge AI, Gen AI, and everything. In all these things, it's okay to stay with certain compromises, I would put, right? Now we are entering the world wherein yesterday we heard from Gokul, the physical AI world, right? Like, I mean, wherein the compromises cannot be tolerated, right? The low latency, the requirements at which each of the physical AI things need to act, right? I mean, so the whole system approach and everything coming together is what is required. So what does this brings as an opportunity for the RISC-V ecosystem? Very much the compute getting into the physical AI. Let's just pick up maybe a robotic arm or a dexterous sensing, right? Like, I mean, so wherein you need compute, you need sense, you need actuate. So all coming together should work seamlessly to require what you want, right? I mean, so that's the world that we are already in. So in terms of the opportunities, yes, there are huge. Challenges, yes, making compute, sense, actuate, all working in conjunction with each other is going to be the theme that we need to be dealing with, right? So that's on the technology part. Just the technology landscape I just touched upon. There are humongous things, right? But that's the physical AI world. On the people and student requirement, I would say, I mean, we have been talking about this industry ready. There are huge opportunities for each of you, just in the RISC-V space itself, right? I'll just touch upon very top level 3 things. Most of you would be part of it. I'm sure most of you are part of VLSI Society of India's drive of One Tops program, which is really making the students get to the one tape out per student. Students getting industry ready before they graduate, complete the tape out. How many of you are aware and how many of you are part of the One Tops team? Okay, some of you are there. I can explain more about it. I mean, you can get back to me in LinkedIn and then I can talk more about it. So that is the opportunity that we are providing. The bodies like VLSI Society of India are providing to student as a community. And companies like Renesas are coming up with some program that could be adopted at the university level, at the student level. Renesas has come up with one such program wherein you would be given kits, you would be given PCB design tools, you would be given the curriculum also. With that, students are enabled completely to face the industry challenges truly while you are studying, right? I mean, that is the people and student part of it, I would take it. And then on the product, I mean, it's the, Sharon is already building, it is the age of building sovereign products, right? And it has to happen from here, right? All of us have been waiting for this moment. There is humongous enablement that government is providing, that every other MNC is also providing. So it is the time to collaborate and build sovereign products. I think I'll stop here and then we'll take.
So thank you, Chitra. So I'll come to Lavanya for the introductory comments also. So you have been at technopreneur, if that's the right word, and we have done both technical products and pitching it to customer centric. So based on your interaction, what would be your take, first of all, on the level of RISC-V adoption, right? And second is, how much of AI is already, let's say, present in some of the RISC-V companies you have interacted with, right? Again, similar to what Sharan is saying, just to understand what is the landscape now. So I want RISC-V to solve AI problem. I want to understand where is RISC-V from people who really, work with customers.
I think RISC-V was a consequence of having a lot of CPU architectures that were proprietary. And the learnings from there and the need for having a common open architecture, which helped bring together a lot of community who were already experienced in the CPU domain. And for them, it made sense to make RISC-V open and collaborate together and bring relevance in the CPU market. The interesting thing here is we have a lot of proprietary AI chips, incumbents, and other things. But it's not a consequence now. The RISC-V architecture is open to explore for this market also. So that is an interesting place where, like, from the context perspective, we have experience as a startup that enables semiconductor companies' chips to come to market. So they have provided the challenges as use cases and other things. We come before the chip is made. So when a RISC-V chip has to become relevant for an AI market, and they mention that it's software driven, software hardware co-design. So that is where the architectural exploration from the technical perspective comes into picture. So before even you design for it, okay, you decided that this is the market, this is the software, this is the model that might be used. So is your hardware ready for that? Is it efficient for that? I am just only touching one part of it at this moment. So the architectural exploration that comes in before even you decide on a solution, I feel those are all things that can be easier in a RISC-V world because we have a community that is working towards it. So a larger part of your exploration is community driven, and the customization and your magic sauce of a semiconductor company becomes that you explore and then fit into the market. So that is where I feel RISC-V plays a major role in an AI.
Yep. Thank you. So I'll come to our academic peer, Professor Kunal. So for the introductory comment, I would like to hear from you. Of course, in IIT Madras, we are running this RISC-V Knowledge Center of Excellence supported by MIT. And of course, we conduct training programs and so on. From your perspective, is academia doing enough to, of course, RISC-V has been also announced as the national ISA. Is academia doing enough to imbibe the governmental push? And let's say if that were the case, almost a lot of architecture courses should involve RISC-V, because if the startup is ready, government is giving a push, I think we have to teach that also. So what is your take on where academia is in terms of, let's say, using RISC-V for pedagogy? Are we doing enough? Are we there? Or do you think something more needs to be done so that we get people to work for, I don't know, Chitra's company or Sharan, or do they have to do the pedagogy? So what is your take? Is academia doing enough?
Yeah. Hello. Thanks. Thanks for inviting me. And see, I will start with, as an academician, I'll start with basics, right? What is Compark? Or what is system design, right? We have, and this is what I try to follow as well. We have to see what is that technology can offer, right? So we had transistor scaling, right? And now we are saying that it is plateaued, right? At one end, you have to see what technology offers. At the other end, you have to see what is the software demanding. Okay, so these two things we have to put together. So, what is this debate? I don't want to go into debate of special purpose versus general purpose, right? We'll figure out the question of what is, so the need. We have to set up the need clearly, that we know what is the technology offering and what is the need of software. Now AI is solving a lot of problems on the need side, right? But we have to fill this gap of what the technology offers and what software need, what are the software needs. In that context, now the question is RISC-V offering what we need? Is it offering the components that we need? So my take on this has been that I'm part of various consortium projects. There are other government initiatives like AI Center of Excellence for Health, Smart Cities. There are other verticals that government is pursuing. In that, I will like to get the focus on, see, on one end you have what a human can do better and what a machine can do better, right? So again, that is where also AI is questioning. And then the other side, you have scale and sustainability, right? What I believe is, if you have machines, cost-effective machines, then you can get to scale. You have cost-effective machines, for that you can get to scale. And I think the companies are rightly placed in terms of they want to be sustainable, right? So they are solving the human question for being sustainable. So what we see is, what RISC-V can offer is, ultimately it has to offer cost effectiveness, right? We have to get to cost effectiveness, and companies are currently placed in terms of they have to be sustainable. The ecosystem has to be sustainable. So then I'm just setting the context that RISC-V should be positioned to, as I said earlier, to satisfy this need, the software trends and what the hardware offers. And it should create space for companies to be sustainable, but at the same time, machines will become more capable, and through that we could solve some of the societal challenges with scale, right? So that's my opening remark.
Okay, thank you, Kunal. So we'll get back to the first round, where I'll take from what both I think Sharan and Chitra mentioned, that of course if you take AI, you can talk about training these foundational models, which requires today almost GPU monopoly, right? So that's where training happens. And even if you say few companies are building foundational models that you train with proprietary hardware, inferencing is commonplace. All of us, for various reasons, use AI in our day-to-day lives. And AI inferencing, again, you can do at scale, where, okay, I want to build hardware that serves these foundational models. But as Professor Feynman said, there is plenty of room left at the bottom. I think that's where Sharan and Chitra seems to come in, where, okay, let's say start with the solution, right? That's the part I like. It's not like, okay, I'm building hardware for AI, but your perspective is, I am solving a problem. I'm using RISC-V as an enabler. It may or may not use AI. We'll stick to that part. Okay. So the three things that you mentioned, right? One is the hardware SoC. Second is you have the application, and in between you have the tool chain. Of course, you can do algorithmic optimizations and so on. So usually my understanding is, you can also define whether Mindgrove is product company or hardware company and so on. We have had this discussion also. But usually when you approach customers with your SoC, at least I've seen that customers might say, this is our application. You run it and give us whether, first of all, your SoC can meet these standards or not. Let's talk about small edge applications. But your perspective was, you could also optimize the application and tell your customer, hey, this is what you gave me, but I can do a much better job if I were able to do hardware software co-design. That is our software guided hardware design, okay, whichever way you want to put it. So that is playing the lines of Apple, right? You are playing the Apple game, that you are saying that the best performance undoubtedly is obtained when you control all the layers of the stack. Do you have that privilege when you are, let's say, SOC provider? I know that with RISC-V solution, you don't always need to have, let's say, every extension possible. Your solution has to solve that problem, right? So do you have the privilege to control all the three stacks, or you are bound by just one or two of those based on your experiences until now? Because I think that will add value to when you have startup teams here. How should they position themselves, right? So maybe you can, we'll start with the edge, plenty of room at the bottom, but how difficult is that also, right? Because when you control everything, you're fine, but what is the scenario out there?
I would say it's a 50-50. Because we have a whole pipeline of customers who are very happy to let us do all the work. They'll take and deploy. We are also happy to let them allow us do all the work, because we can give that optimality, as and Professor Kunal put it, cost effectiveness can be brought into play at that point. But there are also customers, something that you raised and Chitra briefly touched on, is that there is this thing called a legacy. And there are that's the other 50%, in my opinion. There are people who already have a pre-existing stack, and that stack, quote unquote, needs to be ported onto the current system. Now, that's where interesting questions start to come up in the game. And that's the basis from which we've been having that long-standing argument. So the question now goes like this. An application a customer has some software that they have already deployed in a legacy system, and they don't want to change it. They're okay with looking at new hardware, they're okay at looking at new ISA, as long as that ISA makes it cheaper or makes it more comfortable for them to deploy, or something or the others. There is some value. But I have this whole existing stack that I don't want to change. And this question comes every other day to us. So what is it that you can do? There are two sub-aspects to this. If your code is native C++, as an example, or native Rust, then it is essentially a recompilation process to your platforms, the ISA that your platform supports. That's, relatively speaking, significantly easier to do. But if you have a system, and we've seen examples of this, where the customer, let's say they run on a platform that has an ARM core running on the ARM ISA, very small embedded platforms, and don't have too much memory. The traditional practice is to write software straight in assembly language. And then you have a problem. In terms of porting, you do have a challenge, which is why Mindgrove also does software, because that is the point where we can come and give them equivalence. Okay, I see that you have a problem, and commercially speaking, you have sufficient volume where I can, deploying my chips or my systems to in your use case makes it viable for us. So does the effort of porting helping you and supporting you, or outright porting your software for you, does it make it easy for you to port? And can I just plug and play with your existing system? So that part of that is a challenge, and that's why Mindgrove does software, at least one aspect of it. And that is also why we are Mindgrove Technologies and not Mindgrove Semiconductors. We are fundamentally a systems company that so happens to build silicon. Whether we make the entire system or not is up for question. We are quite happy to sell just the chip if you want it, or a PCB if you want it, and you do the hardware, very happy to give the support. Or if you want us to build a full turnkey solution, in very rare cases where the business use case makes it viable for us to do so, we're quite happy to do that. And that's where the conversation we've had. This is the reason why I generally vehemently disagree to do custom extensions that RISC-V allows you to do, Because if you're having custom extensions, you have two problems. First thing, as an engineer, I have to support the compilation stack for that custom extension, and I have to maintain it. That means I have to provision that many more people to do that. Right? That increases the cost, and therefore that translates into the chip. The second thing is I need the people to do that. Getting the people to work on an LLVM transformation layer is not that easy. Therefore, the ideology over there is stick to what GCC and Clang can already do, which is the ratified RISC-V extensions. And when there is ratified RISC-V extensions, other ecosystem players, as appropriate, can also talk because the top-level setup is ratified. And this also touches on the point that Chitra was making about people and talent. It is every architecture course, every computer science course does talk about compiler design and compilers in general. And everybody is familiar with GCC, G++, and everybody is familiar with the Clang compiler. So instead of march ARM, if you switch on the march RISC-V flag with the appropriate ISAs, that makes it all that more easier for us to get the talent to do the software, for our customers to get the talent to do the software, and therefore it allows us to go to the customer and say, hey, look, standard GCC will actually work for you in this case, so pick it up. There is a downside to it. There are cases, again, in automotive where a lot of legacy still applies. That's where a lot of assembly kind of work is done because of extreme hard real-time constraints. And there, the challenge still exists. Although I would put my neck out there and say it exists for now. It will be solved.
And you do agree that there is plenty of room left at the bottom because we have a lot of product teams, right?
There is plenty of room in the bottom. Okay. So you saw 13, I think 13 teams were there and they did 13 different applications. And a lot of them used AI. There are at least 3 ways in which you can solve AI. In a larger scale, you could deploy a systolic array to do some very specific dense mathematical operations. You could use data, feed it into a cloud-like scenario, use the classic NVIDIA GPU setup that we are using today for Gemini and all of that stuff. Or if you're going to do some basic processing like time series analysis, anomaly detection, etc. at the very edge, you could use a microcontroller where you can write CPU code, let's say enabled by vector extensions, and implement that. So there's an enormous scope. Question is, what is the problem that you're solving? And what are you allowed to and not allowed to do? That's what defines it.
Awesome, thank you. I'll come to Chitra now. So I think, as Sharan says, once you have a solution, the fact that a software can be ported over with a switch, does it help, or what is your perspective? Does it lead to widespread adoption, or is that the way to go about it? Right? Don't do something very, very custom. Just have a solution, of course, a product that works. But then the software story is very, very important as far as adoption is concerned. So, what is your
100% agreed. Software story is very important. I would put the answer in 2 ways, Gopal. If I am wearing a hat of a startup person, right? Sitting like Sharan, the first thing when I go in front of customer is I would have identified his pain point and I would be having the solution in my hand when I enter the room with the solution, right? That's how I would approach as a startup. And I understand that customization is the one that would stand out and then he would get huge benefit because what is that he wants to sell to his end customer or to the entire world is the differentiation piece, right? So that works very well in the startup hat. I mean, I can do the quick customization and then I'll be able to look at it and then get away with it, win the customer, win the differentiation, win the socket, all can be done, right? As a startup person. But when I sit in the MNC, right, it gives a different kind of challenge, right? Because I'm not going to one customer or I'm not going to 3 customer or 10 customer. It is multitude of customer wherein the standardization becomes the requirement, right? So that's where whatever that I do with RISC-V, whatever Sharan explained, on the software side, on one popping up and creating the issue, how do I resolve that and everything, right? Getting that answer and providing a very convincing thing for the customer base is the most important thing. I'm a very positive person, Gopal. I would say that over there also, you can turn the challenge into opportunities of creating a standardization for this set of application, form a team, get it out, and then go in front of those customers, right? That's how I would put it.
So I'm glad you brought up that point, because as you rightly said, there's a difference between when you are operating as a startup versus an MNC. I think there's a very famous Jim Keller story where Jim Keller goes to ARM and said, we are going to do this in AI, please support int8 or some low precision format. So ARM's response is like, yeah, we'll do if our customers want it. Jim was puzzled. Oh, I'm your customer, dude. So what are you saying? So as I said, the real story there is when they meant customers, they're talking about big MNCs where you have to, as a company, figure out what a whole bunch of customers want to do rather than doing something specific, which is where I think the startups come in, right? They have the ability to do customized solutions.
If I may interject for a short thing, that's also where RISC-V comes into play. For an entity that operates at the scale that a company like ARM operates in, by necessity, they have to have a set of 2 or 3 customers who will give them the scale necessary to justify the investment into that kind of a thing. And with RISC-V, that entry bar goes down because it's an open standard. You want to make it in a certain manner, okay, take RISC-V, implement the ISA, be done with it, and if you can convince somebody to fund your tape out, then that's it, right? So I just wanted to add that.
Sounds good. So I'll go to Lavanya. So of course, both Sharan and Chitra have talked about product solutions, right? Of course, I know your startup takes care of one aspect of a RISC-V system on chip solution. So I also want to know, let's say if there is interest in, of course, the whole, we have talked about hardware, even within hardware there are multiple levels. If you take software, there are multiple levels. If you take the tool chain, between hardware and software there are multiple levels. Is there enough room for players not only at the, end product level, but have expertise like what you have created in specific aspects of the, let's say, this 5 SoC pipeline? Is there plenty of room, or what is your take on?
So I think whatever they tell us challenges, as Chitra told, it becomes opportunity for us. It's a direct problem statement that we as startups should solve, or as students, it becomes a research topic. So customization is a problem. It is a problem because the pace with which we want to solve it and the standardization that is required for that is not there. That means that is a problem statement, that how to quickly build that confidence in coming from the spec to the solution, and if it makes relevant to the market that is there. So the first question, of course, is the business question, where if is it even relevant that a customization is needed for that particular customer or tens of customers. If that is the need, so that is something a business person decides. If that is the need, then the problem to be solved is how to quickly bring that into market and make it, bring that into the tech within the company and then solve it. So in that regard, yes, we have started out as a verification solution provider in the RISC-V space. But as we see that if we only solve one thread, it doesn't work. As rightly said, we need the whole, if we say that we want to be partners for semiconductor design companies to go from their design to their tape out as quickly as possible and solve the customer solution as quickly as possible, then we have to own each and every part of that flow. So, and in each of that, I feel when AI comes into the picture, it has a different ballgame that makes our life also interesting. So I'm waiting to see a RISC-V chip designing its own next generation of RISC-V chips.
Okay, I'll come to Kunal. So one theme, if based on our interaction with the industry people, is they want system designers,
Yes.
right? So we have courses in architecture, we have courses in compiler,
Yes.
we have courses in algorithms, applications, but looks like the real need is the ability to put, everything together. So do you think that's something that academia could take up so that we are creating the right workforce for people who are going to be working in some of these organizations, right?
Yeah, thanks for the question. See, a typical CS degree, right, in the top institutions, right, or the state universities. The question is our degrees, our curriculum, do we have to make drastic changes to them? I don't think so, right? So the core of CS curriculum or EEE curriculum, if you set up a committee to review this, they will come back and say, okay, they will make some minor changes here and there, but the subjects have not become irrelevant. What is needed, in my opinion, is training of students in a way that they can work together in a group. So we had so many of these interesting projects, right, being shown. So what I tend to do, for instance, is have motivate projects where the end need is clear to the students right from the beginning. What is the end need? What is the problem you are trying to solve? And then how to put the pieces of technologies together. And so students would come from mechanical, EEE, CS, and form groups and create solutions, create products to solve solve the particular problem. Now the question is, can we do it at scale? Can academia do it at scale? That is where some of the programs that Ma'am Chitram she mentioned, right? We need to have programs where students form teams and they can come together, address challenges. And this two things I would like to add, the small models versus large models. I think there is lot of scope for small models, right? And lot of unmet needs, societal needs in healthcare, in agri can be met. And lot of, once the products are built, they will be able to find customers, they'll be able to find takers for that. And in that, there is a big role of our RISC-V, right? Because for them to, they would not be able to put, like, say, an ARM. They will not be able to buy an ARM license, right? That is where the role of RISC-V comes. The other part, I think, where RISC-V, and again, I'll talk about academia as well, is, see, we should also think about workflows, right? What is AI bringing in? AI will bring in new workflows. Now these workflows will impact how products are designed, right? So a team will put together a team of mechanical EEE CS. They will have to arrive at what is the workflow that is good for them, right? And in that, they may also be having a AI workflow for RISC-V, how they put together the software, hardware. So even though, see, I'm also, to Sharan, I'm also a software first person, by the way. I want to know the software. I will not go and do the hardware until I have clarity on the software. Now in that, I feel there's a lot of opportunity, and where academia can also train students in terms of how they do the workflow, and RISC-V as a community, what kind of AI workflows for verification, for even system level, how do you put a drone product together, what workflows can be offered. And ISA is like a balancing act, right? ISA is like a balancing act in that to not complicate things too much. But AI could also, this software hardware divide and what choices to make there, AI could also help in making decisions, aiding people to manage complexity, things like that.
So you have gotten to AI for RISC-V using AI also. Okay. So in the interest of time, what we would like to do now is, of course, we have talked about building products and using RISC-V as an enabler, but I think there's going to be soon, or it's already there, the need to also think about big infra using RISC-V, where at least you serve the inference needs, right? So I want all the members to give the insights on how do you start small, how do you scale, and what are the challenges, and what you think you need to do to make it happen, and we'll conclude with this. Okay, so essentially scaling, and for scaling, what do we need to do in terms of challenges?
In terms of scaling, are you talking about putting out more RISC-V based devices for AI, or are you talking about data center grade stuff?
Going there. So I want to keep scaling up. I have a scalable architecture, and then I want to put in more cores, solve the memory problem and knock problem and so on. So how do we get there?
Yeah, okay. So I'll very quickly answer both before handing over the mic. Mindgrove at least has a very specific way of thinking about this. The way of trying to putting in more goes like this. There are only ever three pieces of hardware that you traditionally use for AI inference, and at that level, inference is what we are really worried about. And that would be a dedicated piece of hardware with a systolic array or equivalent, something that the industry now calls an NPU, neural processing unit. B, you have a GPU, whatever it might be. It might be an Imagination GPU, it might be a Mali GPU, or could be an NVIDIA Orin or whatever that. The third one is the CPU itself. And that has now, once again, come into context due to the whole agentic AI and all those kinds of things. So at that level, what we do is we look at the problem. And if that problem can be, mathematically speaking, if it's a sparse problem, if I can solve it with a sparse model, I won't really recommend using an NPU because it's kind of built towards dense problems, dense matrix multiplication issues. So go for a CPU-based solution if you can get away with it. There is a limit up to which that is feasible, after which you need to go higher. And in our case, because we don't have a GPU, from there we expect to switch to an NPU-based system. That's the edge level. Going to a data center level, once again, depends on the kind of architectures, what you are trying to do with those software. If you are building out, if you are hosting and orchestrating an agentic-based setup, then ARM recently came out with a chip, I believe they call it AGI, which is something like 136 cores. That kind of architecture is now back in vogue, I suppose. And if you are doing more of a vision kind of processing or a language translation, those kinds of application, typical of what you would see somebody like an Alphabet, Google do, then the TPU architecture actually works very well, because at the end of the day, you're solving matrices on transformers, and that is probably the most efficient architecture for dense systems. So the balance depends, my final line over there is the balance depends on what level you are working in, and that level will then drive the kind of architecture that you are doing. It is pointless to build a 10-top systolic array if your selling price is capped at less than $5. If you can sell at $500 a chip, then a whole gamut opens up. So those operational constraints also come into play. And India has use cases across all three and can play across all three with RISC-V. You just need to make an out-of-order core for that.
Sure, thank you. And again, Chitra, for you, so steps 1, 2, 3, in 3 years, we want to see more adoption. Yeah. What are the steps?
I would bring a different spin to whatever Sharan told. I mean, it's going to be more of distributed. I mean, I'm not looking at more consolidation here because it's going to be the same physical AI world. There is going to be more humanoid, more system integration. So it's going to be more of things putting together, and that's where you're going to see huge of scaling challenges.
Since I have not promised to bring these AI chips, I can safely say a lot of dreamy things here. So I think the AI chips, domain specific you make it, and then you can also have hardware for training small language models. That adoption can happen, and the scale for each of those domains can bring in the scale too. Like let's say healthcare, you make the solution for that domain, the hardware requirements, the training requirements, the inference requirements will be different. So make it solution specific AI hardware. I mean, I'm just customizing at all levels. So, and then scale it up. India has as many use cases as we can think of. Yeah.
Yes, Kunal. So steps 1, 2, 3, academicians like us have to do so that we are going to champion adoption. Let's say 3 years later, if you have the conversation, we'll like, okay, you have taken care of edge, and then we are looking at. So what are the steps do you think we should take?
Again, right, like your question of edge versus cloud. See, Compark says economics. Look at the economics. The economics are very different, right? So don't forget the economics. The software needs will be very different, multi-tenancy, all that, right? So in a cloud, but I see scope for RISC-V in cloud as well, but it has to be cracked. As Sharan said, it has to be cracked differently. Now, your other question, the other question on in general the cloud. Let's say you are talking about inference. Then the context, it's not just, it's not a massive, like some of my studies recently from my group, it's not only doing computation and, it's also about managing context, right? Storage and memory, how you manage that may become important. And you could also go full, as Lavanya mentioned, you could also go full domain-wise, right? Like you have, you pick medical domain, right? And there again, there may be consolidation where RISC-V community can partners, because you have a lot of healthcare needs, unmet healthcare needs, and maybe there is, instead of many of those companies, spending tons of money separately, maybe they can, the healthcare providers spending tons of money to build their own AI, maybe there is room for consolidation and their cost savings can come in. So it really depends, right? So my closing thought is, again, we have technology, so I think RISC-V can speed up how we innovate, right, in the technology space and what software is demanding. So I think RISC-V has a big role to play in all of this as an enabler of how we build systems.
Okay, so thank you to all the panelists. I'll place my concluding remark. So the insight really talking to the distinguished people on the dais is, can RISC-V help solve India's problems? It does, but one has to take a solution or product-centric approach and have the ability to work across a stack, which is hardware architecture, which again has multiple steps, the middle level software, and also have an expertise on application. At the end of the day, when you have a solution, you have to know what does its application space look like, right? So, and you learn, by doing the product. And then when you want to scale, let's say to agentic AI or serving language models, I think Kunal's point also is you need to by doing this, you learn to characterize the applications and get the expertise to optimize across the stack. So you learn to crawl before you walk. So once you have As in India, we have multiple, usually Professor Kamakoti says, you solve a problem for India, you solve the problem for the world because of the amount of diversity we have, in terms of our needs as well as expectations, right? So once you do this, think the perspective on scaling is you learn how to solve problems, then you learn to characterize irrespective of whichever application you deal with, and then keep solving the technical challenges. It could be compute, it could be memory subsystem, it could be NOC design, it could be the way you put out the course together and so on. So with that, I'll stop. I hate to be the person between you and the lunch, okay? So thank you all for patiently listening to us. Hopefully you have some food for thought also. Thank you.
Thank you, Professor Gopal, and our panelists for that profound discussion.
We request Professor Gopal to felicitate Mr. Sharan with the memento.
We would now like to felicitate Chitra ma'am with a memento.
Next up, we would like to felicitate Lavanya ma'am with the memento.
And we would like to felicitate Kunal sir with our token of appreciation. Finally, we request Koti sir to felicitate Gopal sir for his work as session chair. Please give a big round of applause for the panelists. That perfectly tees up our afternoon. As we break for lunch, please note that it is from now till 1:45. Delegates, please ensure to take your ID cards and make your way downstairs to the 6th floor for lunch. As always, the program agenda is available on the website. Check the website for any updates. And if you have any queries or issues, please approach a volunteer with an ID card.
Please adhere strictly to your assigned timings to avoid overcrowding. Once finished, move directly to exhibition halls to engage with our partners. We'll see you back here refreshed at 1:45 sharp so that we can conclude today's proceedings soon. Thank you.
Thank you. The event will continue in 2 minutes. Please ask everybody you know to come back to the audience. Welcome back, everyone. We've built some incredible momentum, and it's time to recognize the partners who make this possible. Sponsors are the bedrock that allows this community to flourish and redefine the future of hardware. We are truly privileged to have industry pioneers here representing the forefront of our field, connecting research to real-world solutions.
Our first partner is driving high-performance computing initiatives that command the attention of the industry. CDAC is India's premier R&D organization under Ministry of Electronics and Information Technology and the team behind the indigenous Vega family of RISC-V processors. Most recently, CDAC unveiled DRU64, a 1 GHz 64-bit dual-core RISC-V microprocessor with the next generation Dhanush and Dhanush Plus processors already under development. Please welcome Mr. Libin TT, Associate Director, Scientist from CDAC Trivandrum. Mr. Libin TT brings up deep expertise in hardware design and advanced system architecture. He has contributed significantly to India's microprocessor development program, and since 2025, he chairs the IEEE Kerala section chapter of the Circuits and Systems Society, driving innovation and industry academia collaboration.
Please take the stage, sir.
Yeah, very good afternoon to you all. Am I audible? Yeah. So it's a great pleasure to be here as part of this Symposium, DIR-V Symposium, 3rd edition. So congratulations to Professor Kamakoti, Lavanya and all the organizing team for organizing this kind of an excellent event. So today I am going to discuss about the DIR-V Vega processor initiatives, so which is powering the innovation for Atmanirbhar Bharat. So this is at the agenda for today's presentation. So I will be briefing about CDAC, then the Digital India RISC-V program, and I will be touching about what are the different variants of processors available currently and the future roadmap, as well as what are the other ecosystem available as part of the Vega. So as you all know about CDAC, CDAC is the premier R&D organization under the Ministry of Electronics and Information Technology. So we are carrying out research and development activities in IT, electronics and associated areas. So you know very well know about how the CDAC is formed, right? So whenever there is a technology denial, actually we are trying to import the supercomputer from outside So then they denied the import of supercomputers, and CDAC is started as part of the mission program. So the mission is to develop indigenous high performance computing systems, and CDAC is successfully completed the mission program by implementing the high performance systems, and currently we are continuing the activity as part of the national supercomputing mission. So today also we are implementing lot of high performance computing system across the country, and we are also maintaining and providing access to the other partners for developing indigenous solutions. So in addition to this high performance supercomputing area, we are working on the other areas also. So always our main focus area is high performance computing. So now we are also started working on the fully indigenous exascale platforms. So then in addition to the high performance computing area, so we are working on the VLSI embedded system, including all the microprocessor developed as part of this DIR-V is part of this VLSI embedded system team, and we are also come up with a series of microprocessors as part of that. In addition to the microprocessor and high performance supercomputing program, we are working on the health informatics, education and training, professional electronics, software technologies, cyber securities, quantum computing, and many more areas. So the hardware design group in CDAC Trivandrum, we mainly focused on the high performance computing processor design, starting from the microcontroller class to a high performance embedded class is currently available right now. So anybody can license the processor without any fees. So right now it is free to use. And in addition to the microprocessor program, so we are working on the ASIC design for multiple products, and our team is also expertise in analog and mixed signal designs, high-speed PCB designs, and we have an in-house production and TOT transfer facilities also. And now we are focusing on today, the program is DIR-V Symposium, and we are also part of the Digital India RISC-V program. So when we started the DIR-V initiative, the landscape was very different than what you are seeing right now. So these activities started in early 2000. The government is also started thinking about the indigenous microprocessor development program. So that time there were so many other questions. So how do we go forward? So there are so many other processor architectures are available abroad. So including the x86 architectures, ARM, MIPS, OpenRISC, and so many other instruction set architectures are available outside. So then the question was, how do we go forward? So whether India will be focusing on developing the indigenous instruction set architecture itself, or we are going to license some of the commercial architectures and then building the microprocessors. So there were so many questions was there. So that time, so we had an opportunity to interact with the founders of RISC-V, including the David Patterson, Christy Asanovich, and the Berkeley team, and the CDAC expertise. So they also decided we are going to design the indigenous microprocessors with RISC-V instruction set architecture. So we are also part of the RISC-V Foundation. We are also an earlier member of the RISC-V Foundation. So when we are part of the RISC-V team, RISC-V Foundation team, there were only around 20 to 30 companies are part of the RISC-V Foundation. So now if you look at the RISC-V Foundation, you can see that more than 4,000 members are there, and CDAC is also one of the initial members of the RISC-V Foundation, and we are also continuing the interaction with the RISC-V team. So that time, once you choose the RISC-V processors, so we are not thinking about just designing a microprocessor core alone. So there is not, if we are designing a processor core alone, so we can't sustain, right? So other than even if you have an excellent world-class microprocessor also, in order to do the product development and in order to take it forward for the proliferation, so we need a complete ecosystem also. Then the CDAC focused on developing the complete ecosystem. So we have taken the compiler tool chains from the whatever existing available in the RISC-V Foundation, as well as we are working on top of that. So right now we have the complete ecosystem, including all the compilers, development tool chains, tutorial videos, etc. we made as part of the design. So the main objective is to design the microprocessors in India, and it can be used in worldwide for multiple products. So that was the main objective for the Digital India RISC-V program. And you are very well now aware about what is the importance of this program, right? So because microprocessors is the key element in any of the electronic components, and you know that the for our countries also it is very important to have the indigenous technology for the further progress. So these are some of the points where the country decided to have our own microprocessor development program, and they initiated a project called microprocessor development program. Now later it is renamed to Digital India RISC-V program. So in order to, as part of the program, so they focused on developing a series of microprocessors. All are to be implemented in a RISC-V instruction set architecture, and and we have to come up with a series of chips which can be directly deployed in many of the products in India. And as part of the program, we are also set up a resource center for the microprocessor and other IP core development and research activities. And all of them are currently available right now. And there is a well-defined ecosystem is also available as part of the Vega processor family. And now what is the DIR-V Vega processors? So Vega processors is a family of microprocessors starting from the microcontroller class to a high performance embedded class is available right now. So all the processors are based on the RISC-V instruction set architecture. So these are some of the processor variants available right now in the Vega family, starting from the 3-stage in-order microcontroller core. It's a minimal instruction set architecture. It supports the RISC-V integer and multiply class of instructions. The first 3 variants are in-order variants. That means it follows the in-order instruction execution. And the instruction set, you can see that it supports different set of instructions. The first one will run the free RTOS or bare metal applications. The second variant, it's a 32-bit variant supporting the integer, atomic and single precision floating point operations, so which can boot Linux and run other different operating systems. So in the 64 series, we have the AS1061, it's a starting variant with 6-stage pipeline supporting the single double precision floating point operations, compressed instruction set architecture, which can be very well used as a starting point for the 64-bit application development. And the later 3 variants are the high performance variant. All of them are superscalar processors which can fetch and execute multiple instructions in each and every pipeline stage, and which can be used in high performance the embedded applications. And currently, if any of you are interested to work in this processor design, or if you are interested in using the microprocessors in any of your product design, so now we make it free for some time. So up to next year, we are making it free so that anybody is interested to use the Vega processors as well as our IP ecosystem. So they can approach CDAC through vega@cdac.in, our email ID. And you can collect our contact details from our stall, and you can reach to us. So we are providing the processor RTL for you, so you can develop a product around it, and it is free for the MBW shuttle, and we are providing all the necessary support without any cost. And this is the roadmap for us to come up with some of the test chips. So the first one is Tejas 32, so which is already fabricated and it is available for commercial use. So you can buy from Amazon or Robu or Vega website. It is available free, and the development platforms also based on Tejas 32 is currently available. And the next variant is Tejas 64, which is fully indigenous. We fabricated in SCL Chandigarh, and it's fabricated in a 180 nanometer, and it's clocking at around 80 to 100 megahertz frequency. And recently you heard about a new Dhruv 64. It's also a high performance processors which is powering the 16-stage out of order processor pipeline, dual core processor clocking at 1 gigahertz, and it is also currently in the testing stage. And now our focus is on the Dhanush, last variant, Dhanush 64. We are working on the quad core processor SoC, so which will be taping out soon, and the chips will be available mid of next year. And this is the block diagram where you can see that in Tejas 32, in addition to the processor core, so there are so many other peripherals are also there. So you can see that the timers, GPIOs, UART, and the basic peripherals are there in the Tejas 32. So if you need the processor or IP or any form, so for your applications or research, so we are ready to provide it as a free to use. And similarly, Tejas 64, you can see that it's a 64-bit processor, the heart of the Tejas 64 chip. And in addition to the processor, we have the Ethernet controller, STRAM controller, DMA display controller, everything is integrated and created a single chip solution. And through 64, if you look at the core, you can see that the processor, 2 processor cores are there, which is connected through a high performance interconnect, coherent interconnect, and the multiple L2 cache is also integrated. And all the other low speed and high speed peripherals are there. USB is integrated, Ethernet, display controller, DMA, and all the low speed peripherals like UART, GPIO, EOS, PWM, everything is there available in the Dhruv 64 chip. And this is a key architecture features, and you can always browse through our website. All these details, data sheets, example designs, everything we put up in the website, Vega website. And these are some of the development boards are available starting from 600 rupees to 4,000 rupees right now. So you won't get any other RISC-V boards supporting the IoT application at this much of low cost. So this is, we are only providing the IoT class development boards at a cost of 3,999 rupees. These are some of the details of our RISC development platform. All of them are powered by the Tejas 32 chip. Tejas 32 chip. In addition to that, the board level capabilities are varied. Some of them support SD card, some of them support Ethernet interface, and this IoT platform support Wi-Fi and Bluetooth, and all the temperature and other sensor modules are integrated. So this is the Tejas 64, which is fabricated in SEL Chandigarh. So you can see all the details are there. So if you need, if you interested in getting more details, you can either browse through our website, or you can contact directly vega@cdac.in. So this is a small evaluation platform we developed using the Tejas 64 chip. And this is the block diagram of Dhruv 64. It's a 784-pin BGA package, and currently we are in the testing phase. And this is the evaluation board also, which is not fully ready right now. And this can be used for different applications like high performance embedded or different class of processes. Some of them are suited for high performance embedded application, some of them are suited for smart meter or low power embedded applications, etc. And the key benefits of the entire program is, so India now owning our own IP, our own high performance microcontroller processors are available, which can be tuned to our requirements. So some of the customers are approaching us so that they need or customize the processors based on their architecture, their specifications. So we are currently doing that also. So these are some of the products which are developed using our Tejas 32 chip. Some of the IASC, they demonstrated a drone, and smart meters and so many other products are developed using this Tejas 32 chip. So when you compare, so we are always hearing a question about how do you compare with Arduino Uno platform. So these are the comparisons. So even if you pay little more for this indigenous microprocessor, also in performance wise, it is much higher performance than the available Arduino Uno processors. So all the platforms you can purchase from Amazon, Robu, Electronic Components, and or from the Vega website. And currently also, so we have the Drone Federation of India, they have launched a program for the indigenous drone development activities. So it's a mission by the Ministry of Electronics and Information Technology, National Innovation Challenge for Drone Applications and Research. So last year also they conducted a challenge, and this time also this is open till August end. You can apply for this program. So they are providing a huge prize money also for this. So the problem statement is you have to develop the mission 3, it's the Vega pilot. You have to develop an indigenous flight drone system using our ADs or the Tejas 32 development platform. So in addition to that, we are also supporting many other design challenges. This time also we are part of the DVCon, Design Verification Conference. So there also the design challenge is based on the indigenous Vega microprocessors. So as part of this program, we are also, now we are also grateful to all our partners from the industry, academia, who are supporting us to reach up to this particular stage. And we are now for the students or other partners here, so this is the right time for you to get more into the computer architectures. Since RISC-V is free, you can do anything using the RISC-V instruction set architecture. So hopefully in the coming years, so some of you are sitting here will be part of our team. So we are interested in continuing our collaboration with all the other partners, and we are also thanking MIT for giving us this an excellent opportunity for developing indigenous microprocessors for our country. So once again, thank you for all of your attention, and thank you.
Yeah.
We request you to be felicitated, sir.
Check.
Thank you, sir. We would now like to present a token of appreciation to Mr. Libin. We request Patanjali, sir, to present this token of appreciation. Now, let us welcome a company doing revolutionary work in AI hardware and software. Tenstorrent is one of the most closely watched names in computing today, a global company building high-performance AI accelerators and RISC-V CPU IP, and licensing both to customers worldwide. What makes them particularly relevant to this audience is their conviction that the open RISC-V architecture belongs not just at the edge, but at the very top of the AI, the data center stack. They also have a growing engineering presence in India, which makes this conversation a timely one. Please welcome Mr. Shubham Mathur, Principal Engineer from Tenstorrent. Shubham Mathur has spent over 15 years building and verifying CPUs. He began at IBM working on power architecture, then spent 8 years at ARM across the A, R, and M profiles. Today, he is the part of Tenstorrent's RISC-V group, developing high-performance CPUs and system IP for next-gen computing. He will speak on Own Your Silicon Future. This is a mic for backup if you need.
Selling, right? And CPU is just part of the Tenstorrent AI story. And I'd like to start with a question, right? With RISC-V, we have, right? It's bringing a lot of openness to all of us, and still we can build our system with the RISC-V, right? But can organization, can companies, can we own our product, right? Can we own our product roadmap? That's the question we start with, and that's where we are trying to come up with a solution where we can own the complete roadmap, right? Yeah, so before, I talk more about our IP portfolio, the solutions we have in hand, I wanted to just, talk and, glance through overall Tenstorrent, right? So yeah, we are in the industry, we founded in 2016, and we have raised more than $1 billion as in, capital raised. If you look at our investors, the whole spectrum across, and our investors are not just our investors, they are actually partners. If you look at Hyundai, Samsung, they are also using our solutions, right? In terms of our solution, we have IPs, we have systems, we have chiplets which we can sell, and we also have a board for developers community. These are high level, our roadmaps and whatever products we have right now. So for example, we have AI accelerators, which is, 10.6 Neo, and we have a CPU, which is RISC-V based, one of the highest performance CPU. Okay. So it has completely RISC-V 64 compliance, out of order core, high performance CPUs, which 8 wide issues, and it can scale up to 4 wide machine to 8 wide machines. We do also have chips and chiplets. I'll talk more about the OCA, which is open, Open Chiplet Consortium, which Tenstorrent is founding. So I'll talk more about it later. Along with that, the CPUs, we do sell systems, right? We do sell servers. Like one of the servers which we have is Tenstorrent Galaxy Box, right there in the left bottom corner. This server is 32 high performance ASIC in the custom chassis, right? We do have, I don't know if you have checked out the internet, we do have a liquid cooled box, which we call as Quiet Box. It's a liquid cooled machine. So this box is available and we are right now deploying, right? None of them are prototypes. These are something which we are deploying at the customer end. Along with that, we do have a software story. We have all 3 verticals. I think in the previous conversations when we were talking about, what all the verticals, right? When you sell some of your system to the customers, will their software work on that, right? And that's where we have multiple entry points where you can enter at the compiler level. So what we call as TT Forge. This is our compiler, and we have a TTN, and these are the library optimization module. Essentially, you think about it, you have the large language model, which you want to have inference on your system. So you need some sort of optimization and operators, right? This comes from the TTNN, right? Along with that, we have a TT Metallium, which is nothing but a bare metal lower level programming where you can control your kernels in the systems. Yeah, moving forward, like this is something, I want to talk about, right? If we just sell a core, right, you inherently, take the constraint from someone else because core is just one box, right? You want to make one whole system. And these are the constraints you have to take. So that's where Tenstorrent as an company is going more towards selling a solutions, right? So in that terms, we have IP where one can have the control on our IP. So we essentially sell. I'll talk more about how our licensing work, but we actually give the complete access of RTLs along with all the collateral you have. That is something accessible to the customers. We have silicons where you have development boards where you can start upfront in the cycle, optimize your workload on these systems. So for that, we have a silicon boards available. We have systems in the sense you can take the whole Galaxy box and scale it into multiple sockets, make a sort of a sovereign AI solution or make a data center out of it. So for that systems, we do have software. So that's where the software thing I was talking about earlier in the previous slide, where multiple entry points we can have. And then we do also offer all these things on the cloud, right? So we can jump onto the clouds. So moving to, more focus on the RISC-V, like when and why it started. Like we actually be an AI company, and And RISC-V was a need, right? The previous solution which we have, we were using some IP licensing CPUs, and that's where we find the need where it is neither customizable nor it is something where we can have a control in terms of roadmap, right? How do we drive the next generation of it? How do we optimize it in terms of the software workload we have and things we want to run, right? So that's the starting point, right? That's the need exactly, right? And that's what we were talking about, right? When there is a need, and need will gonna turn into a challenge, and then challenge gonna work into the business, right? So that's the choice from the company side, right? We want to go open source, both in terms of our hardware, both in terms of our software. We want to. That's where the choice of picking RISC-V, choice of open sourcing our software, the RISC-V effort we are doing, we are putting back into the community as well. So a lot of our test generators, a lot of our verification collateral, you can download it from the GitLab or GitHub and also contribute there, right? And that's the choice we have making, right? And then just the result of it is the capability, right? So we have actually intended to do it for our own business need, but then we started, the problem which we solve for ourselves is actually becoming a business, right? And we started selling IPs and our high performance CPU IP. We have a lot more, customers across the globe, and that's the starting point, right? So essentially, which is what we discussed. Like, if you have a challenge, the challenge is how RISC-V will solve the problem, right? And then we can think about a solution. Like, you have to build. It's just not the CPU which RISC-V offer, right? RISC-V, along with RISC-V, you have something called non-RISC-V kind of a terms, which is help you to build a system, your debug collaterals and things like that. And then we have to work on the software like that. Sharon was mentioning earlier that you have a GCC and you can go ahead and compile your C++ code with GCC, but you can actually have another flag there where you can say, let's compile with the RISC-V, right? So that is where our contribution towards, RISC-V and openness as well. Moving beyond, this is more a licensing model. On the left-hand side, you have more traditional licensing model where vendor will give you the IP, and that IP you own it, and you can't modify the IP, right? Most of the vendors, they obfuscated it, and they hide the whole source code. However, where the Tenstorrent comes in, we give you an innovation license where we work along with you. We can give you access of whole RTL, we'll give you the access of our software collateral, and we are very flexible in terms of building business relationship, right? So we figure it out how we can help you, how can we change our roadmap, or how can we support you guys to get things done. Yeah, so just moving beyond in terms of why Tenstorrent RISC-V IP, right? So you need not to just choose just the open model and production grade credibility, right? So in that sense, we have open business model, we have proven silicon as a system. So all these CPUs. So this year we have done the GA, what we call almost a production quality of our Escalon CPU, which is out there, and we are also expecting a test chip coming and more like a development board by end of this year. Some of these CPUs also delivered to customers. So essentially what we are saying is these are proven silicons, these are not prototypes, right? And so all those proven silicons available is built by strong team. Our architects, our team all came from the most reputed company along the whole semiconductor industries. And these are fully verified, right? So the way our verification approach is not just simulation, right? We did simulation, we do FPGA prototyping, we run it on a HAPS board, we also have post-silicon story ready once we deliver CPU to you guys. So this is something, our roadmap. At the top, Escalon is our Escalon CPUs. We have multiple generations of Escalon CPUs. Escalon X is our highest performance CPU. It is 8-byte machine with 8-byte machine and 2.8 gigahertz and scale up with respect to the technology node you use, right? It can be the 3 gigahertz processor. We have a low-end CPUs along with it is called Escalon S, which is 4-wide machine. Alexandria is our real-time, mainly catering to FUSA requirement there. So this is something have fully ASIL-B and ASIL-D verified CPUs. Babylon is our next generation, closing some of the gaps which you need in the infra CPUs along the RAS and other stuff. DIR-V and Rondel is our real-time CPUs. So essentially, we are not just building one CPU. We have a real-time CPUs. Rondel is our more microcontroller CPUs targeting edge computings, and we have 10.6 Neo, which is our accelerator, right? Also, we have chiplets, which is coming along with that. So Quasar and Escalon, Aegis, these are our different chiplets, which is coming in 2026. This is a high-level glimpse of our overall portfolio. So starting with the RISC-V CPUs, we have Escalons, Alexandria, Babylon, Cyrene. This is all our roadmap and built on every generation. So by the way, all our CPUs starting with Escalon, these are all our RV64 compliant CPUs along with all the extensions, RV23, all extensions we do support. We support all the capabilities in terms of debug, in terms of power management, in terms of scaling it into the multiple systems, so you can have NOCs connected to it and you can scale it. Along with that, we also provide system IPs. So these are the IPs which can help you to build systems. It can be IMMU where your devices can be connected, interrupt controllers, so something in the ARM world which you have GIC, so you can have Applix connected, you have system management blocks, boot, security, chiplets. And this is very crucial component. Reason being is, when you building a system with the RISC-V out there, a lot of customers looks at you with a lens of ARM, right, in terms of what ARM is offering. They do have, you go and end up saying we are having RISC-V CPUs. You can't simply add a RISC-V CPU and replace it with the existing ARM CPU, right? You have to come up with a whole solution where customer can, take it as a holistic approach. So these system IPs are essentially enablers for customers to actually move their whole clusters or a subsystem into RISC-V system, right? We have on the bottom we have 10.6 AI. These are all accelerators chips which can also going into product are called Black Holes, Neo, and we have auto version of that called Neo Auto, right? So this is something we are just not selling the IP altogether as in RISC-V IP CPUs to the customer. We are also providing a support in terms of post-silicon, right? This is what we call silicon vault, right? In terms of engagement with the customer, is just not you take an IP and go ahead and do your chip around with it. We also have a post-silicon capabilities. These are all the debuggers where you can actually tap into the chip, and while bringing up in the lab, we have all the collaterals available to the customer. So this is, as we discussed in the previous discussions as well, so in terms of AI, in terms of RISC-V, we have to solve particular problem, specialized vertical, and one of that vertical is the physical AI, right? This is all the efficient AI or edge-based AI where we wanted to do real-time AI compute, right? So I'm just more talking to you in terms of what is the requirement, where do we fit in, what is the customer end product. So a lot of real-time processing where you wanted to have the data in terms of times, in terms of real-time data, and take a compute immediately, right? So that's where our DIR-V CPUs, Rondel CPUs, these are real-time microcontroller CPUs comes and fit in. We also provide systems plus chiplets. So OCA is something I'll talk about in the further slide also, but this is where you can get rid of that vendor lock-in, which people traditionally have, right? And in terms of end customers, these are all robotics. You can have control, zonal control, safety island. All these products, required physical AI at the end of the edge devices. in terms of AI, you need control, you need orchestration, you need efficient AI bandwidth, right? So the message here is, our TT Escalon along with 10.6, which is our AI accelerator, and the system IP stack, right, can underpin this hyperscaler and sovereign AI infrastructure. So that's where TT Escalon comes in, 10.6 AI comes in, right? And we can build a whole hyperscaler systems along with this. And the product is, it can go into the server, it can go into, hyperscaler sovereign AI. This is again a solution towards automotive and autonomy. So in automotive you have ADAS, you have cockpit. So ADAS is something which need CPUs, high performance CPUs along with the real-time CPUs. So combination of our heterogeneous compute subsystem. So that's where we can address the ADAS market with the existing solution what we have. Solution towards IVI cockpits. So cockpit is where we need large number of CPIs, right? So all our CPUs can scale up to more than 128 cores, or it can go beyond, and you can scale all of them together and make cockpit solutions. We have zonal gateways where you can have a secure communication, so that's where the real time come into the picture. We also have the security island there, a bunch of actuators and edge kind of systems. So all these systems can come, and we can address all the existing market with our existing solution. So this is market which we are collaborating also with partners. So we have it's not alone, right? TenStorrent can solve the problem, right? So we also collaborating with multiple partners in terms of our NOC, in terms of the fabric which we provide. So we collaborated with Rambus, we collaborated by a subsystem for NOC, and bunch of other customers on AI and CPU infrastructures, right? And these are all very well integrated with the TenStorrent collateral. On the automotive side, we also been partnered with Bosch, Samsung, and Siemens. So there are a bunch of consortium. We are also partnering with Samsung, providing them some solutions. Also in the edge side, we have multiple other customers listed here. So essentially, message here is it's just not TenStorrent coming up with a solution. We have to partner with the people in the community and come up with a solution which can be better for the community. Yeah, so this is all, I want to take a moment and talk more about the software side of the story, because hardware is where, we have all the solutions. So as in TenStorrent, we also started contribution from the foundational level, right? We started contributing to GCC, LLVMs, where our software stacks can work with the RISC-V, right? So we have done, optimizations towards the vectors, FP16, FP8, Int8 kind of solutions, working with the software community, right? So this is something not possible with overall RISC-V community, right? It's not just TenStorrent. We work with the community on these sites. Yeah, so I want to take a moment about the OCA, which is called Open Chiplet Ecosystem. This is a foundation by TenStorrent, and we have bunch of multiple customers joined it, right? So this is in terms of making a chip, and right, chiplet is another strategy where you will build pieces of your chips, right? You can have one CPU chiplets, you can have communication chiplets, you can have the memory chiplets, and all these chiplets can be at a different technology loads, right? So this essentially reduce the risk and increase your overall yield, right? So that's where TenStorrent is also putting a lot more effort, partnering with company, coming up with the open chiplet atlas. There's a high-level architecture about the open chiplet, right? It is split into 5 main layers, where one is your software, second is your systems, and software is essentially where we can have all the interfaces, lower-level programming. Systems comes with boot, security, and interrupts, bunch of system IPs essentially, right? And all of these layers you can actually build with the different technology nodes and stick them together. So there is a barcode, you can, scan it, read about the architecture and more about it, right? Yeah, so this is some of our customers and in the market, what people are saying about Tenstorrent. So they are confident about our portfolios, they are confident about our capabilities, what out there, and yeah. Yeah, so I wanna just also stop here and tell you guys that we have an event also coming up in Bangalore, and be watchful about it. It will be on 8th of October. It'll also bring a lot of leaders and our own leaders there. So that event will be on 8th of October. We'll have more information about it. You can check out our website, and it's some more on the website on that, right? So that's where I like to thank you all and want to just take this moment for sure that RISC-V and AI where the openness really playing important role, be from the India perspective where we have to support on the open in terms of open software. It can be your simulators, it can be the compilers, it can be the software. We need to start using and adding more to it, right? We have lot more dependency in terms of our vendors. You can most of the CAD tool provider, you can't tape out right now chip without them. So but there are across the globe a lot of open source in terms of development going on, and we should support into that, right? Thank you. Thanks, everyone.
Thank you. Please accept the token of appreciation. I request Patanjali sir to present the token of appreciation.
Next, we have a company at the cutting edge of processor and SoC IP design. Encore Semiconductors is a Chennai-based fabless company building RISC-V processor IP, and it was founded in 2018 by the very team that built IIT Madras' Shakti processor, which makes their presence here especially fitting. Rather than selling a fixed catalog of cores, Encore builds core hub generators that let a customer configure the ISA and microarchitecture to their exact needs. Their Azurite core targets ultra-low power applications like smart meters and smart cards, while the Linux-capable Calcite core serves higher performance systems. We please welcome their spokesperson, Srinidhi Iyer from Encore Semi. Hey, ma'am. Yes. We can set it up this way. Yes. One sec, ma'am. Srinidhi Iyer is a design engineer at Encore Semiconductors, where she works on secure SoC development. Her work focuses on hardware security for RISC-V systems, including secure SoC development. Her work focuses on security accelerators and a RISC-V trusted execution environment. She holds a Bachelor of Technology in Electronics and Communication Engineering from PES University and is currently pursuing a part-time MS degree at IIT Madras. Her interests include computer architecture, hardware security, and trusted execution environments. Over to you, ma'am.
final 1, final 2, final 3. Final 1, final 2, final 3. Mic is on. Oh. Do you have a local copy of this? I have a PDF, but it's not updated. Try changing the slide. Oh, wait, one sec. And the connector and there's the extension. Adapter. Okay.
Is this fine now?
Yeah, yeah.
The pen drive.
Yeah, pen drive venuma. Amma.
Let them start. Come.
Pen drive venum. That is the remote.
Oh, is it?
I'll just use the arrow.
I can move it for you for now.
No, it's okay. I change it.
Just check once.
Is it not changing? I'll just use arrow. It's okay.
We can have one person here if you want.
No, it's
Okay.
Hi everybody, sorry about the delay with the setup. I insisted on using my laptop. I'm Srinati. I'm going to be talking about secure system design and the kind of considerations we have to make when designing a secure system, including the trade-offs we will be making. And when I say trade-offs, the first adversary you have to encounter when designing a secure system is the performance team in your company, because they hate it. And because they optimize for every one cycle bubble, and when you tell them that you're adding an encryption engine that takes 32 cycles, they don't like it. So it is always a balance between security and performance. A lot of security hampers the usability of the system as well. So we always try to strike a balance between security and performance by considering a few security goals, which is defined as confidentiality, integrity, and availability by Todd Austin. Confidentiality means, do you have any data that you want to be visible only to certain entities? And integrity means, do you have any data that you do not want modified by other entities? These are like some protected keys or passwords. And availability is your system servicing requests to multiple systems, and is it a big problem if it goes down? And there are some systems where some of these goals wouldn't make sense. For example, a server that is servicing multiple requests does have to worry about availability, but a user-side smart device doesn't really have to worry about availability, because if it goes down, it's a single point of failure. So another thing we ask is, okay. Okay, so another question we ask is, what is my threat model? And when I ask the question threat model, the first question is, what are my assets in my system? Do I have any cryptographic secrets I need to protect? Do I have any data that is is a secret? So for example, if I'm an ML provider, then the weights of my ML model are a secret that I want to protect from other people. And the other thing is, who are my adversaries? Who do I expect to be attacking my system? What kind of system am I providing? And what kind of capabilities do they have? And by capabilities, I mean that there are some attacks that are very expensive to perform. For example, fault injection attacks require laboratory setups that are very costly in terms of time and money. So when I design a very small system, like a BLDC controller, I'm not worried about somebody doing a fault injection attack. But that is something we need to consider as well. So I've listed out some threat vectors, and the first one is software-based threats, because these are the easiest attacks to perform because they have a very low cost because you're just writing software. And over here, there are two main things, right? One is software trying to escalate privileges, which is user mode code trying to run in machine mode. For people that are not familiar with RISC-V privilege modes, there are three. One is machine mode, the lower one is supervisor mode, and the lowest one is user mode. The other type of software attack is when software is trying to modify protected information. Another type of threats we are thinking about when designing a secure system is system-level threats. These are not isolated to one block, but it's more of a system thing. For example, if you have an external flash and you're copying your boot image into the on-chip RAM, then any tampering of that image is a boot process compromise. And another thing is if you have a key on your SoC, then you want to make sure it is protected. So the third type of threat vectors are the physical ones, and the most famous one here are the side channel attacks. These are pretty costly to set up, but there are some systems that require protection against them as well. I've listed a lot of solutions on the side, but what I was trying to demonstrate here is that none of these solutions by themselves protect against all of these threat vectors, but a combination of all of them is what we use when we design systems. So when I say building blocks of secure SOC design, these are a few of them. And the basic layer is going to be the RISC-V core and the PMP that comes with it. So it provides a pretty basic separation between the privilege levels in the core. The next thing is the accelerators, of course. They are accelerators that accelerate the cryptographic computations you will be performing. For example, the ECC algorithms or signature verification algorithms or anything like that. And you need them for performance purposes. For example, our secure boot would use all of these accelerators, the SHA accelerator to do hash matching, the asymmetric key accelerators to do signature verification, and the symmetric key accelerators to do payload decryption. So they are useful because you don't want your security to slow down your performance as well. And similarly, we have the tamper response module, which was listed as a solution for physical attacks. It allows your SoC to decide what kind of response you want to come up with for any kind of tamper that you detect. You will be able to exit that situation gracefully instead and avoid spurious resets. The other solution here is WorldGuard, which is RISC-V's answer to TrustZone. It allows you to separate between non-secure and secure worlds, but also lets you scale beyond just two worlds and gives you the ability to perform software isolated, which is software isolation, which is hardware enforced. So at Encore, we believe that because this process is so iterative, because I need to decide on my threat model, and then I need to decide on what kind of performance trade-offs I can even bear. So we believe that SOC design itself is an iterative process, and SOCs are basically comprising of some basic building blocks, like the RISC-V processor core, and then the NOC, which is usually one of the fabrics, AXI or APB or anything. And then some low-speed peripherals, like the CLint, PLC, GPIO, all of that. And then the accelerators, which is where our crypto accelerators fall as well. So when we design a secure SoC, we are still using this tool to iterate through multiple threat models and performance considerations very rapidly. And I have a few examples here of some different SoCs with different goals. This is the first one. And over here, clearly, the goal is low area. And it is a very simple SoC. So it has a very minimal attack surface as well. And the threat model they've considered when building this SoC is just privilege escalation across the M and U mode. And for that, it suffices to just use the RISC-V PMPs, since it is able to provide that. Over here, we're not worried about access control to the peripherals and all of that. So this is another SoC, which is a little more I/O rich. There are 3 new security accelerators as well. And you have one core, which is MU. And there is a larger attack surface simply because the SOC is larger. And the threat model we've used here is that we have secure boot enabled, which uses these accelerators. And after that, all of the software is trusted. So you're not performing any access control for the security accelerators. So the U mode code is able to access these accelerators as well. So we accept that there are some open threads over here, but the design of this SOC focuses on performance and doesn't choose to apply some of the security solutions. So this is the final SOC, which is more comprehensive in terms of its security. And over here, there are multiple security solutions layered together. And for example, the first one is going to be the world guard. There are two cores. One is the trusted core and the other one is the application core. This lets you define your threat model that the application core itself is untrusted by default. And even within the trusted core, you are able to assign the trusted world only to the M mode code and assign a different world ID to the S and U modes. So this way, the trusted core can control which peripherals the application core even has access to. So that is one level of isolation. And then there is also the on-the-fly memory encryption, which does the encryption of the DDR data at the rest. And then there is also the alert handler and the tamper detection mechanism, which lets you respond to tamper events, that is the physical attacks. So yeah, so just to summarize, we have seen that even secure SOC design is not a very clear-cut thing. When we come up with threat models, we are always iterating through different performance trade-offs and different considerations and different IP blocks and which of them work together to even form a security solution. And we at Encore have achieved this through SOCGen and our security IPs. Thank you.
Thank you, ma'am. We would now like to present you with a token of appreciation. We request Patanjali sir to give this token. Finally, for this segment, we welcome a team whose work on design efficiency has been vital for this ecosystem. Mirabilis Design is a Silicon Valley EDA company whose Visual Sim platform answers a question every architect in this room has faced. Will this design actually meet its performance and power targets? Before even a single line of RTL is written, Visual Sim Architect lets teams model an entire system, run trade-offs, and find bottlenecks at the specification stage. They released one of the first dedicated RISC-V system modeling libraries with configurable cores, interconnect, memory, and peripherals ready to assemble. Please welcome Mr. Tom Jose, Director of Research and Development from Mirabilis. Tom Jose leads the development of advanced system architecture and modeling technologies at Mirabilis Design. His work spans SoC architecture exploration, avionics systems, heterogeneous computing, and next-generation interconnects, with published research on RISC-V versus ARM benchmarking, time-sensitive networking in avionics, UCIe performance modeling, and fault tolerance in RISC-V cores. Over to you, sir.
Hello everyone. My name is Tom Jose. I am working as the director at R&D at Madras Design. And so today I would like to discuss the importance of doing architecture exploration at system level. Because oftentimes, as we have seen, at an architecture level, what we have done is, what people have been doing is, they do static analysis. They have a spreadsheet where they would, for a specific application, they would do comparison. So let us take an automotive application. So they would, depending upon the application, they would assemble a list of possible IP components that they can use it for. And then they would do certain trade-off analysis statically. And then they would pick those IP components. Then they go down the line, they have the Verilog RTL code. Then they do the fine-tune optimization. And at the time of, when they are running the application, they find that, okay, it doesn't meet the deadlines. It is not meeting the requirements. So for example, let us take a very quick example. So let us consider an automotive application, and within the scope of automotive application, let us say we are running an autonomous driving. So we have very strict timing deadlines that we have to adhere to. So for example, let us say there is an obstacle that is coming up, and it has a sense of obstacle, it has to apply the brake, and the vehicle has to come to stop within certain timeline. So let us say that time to action is like only 25 milliseconds. So we have to make sure that the components that we are putting it together, the hardware architecture, can sufficiently run the application code and get the action delivered within that timestamp. So what if we could do it at a system level itself? So then what we'll be doing is we'll be saving ton of time and cost where we can save down the line. Because if we find that our hardware architecture is insufficient to handle these requirements, we can increase the number of cores, we can select a better core. So there are for RISC-V, let us say we are going with Sci-Fi U74 or maybe Andes cores or any core. So you have a wide range of options to choose from, and you can identify which one to go with. Yeah. So by the time RTL is available, the architecture is always fixed. So there is limited amount of trade-off analysis or PP optimization that can be done when you have the RTL code ready. So let us consider a very simple example. So let us say we are building a house. So before building the house, we would spec it through and find the list of components to build the best quality iron bars, the cement, bricks, everything. And now you start building it up, and then you find that after putting it through, you could see that there are cracks forming. So then you find that, okay, we have to go back and take out the iron bars and use a better component. So what would that impact? You have to break it down, each of the components that you had previously built, and then replace it. So that is you are wasting your time, you are wasting your money where you could have spent efficiently. So that is why if you are doing the system level architecture exploration, at a very early stage itself, you will be able to do this trade-off analysis. So for example, will the application close the deadline using the IP codes that we have selected? Or what does the old SOC consume for running that application? What will be the power consumption? And which functions belong in hardware, which functions are executed in software? The hardware-software partitioning. So all of these can be done at a system level itself. The benefit is that we get more clarity, we get more confidence in the system, and there is about 90% of the bugs that are, or issues that we can identify in RTL and down in silicon can be prevented in architecture phase itself. So to give an example, so this is the methodology. So we have application, we have the mapping, and we have the hardware architecture. We are combining all three at a system level. So to give an example, we can see on the extreme left, we have the set of applications that you want to run on your target hardware architecture. So there is ABS, the ADAS, and fully autonomous driving. So depending upon the type of application that you want to run on your hardware, you have to pick the system. So what are the type of sensors that you want to be included? What are the compute resources? So the DSP cores, the NPU cores, do you want to do some edge computing, the high-end RISC-V cores. So there's a pool of components that you need to, from which you need to pick the right component for your application. Then what you have to do is you have the set of components you have selected. Now you have to map this application to the dedicated hardware. So there could be multiple applications competing for a hardware resource. So are all these applications able to run within the timing deadline? what is the power consumption for it? What if like there is a, let us say there are multiple applications running on a hardware accelerator and there is like too much activity, there is too much network activity. Can our interconnect handle it? So maybe we have initially used ARM by XA interconnect, maybe we need to go with a network on chip interconnect to handle the traffic load. So there's like a lot of these architecture decisions that can be done at a system level itself. So there are 3 levels of fidelity that we could look at. So let us say you are someone who is building an IP component. Let us say you are building a processor core. So you need a microarchitecture model of the processor code to do the simulations, to do the trade-off analysis at a very early stage. So let us say you are working on an out-of-order processor core, let us say a 13-stage pipeline processor core, and you have the microarchitecture model built in this platform. Then what you could do is like you can run certain benchmarks, you can run certain target applications at the architecture phase itself, vary these parameters. So let us say we are changing the branch prediction algorithms, let us say you are varying the load store unit behavior, maybe the cache replacement algorithms. You are varying a lot of microarchitecture conditions and finding out what is the optimal configuration for your IP. So that is one set of users. So they need microarchitecture models. So let us consider another set of users who are working on buying IPs from different vendors and assembling a system for their application. For them, they don't need to be at a microarchitecture level because they are just buying these processor IPs and just, there will be certain parameters that they can vary. Let us say they wanted, quad core or octa core, so they can increase the number of cores that they are, they want to run the application for. Or maybe the cache hierarchies. So there might be, cache sizes, number of cache hierarchies. There may be system level caches, maybe the cache coherency factor. So they can do that kind of experiments with. And then other is like, so when we are constructing a full system on chip, there could be certain interfaces that might be of less importance to you. So those can be extracted as the traffic generators. So those are sensors which feed in traffic at a continuous rate. So all 3 abstractions can be modeled within a single model. So now, another question that comes up is, how do we know it is accurate? So what we have done over the years is we have run, so let us say we are modeling a platform. We compare the same applications on platform where we are running the simulations as well as on the hardware board. And we run the same benchmark and compare the results that we have gotten from both of them. So here we could see we are running a Tri-Stone benchmark, a simple Tri-Stone benchmark, and we could see the the Tri-Stone scores we got were within 6.02% delta. Not just that, we could see detailed statistics being generated. We can see the average and instantaneous power. We could see whether there were any pipeline stalls that were observed. What was the cache stats, hit ratio, miss ratio, the memory throughput, if there are any buffer overflows, any bottleneck in the system, all of this can be analyzed at a system level itself. Now, this is this is data we captured from a recent project. This was done for Mazda. So they were doing an infotainment, infotainment system using NVIDIA Jetson AGX Orin, and they had run certain spec-end benchmarks as well as Google Net and Rust 50. So we have 2 use cases. One is like where we are running the spec-end benchmarks on dedicated cores, and another case where we are running 2 applications on 1 core. So there is like a scheduling algorithm, time slices, so there is that scheduling overhead. So in both cases, we could see the delta percentage when comparing the accuracy. So we could see that, not just on application latency, but at, cache hit ratios and even memory interconnect, we are able to maintain this accuracy. And this is again modeling accuracy of embedded systems for different components that we were able to capture. So for A77 cores, Wi-Fi modules, camera modules, DSP cores, amplifiers. So for different components that we were able to model using the platform, we were able to compare the accuracy observed from it as well. So now I would like to show you some typical case studies that were done using the tool. That will give you an example of how we can use the tool for. So oftentimes the process starts with a block diagram and a set of requirements. So it would say like, for this particular application, in this case it's a multimedia SoC. So we want to keep the SoC power down less than 2 watt, and the system throughput has to be 100,000 FPS. So for this particular requirement and for the particular hardware architecture, can we meet these targets while running this application. So we can see here in the hardware architecture that you have the RISC-V cores, you have a dedicated hardware accelerator, you have the different, bus hierarchies, memory components, etc. So what we do is, like, this is a visual sim model. So it is a fully graphical user interface. You can just drag and drop the components. Unlike, you don't have to do, you don't have to spend time coding the model up. So the benefit is that you spend more time doing analysis rather than building these models. So you create this model, you can drag and drop in all of these IP components available in the library. So you can just drag and drop it, assemble it up, and then you can define the application flow. So on the bottom, you can see the green blocks that you see in the bottom. That is application flow. So you can see sensor generates a frame, we read the frame, decode the frame, video post-processing, render frame, format conversion, rotate frame, and then display. So all of these tasks are being mapped to the available hardware resources. So as an experiment, initially, we weren't considering hardware accelerator at all. So it was all run on RISC-V cores. So then what happened was, the application performance, the performance targets were not met, but the power requirements were met. So to improve the performance, what we did was we did an analysis of how the tasks were performing. So what we found was the rotate frame task was taking too much resources, and it was not completing within a time day. So what we did was we mapped the rotate frame task to hardware accelerator where it is using dedicated resources. So by using that, we could see that you can see here, like the red plot is for when we are running it purely on RISC-V core. The blue one is when we map the rotate frame task on hardware accelerator, and the light bluish one, that is when we are using hardware accelerator, but we are adding the power optimization algorithm. So what we could find was that the hardware accelerator, when we are running the rotate frame on hardware accelerator, the performance targets were met, but the power requirements were not met. We could see the average power was going beyond 2 watts. So based on the hardware accelerator behavior, we could see that it was only active for very short period of time. So what we did was we looked at the power behavior, and we could see that power optimization algorithm could be added to bring the hardware accelerator down to sleep when it is not active. So doing that, just a simple power optimization could bring it down. So imagine the case where if we have not done the architecture's case studies, we would have procured all these components and you would have produced this product. And then you find that when you are enabling the rotate frame application, the battery backup is not sufficient. Only 30 minutes of backup you are getting with this device. It's a camera module. So then you would have to either go back and do the entire tear down and find where the bottleneck is located. So you can save a ton of time by doing an early architecture case study. So this is another example. This is like RISC-V edge node to data center modeling, where we are doing end-to-end. So we have the devices, and we have the network hubs, the gateways, and the data center servers. So within the devices, we have, starting from sensors, analog front end, we have the MCU, we have the Bluetooth core, we have the transmitters. So we are modeling the entire pipeline flow and analyzing what will be the latency, the network latency, whether the server has to be modeled with much more capacity, can it handle all the LLM workloads. So we could do a case study analysis here, and we could see what was the power consumption. So these are like IoT models. So we have to be power efficient, each of the devices. So how much is the average power consumption over time? What was the network latency? Are we able to get a response back from the server within a limited budget? And what was the Bluetooth core activity? And now the final use case that I would like to show is so this was again for an automotive application, and for this customer, what they wanted was they had to choose an SoC architecture from a product, a family of product line. So they had to choose from in-order RISC-V core like ANDAS AX45MP, out of order RISC-V core like ANDAS AX66, Tensilica HiFi DSP, Neo NPU, and Tensilica LX8. So, and we had to use what would be the best interconnect to choose from, by XI, network on chip, or a custom bus architecture. And the applications that we are trying out were ABS, ADAS, and fully autonomous driving application. So in the first case, what we did was we went with a single order architecture, and we had just 4 sensors. So we are using the AX45MP, a single order in order, and which had private L1 and L2 caches, and it had 4 dedicated DMA channels, and it had 3 preprocessing units as well. So overall, when we run the application on this architecture, we could see that it only consumed 13 milliwatts of power, peak power, but the application latency was around 950 microseconds. Now, the same application, we took it on a medium-end ECU. So it is a dual out-of-order core with 8 sensors and sensor fusion. So we have more number of sensors being handled here, but we could see that the ABS latency, the application got completed with 400 microseconds. But the power went up from 13 milliwatts, it went to 360 milliwatts, but the application is able to complete much faster. We can also see that the medium end ECU is able to run ADAS as well. The low end was not able to run ADAS because of the resource constraints, but medium end was able to run ADAS as well, but it took 500 microseconds. Now, the high end ECU family, so that has octa-core NPUs with DSPs and safety islands and NOC. So it was able to run all the applications much faster, but it was consuming more power of the bunch. So it was consuming about 1.365 watts. So we could see some of the plots that we were able to generate from this. So this is the low end ECU on the left. So you could see the application latency, right? So you can see the peak application latency goes up to 1.2 milliseconds, while at the high end it is only about 90 microseconds. And we can also see the power plot. We can see in which period of time it is, which is very high activity across the cores, and where it is very low activity. And this is again, we are comparing the ADAS application and autonomous fully driving application at medium end and high end. So from the power plots, we could see that, the high end definitely consumes more power, but there is enough headroom. If you are using high end ECU, you can add multiple applications down the line. So this is like a quick summary of the results that we were able to derive out from a system level architecture exploration. So the low end ECU, it consumes the least power, but not all applications were able to run on it, because you can see ABS itself took 950 microseconds, while on high end the ABS task only took 95 microseconds. So now to just give you a summary about introduction to what Visual Sim Architect is. It is a graphical user interface tool which allows you to do system level architecture exploration. You can do, if you have, let us say, system C codes, RTL code, you can bring it into the platform. You don't have to rebuild everything from scratch. We also have a very large extensive set of library components from which we can drag and drop the components and assemble the system. So that way, so the main idea is that you can spend more time doing analysis and case studies rather than building models itself. And this is the list of library components that are already available within the platform. You have a large set of RISC-V cores, ARM cores, GPUs, TPUs, NPUs, FPGAs, multiple interfaces, we can do failure analysis as well. So let us say, we can have cryptography units, encryption units, everything modeled within the same platform at a system level itself. So I would like to just bring one of the upcoming activities into attention. So this is like there will be a hackathon that is being planned to happen on October 3rd and 4th. So this is like completely free of cost. Anyone can register for it. The tool will be provided free of cost. You can come in, learn about how to use the tool, learn about the different applications that are being used by different customers, and there will be different problem statements given to you as well. So in this hackathon, there will be multiple sections. So let us say you are more interested in digital side of things, or maybe RF or analog side of things. You can focus on completing the hackathon questions related to that area. There are hackathons for sales and marketing as well. So if you are interested in those aspects, you could also join in. And once you complete the hackathon, the top 10, top 20 attendees will be given prize monies as well as job opportunities. And especially I would like to point out one other thing is for universities, we provide a specialized, a program that we call SEAL. So Semiconductor Embedded Systems Architecture Lab. So where you can, currently it is being deployed. There are universities across the world who are using it. So for example, they have integrated this architecture exploration at a system level part of their curriculum. So students will be given laboratory assignments. They would complete architecture exploration. For example, designing of matrix multiply units, designing of cache algorithms. So these are things that they could do it at an architecture phase, at a system level. And since it is graphical user interface, the students are spending more time, learning things rather than spending time coding it up. So this is also another way that you could, and also there are PhD students and professors using it for their own research programs as well. So because let us say you want to deploy a certain application for edge AI processing, and procuring these boards are very expensive. But what if you can simply create a virtual prototype of it using the platform and run your application? That makes it very convenient. So and you can always come and contact us. We have a booth here. If you need more information, please come and visit us. So I would like to thank you all for being there, attending the session. If you have any questions, please feel free to drop an email to tjos@mirablesdesign.com. Thank you.
Thank you, sir. We would now like to present a token of appreciation to Mr. Tom Jose. We request Patanjali, sir, to present this memento. Now, we've heard from the leaders, but now we turn to the disruptive engines of innovation, our startup sponsors. Startups are the primary catalysts for technical growth. They embody the entrepreneurial spirit that pushes boundaries, taking bold ideas and turning them into reality. In the RISC-V landscape, these ventures are crucial. They bridge the gap between research and commercial success by building high-impact, scalable hardware solutions. We are honored to feature these innovators. First, we welcome Vyoma Systems, who are tackling the part of chip design nobody puts on a poster, making sure the silicon actually works before it is ever fabricated. Vyoma Systems is a Chennai-based deep tech startup founded in 2021 and incubated at IIT Madras Pravartak, working on one of the hardest and least glamorous problems in chip design, pre-silicon verification. Their Uptick Pro platform delivers verification as a service, bringing together functional verification, FPGA-based validation, early software bring-up, and side-channel security analysis in one cloud-enabled environment. In short, they make sure that the silicon is correct and secure long before it ever reaches a fab. We welcome Ms. Lavanya Jagdishwaran, ma'am, founder and CEO from Vyoma Systems. Over to you, ma'am.
Hello. So we skipped my bio because I've been here too many times. So, good afternoon, everyone. We generally start with this slide for students so that we connect with some electronics that you generally use in your day-to-day life. And to be the motivation for not just as consumers, but as developers. But the talk is going to be a bit more than what we generally do. So that is the idea. The motivation for us to present Vyoma Systems to you. So how often do you buy these? Do we understand the pictures? The mobile, the automotive industry, the compute platform. Right? So these are the things that we target majority of our electronics into, and it has the larger market even in the RISC-V domain. And what can you do is the general question we ask the student community the upcoming fresher electronic graduates. Just to put things into perspective, what we see is all of you change your phones 2 to 3 years once. Why? Because better performance, better looking phone, Apple phones based on earning capability. We also change our computes, the laptops, 4 to 5 years on an average, because again, we want better performing processors on which you develop your software or watch movies or play games as the need may be. And of course, there is an automotive industry, comes later in your career, where you start buying your first car and then keep upgrading it. All the electronics involved in this requires the domain expertise that we have been talking about in the past 2-3 days. And the motivation is for you to become not just the consumers of this, but the developers. So the motivation was for you to come on this side of it, be an electronics engineer who can design chips, RISC-V chips, or verify, or build physical design expertise, or build the software stack around it. But when we were doing this, we found the imbalance. We have a huge electronics market, but the self-reliance for that still is happening. And that is what the Shakti and the government initiatives together, as well as the startup communities that are trying to execute, is trying to prove that we will build the self-reliance up. This is all funny in a way that we assumed that, yes, we are all electronics experts within double quotes, where we have understood the industry, we have been in the research with the R&D labs in IIT Madras, and we have started our entrepreneurship journey. So kind of we have figured out the self-reliance. We know how this VLSI flow works, and so we go and deliver, right? But we had our Bahubali moment in the past few years, where we started becoming more relevant in the AI hardware field, where the ChatGPTs, the AI, Gen AI application required a very different hardware. The hardware that we know is still relevant, but with some difference. It is not 2 to 3 years or any of the yearly things that work. What we are looking at is 3 to 6 months. The model changes and the model gets used, deployed, then dropped, and then better model comes. Are you ready to sit with the first ChatGPT model and then do your asking? No. So you are looking for better models every few months, and the best that can be delivered is through better hardware. So this is not just what you can do, it is becoming even relevant in the RISC-V world, where 43% of the market, AI market, is being dominated by RISC-V adoption because the ISA itself is open source. So we are seeing the reality, but that reality is not getting translated to the 3 to 6 months. And we hear such statements. One, hardware is the new software. Extreme, we have seen in the panel, extreme hardware software co-design. You design very customized to the application that you are running, the model that you are running, because you need that kind of a performance in your hardware. So what it means, or what it translates to in a different way for silicon engineers, is the silicon that we need today or that we use the applications that we use today, for that the silicon does not exist. What does that translate to again? So till now we have been telling domain expertise, build the knowledge, have it in part of your foundational courses, develop it, apply it, and make it as your career. That is the gyan we have been giving. The gyan that we as domain experts have to take is that there is a pace mismatch. What that means is the few months of silicon needs that are coming up, more advanced performance is required. They are all power hungry, so you have to match the requirements for that too. Different requirements for different domains. The pace with which the software is evolving, the pace with which you are developing your softwares, the hardware does not exist, and the hardware space is 5x slower. The silicon pace for the first time, yes, it has been there. Time to market has always been there as one of the goals, but it was a nice to have feature for a lot of silicon companies. But for AI hardware companies or the silicon of the future, the silicon pace has become a liability. If you don't have the hardware, you don't have the performance as of today. A switching gear of what we have been delivering till now and how it's changing for this AI world. So what we have been saying is the basic time to market. You have a chip, we cater to RISC-V design companies. So we have a RISC-V chip, how to verify and maintain the quality for that. So we take that as a use case from the Shakti processor, where you build the design, you generate test cases around it, and you simulate it in millions and millions of clock cycles, and make sure it performs correctly with respect to an instruction set simulator. This is the normal flow that we have. The difference that we brought in is in the methodology, where we said the next gen likes Python. So let's develop something of an infrastructure or a methodology for this quality with Python. It was a hit. We have students in Shakti lab who have started becoming verification engineers from their second year. And yes, this conversion was a success. It also found industry relevance because there also pace mattered, and RISC-V was an emerging design. So they didn't have the legacy on which you have to fight against. So it was easier to adopt CocoaDB based verification for upcoming startups. But this story has become outdated in 2-3 years. So what should we do is the question that we are asking. And we would like all the engineers here to join that journey of redoing the stuff. This is the basic VLSI design flow. I'll just go through for reference. You start with RISC-V specification document, where you look at English language coded intent of the design. You take it through the architect model and then see how it meets your PPA targets. You implement it using system Verilog or Verilog, and then your simulations comes into picture. You verify, you go through the physical design flow, and you tape out your chip. There is also an angle where the system software gets built. So this is the normal flow. This flow, even with the methodology that we built, only verification alone for a processor takes around 4 months. It's the processor that we understand, we have already taped out. With that, if we develop a new SoC, it takes 4 months. But if you want to convert it to something as an AI chip, full from design to silicon, it is not going to cut it. So that is why I meant pace is a liability. And this is where Vyoma or the Uptick Pro platform that is going to target for, where the agentic flow has to come in at each of these levels and it has to converge. Do we have the solution today? No. Does any of the global startup ecosystem have the solution? Yes, for some of the verticals, not for the whole thing. Yeah? So that is what we are looking for and finding the solution, where the context of each step has to be fed in a different way to each other step. So if you solve the problems, let's say we are currently solving, you would have seen in the demo also. From the verification perspective, we are trying to solve the problem that the coverage closure can be done using the agentic flow. Sure. But that is like applying AI to one domain and then leaving at it. Again, we understand the reality that that does not cut it. There is customization that we have been talking about that comes in the hardware. And if we slow down each and every step without understanding the full context, then the agentic based VLSI flow becomes also a liability. So that is the biggest problem statement that we are looking at, that we want chips at the pace of software, and how to go about it is something that is the biggest opportunity that is lying in front of us. With that, I come back to the title, and this is the end. So, can silicon meet the pace of software is the question, and that is where your career is heading, and that is our intuition. Thank you. Oh.
Thank you, ma'am. We would now like to present Lavanya ma'am with a token of appreciation presented by Patanjali sir. Moving on, we now have HCL GUVI. GUVI is an edtech platform incubated at IIT Madras, best known for teaching technology in India's vernacular languages, making programming and engineering skills accessible to learners far beyond the metros. Every chip in this room needs engineers to design it, verify it, and write software for it, and that pipeline is exactly what GUVI works on. Please welcome Mr. Arun Prakash, founder and CEO of HCL GUVI. Known as Mr. T-Man for his affinity to technology, Arun Prakash has led HCL GUVI to 2 Guinness World Records in online tech education and was invited to Oxford University to speak on how vernacular learning is transforming technology education. He brings over 20 years from Honeywell, PayPal, Calido, and Symantec, and is a TEDx speaker and award-winning social entrepreneur. Over to you, sir.
Hello. Yeah, it's working. Perfect. Sounds good. Okay. Hi all. Good afternoon. Okay. Sorry to be at the wrong time. Okay. So as all young kids, we work only after 11 p.m. and we sleep in the morning time. காலையில தூக்கம் வர மாட்டேங்குது. காலையில தூக்கம் வருது, நைட் தூக்கம் வர மாட்டேங்குது. This is a common thing which we all go through it. So today also the same thing could happen. So அதை destroy பண்றதுக்கு தான், my job is to destroy that. So one of the bad thing which I have is I point out at people and ask. I'm worse than your professors. Okay. So I'll point out whoever is sleeping, wake him up. Whoever is that like that, I'll do it. Okay. So I saw somebody who was sleeping. Now luckily he moved out. Okay. If you are not looking at me, I'll ask questions directly to you, not to the crowd. Okay. So let's say for the test, right? Yes, you. Maroon color, you are looking it down, right? Yes, ma'am, you only. Get up. No, background. Maroon. Yes, you only. எந்திரிங்க. அவங்கள அவங்க ஒளிஞ்சு உட்காந்துருக்காங்க. நீங்க தான். Yes, you only. எந்திரிங்க. This is how I do it. எந்திரிங்க, பரவாயில்ல, எந்திரிங்க. எந்திரிச்சு உட்காரலாம். You can get up. Yeah, this is how I do it. Okay, I won't just do a demo. So you don't have a choice. When I look at you, please look at me. If you don't, I'll point. Okay, just now we escaped it. Okay, black t-shirt. Okay, so this is how it is. So the reason why I'm doing this activity is, so I know how hard it is to be at 2 o'clock. Come on. Yes. Okay. So before getting into the RISC-V, when I was a student, I used to always have a question. In the software world, they have multiple programming languages. இன்னைக்கு C படினுவாங்க, நாளைக்கு ஜாவா படினுவாங்க, C++ படினுவாங்க, பைத்தன் படினுவாங்க, C# படினுவாங்க, பத்தாவதுக்கு இப்போ Go படின்றாங்க, Rust படின்றாங்க. I don't know what one I need to study. This used to be my question. This is one set of questions. Another set is another world. There are a lot of frameworks. Angular, React, Node, Node-RED. What to do, what to learn, I don't know. This is one of the biggest questions when I was in my college days. And I couldn't find the answer for a long time. Okay? But I figured out after becoming an entrepreneur. Okay? It was too late. Okay? But at least I want to share that info to you so that you guys at least look at it in the right way. Come on. Okay. The question is, I'll put a simple question. Whoever answers right, I'll give 500 rupees. Right away, I'll do GPay. Okay? The question is, this is not the question. How many, this is the prelude, how many languages are in the world? Sorry, how many religions are in the world? Rough number. You can Google it, you can look at it anywhere. Rough number, random number. Sir? I'll ask the professors as well. Only 9 religions in the world. No, this is just a sample set. Random, a bigger number, you can say. 50 religions. Okay? 5,000. 10,000. How many people? Billions. It's not about the spirituality. He's saying like billions of religions. 1. Okay? That's another strange answer. Anybody else? So, 4 to 10. No, all religions. I don't want major. Even minor is also fine. 4,000 to 10,000. So let's go with that number. Now the next follow-up question. Again, this is not the question for 500 rupees. The follow-up question is, name 10 religions in that list. Let's say make it 12. 12 religions in the list of this 10,000 religions. Buddhism, Christianity, Sikhism, Hinduism, Jainism, Zoroastrianism, Judaism, Taoism. 8. Confucianism. Yes, it is there, I agree. 9. 3 more. Islam is done. Scientology. Let's take Scientology also a religion. There is a big group which is mad about it. 2 more. Shinto. Atheism, I don't count. I'm an atheist, so I don't count. One more. Tell some names. I'm not here to promote any religion. Huh? Nod. Is it a religion like that? No, if it is there, I'll agree. I'm not here to debate. Judaism already counted. Sikhism counted. Baha'i is a religion? Okay, it says there is a 12th religion, Baha'i. Okay, give a big round of applause for all of you. For the 12 religions. Out of how many? Out of 10,000, we couldn't figure out 15. 12 itself is hard for us. Okay? Now this is a real question. What did these 12 religions did something which other 10,000 couldn't do it? If you answer this is a 500 rupees question. Best marketing, correct. That's true, but not so. Why? Why? How? Why or how? Whatever it is. Community. Why the community followed? Why not others? These guys have religious text. So if you are saying that remaining 4,910 didn't have the religious text. Trust. These 10 gave the trust. 12 gave the trust. These gave the crowd. Okay, which is a marketing thing. Marketing leads to the crowd. What is the reason? What would be the reason? Yes, sir. Okay, it suited me. Okay, so that is what he is saying. Nothing wrong in that. It suited me for some reason. Why people picked it? That is also, see, we'll do this for 5 minutes. Whoever says it, closer to it, I will give 500. I am not trying to save my 500. I am trying to ask why as much as possible.
They had a way of spreading their...
They have very good marketing. Way of spreading is marketing.
Some were born into it.
Sorry? You are born into it because the crowd is there, because the marketing was done to the crowd. Why? Why was marketing done to the crowd? How was the marketing done to this crowd?
It was modified in a way that fitted their lifestyle.
So the ad was again appropriate for you. The Instagram videos were for you from these religions. This is again nothing marketing. So still he is winning it.
Fear of persecution.
Fear. That's a very good point. Fear of persecution. Networking and risk sharing. I didn't get it. I didn't understand. Leave it. Let's move on. This is a valid point. Somebody said about beheading. If you don't, I'll be. That could be one powerful reason, right? Fear is such a powerful reason for a religion to exist. Colonization, yes, same thing. Exactly, colonization. Every colony spread it. Expand on it. That's a valid point. He is very closer to me. No, nobody cares about it. We shift. We can associate because the marketing is done in the right way. But the clue is, his answer is the clue. Colonization is the clue. Tell me, he is around winning the thing. So if the colony is there, the marketing can be done better. So he has gone one level up to it. Set of rules. The colonies gave the rules, and then that's what it is. Again, you are going to his thing. So he is the winner now. Exploration. Yeah, colonization lead to exploration. Yeah, because you went there, you are exploring it. Enforcement. Who enforces it? Money and the power. Correct. That's true. Money and the power. Every religion runs on these two activities. Sorry to offend. I'm not here to offend anybody. That's a fact. Deep state. In the sense? I know fake. I don't know deep state. I don't know.
They want to control everything.
Okay, they want to control everything. Yeah, that's what. Money and power. What he said is right. The colony, money and power. These are the cues. Good leader, correct. Possible is there. Like for example, let's assume which are these religions are you started loving because of the leader. When I say you, your forefathers. That is now. Earlier I'm saying. Now it is. Now the same game is in a different thing. Okay. When it started, these 10 religions, who was the leader? Who was pushing it?
Created a hierarchy to control people.
Created a hierarchy. Who created a hierarchy? Who? One who wanted to govern. Awesome. Who wanted to govern? Correct. Who wants to govern? Colonization, govern. Who wants to have the power? That is what you mean by govern. That's a govern is a political word. Power is a real word.
So just to expand my answer, exploration of the unknown.
It happens for few, not for the masses.
It's for the masses. We don't know what exists. So they may have...
No, masses follow when something is forced into it. That's a fact.
Yes, definitely.
Exploration is done by the early adopters. Okay, early adopters are always low in count. Correct? That's the thing. That's the answer for you. So, power, govern. She was close. Somebody. She is the winner now. The power shifted from there to here. 500 rupees here. Leader, that's what, tell me a little more clear. Fear from whom? Fear of whom? Who will persecute? Who is the powerful people? Who is the one? Who is the one? Who is the one? That is what I am trying to answer. Get the answer. No, there is no capitalism in the old world, right? It's a new word. Who wants to control? Who wants to have the power? Who used to have power? Somebody said it. No, not humans. King. Who said king? Please stand up. Give a big round of applause to him. Whatever the king decides is the religion of that land. Buddhism was born in India, but it grew in where? China. Correct? The same thing. I mean, you know all the colonization story. Everything is towards that. Please. Correct, correct. Who? Somebody has to fund the scholar, right?
Yeah, but he doesn't, like, I can go somewhere else and I can explore it.
Correct, correct, correct.
He doesn't need a king's funding for it.
Ah, correct. So now this is a good debate. We'll have it. I'm not saying that's wrong. There is a funding which is needed for any research person, which is the scholar, for the professors who is writing the projects, PhDs. Somebody has to fund. In your case, it's your VCs or your college or government. The same story goes in the old days. Okay. So there are some scholars who doesn't need that. So there are most of the scholars who needs it. Okay. So the king decides what's going on. Correct. So you have the GPay number. Give me your GPay. I'll pay right away. No, come here. Don't tell the name number. You type the number here. I'll pay right away. Okay. Let him type it. Now let's go to the question time. 500 rupees time is over. Okay. Who is the kings of the current world? Corporates. When you say corporates, make it the name. Name the corporates. Nvidia, AMD, Apple, Samsung, Google, Intel, Microsoft. All these are the kings of the current world. So let's try to put that analogy over here. Which are the frameworks that you know in web? Somebody said something. Huh? Little louder, please. React. Who was supporting React? Yes, sir. Please. Next. Who was supporting React? Meta. Thank you. Meta was supporting it. Who was the ruler of the world? Correct? Now you get the answer. What are the competitors for React? Flutter, Angular, Next. Angular is the most popular thing, right? Who was supporting Angular? Angular is from whom? Okay, let's go to the languages. Java, who supported? Oracle. That's an easy answer. Oracle. C#, who supported it? Microsoft. Okay. What else? C died because nobody supported. That's a good religion. Unfortunately, died. Python, who is supporting? Every AI company is supporting it. Okay? Because it's open source, nobody is there, everybody is trying to relate it. So, whenever you pick some technology, one way is to look at the good technology and learn it. Nothing wrong in that. Another way is if you want looking for a job, go and look the technology which the kings are supporting and learn it. This is a simple hack which I realized. Fair point? Okay. You paid him, I'll pay him. Yeah. Please. Got it? Check it. Big round of applause to him. So now let's do the same exercise in your case. What are why RISC came into play? Now let's do the same game in this. Why everybody is supporting RISC? ISA was closed. Closed by whom? Intel and AMD ARM. What was Intel's architecture? ISA? Sorry? x86. What is the ISA? RISC. Okay. 86 is better, I guess. That is even better. x86 is them. What was ARM's? RISC. Okay. So both the guys are trying to control their own thing. They are the kings of the world right now. So the others has to take it out. Who are the others who was deprived of those two things? Who was not given this RISC or ARM and 86 thing? No. Country level. Which country didn't get it? China didn't get it. Okay. So what he'll do? He is a king. He has so much of money. He will push the money into the game which he wants to play. That is how RISC came into play. Very simple thing. We know all the good things about RISC. Like every other religion, it's a good religion. There is no question in that. I am not blaming any religion. I am not supporting any religion. But in the game of politics, in the game of power, right now, China wants RISC to be there. And India wants it. Why India wants it? We want to play the power game as well. That is what we did it. We don't want to surrender ourselves to UK or US. Simple. That is the answer for this. Okay? Come on. Okay. I'll come back to this little later. Okay? It was a simple 3-month project. Nobody cared about it, the RISC one. It was there dormant for 15 years. No one cared about it. All of a sudden, this religion became a popular religion. For the simple reason, there is a power behind it. Okay? We can say all other stories, good things to believe to us, but the reality is this. Come on. Okay? See, this is the thing. US is the birthplace. China state embraces it because he wants to do it. China +1. These are, how many of you know the word China +1? Go and check it out. That's a very important word for you guys, not for us. For all the youngsters, you should know what China +1 means. Okay? Then obviously India. India wants to be in the game. Okay? So this map, keep it up in the mind. So this is a map of RISC. So this is what it is. See, it started in 80s. Okay? It just inflection came in 2025. Whether you like it or not, this is going to be the religion of the world soon. Because all your processors, you take your Snapdragons, your iPhone, or any other process which is out there, Android is pushing it. Another ruler is pushing it, which is Android, which is Google, which is a powerful ruler. He is also pushing for it so that he can take away the control from Intel and ARM. He wants to rule the world through Android as well. That is his religion. Okay? So everybody is playing the game. Come on. Yeah, done. Okay, I'll close the thing. Okay, I'll skip all those slides. So this you can read it everywhere. Okay, so this is what the instruction set is. I'll skip all the things. My job is done. So all the things are there. So what GUI does is, GUI is a skilling platform where we are there to skill up these things, whatever is in the market. So I used to work in PayPal. I used to work in KLA Core. I resigned it and started this because I hated engineering colleges. Sorry to say that. Okay. So I am an engineer by chance. But now it is, I love engineering. After getting into that, I understood the reason of it and I started doing it. So this is a program where we did with IIT Delhi. It is closed. Sorry, it is over. But come on. So this is another free online course. Right now we are giving it for free. We are not charging anything. This is nothing to do with any other course. You can, if you want, you can go and learn here. Okay, go to GUI. You can find it. You can get it. There is a stall at there. Sivagami, stand up, please. So she is there. You can reach out to her and ask the coupon codes and get it done. Thank you all. Bye-bye. No, I understand.
Thank you, sir. We now request Patanjali, sir, to give you a token of appreciation.
Next up, we welcome Entra Innovations. They are indigenous silicon aimed squarely at the automotive industry. Entra Innovations, an IIT Dharwad incubated startup, is developing India's indigenous TPMS tire pressure monitoring system SOC, low power, secure, and feature packed for improving fuel efficiency and automotive safety. Backed by MeitY, C2S funding, and IIT expertise. Please welcome Mr. Ritesh Beldurgi, co-founder and CEO from Entra Innovations. Ritesh Beldurgi leads Entra's vision, strategy, and engineering roadmap while concurrently pursuing his PhD at IIT Dharwad. He brings over 12 years in the semiconductor industry, applications engineering at Intel, formerly Altera, and FPGA design at Unison Technologies, spanning defense electronics, consumer electronics, and high-frequency trading networking.
Over to you, sir.
Thank you. Clicker. Hello, everyone. I guess I'm audible. Thank you, DIR-V team, IIT Madras team, Lavanya sponsorship chair, for quickly onboarding us into this symposium and giving us opportunity to talk the good work what we are doing here. So, good evening, everyone. I know it's tea time, but I'll not take much of your time. We'll keep it short what we are doing and explaining about what we do and a bit about security aspects about the TPMS or the SOC which we are building. So myself, Ritesh Belgudri, I'm co-founder and CEO of Entra Innovations. Today what we are going to look into is how security impacts, or how security is very important for a chip which sits inside the tires. And this is the sensor which goes inside the tires of your automotive. It could be cars, two-wheelers, or even big commercial vehicles like trucks and buses. So having said that, in core, the previous presenter has already put a lot of context to this presentation on how security is built from silicon IP, from the IPs to silicon to systems. So building on top of it, I'm going to double click on an application. I'm just going to go a step deeper into how security matters for automotive SOCs and what all considerations we should do while designing an SOCs typically for automotive applications, which is very critical. You know, let's take an example. Just like I said, we're building a chip which is as small as this, which goes inside the tire. It's going to be a form factor which actually has a coin cell battery and which goes for around 5 to 7 years. So, and what is going to happen is India is going to have mandatory TPMS coming soon. There is AIS 154 standard already built, has come out, and we have seen Europe, US has already TPMS made mandatory. So upcoming all of these vehicles, all of our vehicles are going to be TPMS enabled. That means we should be ready for the TPMS, and with TPMS there is a chance, because the TPMS comes with a sensor temperature sensor and a pressure sensor, and since the tire is rotating, you cannot put the wires there. So you need a wireless protocol which should transmit the data back to the ECU. So there is 433 megahertz transmit and LF 125 kilohertz receiver. Now what happens is this chip itself is a very low powered. It's a ASIC which needs in nanoamperes and which draws nanoamperes and or maximum microamperes of current. And the form factor is very, very small. So we cannot, because just imagine what is the diameter of the tire, right? It has to be fitted, it is very constrained. It has to be fit within those boundaries. And interestingly today, when we talk about silicon, we talk about RISC-V. The most important aspect of RISC-V is software. And in our case, it's a firmware. It's a small baby C code, which is a bare metal C code running on this chip. We don't have a OS, but still this small firmware also is very important, which we'll talk about. So today we'll look into side channel attack. And the side channel attack means you just have to put a hat of hacker now in the rest of this talk. So we'll talk about secure boot chain, which is hardware root of trust. So what we do in our chip is first we release the reset on power on. So there is a hardware engine which takes care of security. Now the security means that we have to have the boot secured. So that comes from a boot ROM. So there is a boot controller which is written in RTL, which actually boots up your CPU core from after power on, before the CPU starts executing. Then what we do is we decrypt the firmware which is sitting inside the flash using AES 128, and we measure that hash key using SHA 256, and that key is stored in the eFuse, which the earlier presented talked about in one of the slide about the security aspects should have a one-time programmable element, which today we call it as eFuse. And then what we do is we verify the app using the first stage bootloader, which is FSBL, then uses ED25519 signature to validate the integrity of the software which is residing into the flash. So if all of these checks are passed, then only CPU starts executing. Now that means, just as an analogy, when we all are coming to this conference, we make sure that we register to the conference, we sign in, basically we give our some basic details like email ID, phone number, our affiliation, and then there is an authority which approves it. So only once that is approved, then you are allowed to come inside this campus and you are allowed to listen to the talks, and you are allowed to participate into the symposium. And this is all done for sake of safety and security. So the same thing, the same analogies, if our systems has to be secured, it has to go through the safety procedure, which is the hardware root of trust. And hardware root of trust is needed because it's very critical that it has to be done very faster. We don't want systems to be hang or maybe keep booting forever. So the key elements here are OTP, one-time programmable memory, which is eFuse, which stores the keys. Then there is a signed firmware and the secure updates, which holds. Actually what we do is, whenever the malicious code is trying to be loaded onto the flash, and if the security validation is failed, we have a counter which just keeps counting, and once the counter threshold is hit, we freeze the silicon, means the silicon or the chip is unusable. So that way the hackers are not allowed to enter into the system. Now there is also a trade-off, because today we talk about all good things. We do have we can get the highest security of in the world into the chip, but the biggest challenge and the trade-off is the form factor, which is just as simple as our silicon is 4 mm by 4 mm. So we need to add security features in a small form factor as possible. So with that, it also adds to the latency, because as the area is small, there are few algorithms we cannot implement on hardware, and we rely on software, and that's exactly what the slide talks about. So the boot latency increased. In our case, we run some simulations, and after running simulations, we found that the boot latency is taking around 40 seconds, and 40 seconds is big number. For example, when you switch on a car, you don't want to keep waiting until all your tires the tire TPMSs are booted and you see the value and then you start. So you really want things to be done faster. So the candidate fix, what we did was, we built an hardware SHA accelerator. This is a good example of why do you need an hardware accelerator engines into your chip. Then there are two crypto primitives in our chip. One is hardware-based SHA-256 and software ED25519, which is used for authentication of the upgradable app. Then very important is the classic backdoor, which is JTAG. So today we use JTAG for system bus access and also accessing the flash where the program memory is sitting. So this provides a vulnerability wherein you can actually access the chip if you get an access to the JTAG. So it's a threat. So what we do is we shut down JTAG whenever the chip goes into production. And also to add to more security, we made sure the SPI flash, which is external flash via QSPI, that only has write access to wherever needed. For example, the first partition what we have is the FSBL section, first stage bootloader, the bootloader itself, that the processor is not allowed to touch. The firmware program area, which is partition 1, that also is not writable, it is just read. And the third part, which is user data, wherein you can store tire pressure, temperature and pressure values. So that is also, that is read and write. So we partition with read and write accesses. So now in the, when we talk about engineering, there are always trade-offs, and what we have done is we know the trade-offs, we know the limitations, and we have tackled it one by one by adding hardware features, by adding hardware accelerators into our chip. Now let's talk about side channel attacks in real world. So particularly in today's connected car era and with autonomous driving vehicles, this is very important because research has shown that there are side channel attacks. For example, just like we just discussed that our TPMS has an RF device which transmits data from the sensor to the ECU. Now when that is happening, you can actually, someone can come and then spoof the channel and start transmitting unintended data. That will actually try to reduce the lifespan of the coin cell, or it can also reduce the performance of the system, or it can even make sure that it can also put the vehicle in trouble. So there was research done by University KU Leuven in Belgium and also Brigham University in England. So they did profile the commercial available fob which has 125 kilohertz transmitter, and they were actually having a security threat. Then there was a voltage glitch found by Black Hat conference. This conference happens for the hackers, and they found a vulnerability in Tesla vehicles, and that to infotainment system. And this is very crazy because you don't really worry about infotainment. You feel that infotainment is just for, it's not critical device. But when you have a car which is fully automated, you have a car which is running on its own, you don't want to risk anything. So that's why whenever we are building a chip, and fortunately what happened is, again, thanks to mighty C2S program, we started building this chip. We had to put a number. Today in India we sell 220 millions of tires per year. So that's a market opportunity which we have. And in previous talk, the market opportunity is big, is what was discussed. Lavanya presented, and I think I agreed with her. Including the tires, we have 220 million tires opportunity ahead of us. And I would like to thank mighty C2S program for giving an opportunity for us to build silicon in India. And we take that as an opportunity to build a secure SoC, because security starts at home. We cannot rely on our neighbors to build security for us. So we are focusing on side channel attack. So any researchers, any students wants to explore and wants to work on security, let's collaborate. Feel free to drop a note to me on LinkedIn. You can visit our booth. Some of you would have already visited. Thank you. Thank you for listening.
Thank you, sir. Please accept the token of appreciation. Next up, we have Caligo Technologies, a company rethinking how computers represent numbers altogether. Caligo Tech is a Bengaluru-based fabless semiconductor system startup serving high-performance computing, big data, and AI workloads. They built Tunga, the world's first 8-core POSIT-enabled RISC-V CPU, by combining RISC-V, the POSIT number system, a rethinking of how computers represent real numbers that delivers better accuracy at a low power. Their next chip, Matunga, is built on CDAC 64 Vega core. This is a rather nice illustration of this ecosystem working exactly as intended. Please welcome Mr. Madhan M., Head of HPC Software from Caligo Technologies. Mr. Madhan M. brings over 30 years of experience in BIOS, firmware, device drivers, and system software, having worked in India and US at AIML, LSI, Adaptec, and PMC. He now leads the full HPC software stack for the Caligo Uttunga POSIT controller. He will speak on Caligo Uttunga, world's first POSIT numeric unit.
Good afternoon. Am I audible? Fine. Okay. So, most of you have walked by our booth. You have seen what product we have today. You have seen where we are. So, we will do a quick recap on what Caligo has achieved in the last few years since the number system challenge of floating point having a few inadequacies, especially when you go into higher order of accuracies. Like everybody thinks floating point is financial transactions where you can have some pice that can be given to you, right? So financial transactions is the most important transaction. That's what we all think. And that needs only 2 decimal places, right? Third decimal may be to round off in stock market and things like that. Floating point is able to serve that. So we don't want more than 2 or 3 decimal places of accuracy. Everybody is happy. That's how we have all been happy all these years. But now with fluid dynamics, immunology, biotechnology, and all those high accuracy computing coming into play, we are seeing that 6th decimal, 7th decimal accuracy is becoming more and more important, and floating point struggles in those areas. So there is a new number system which was proposed by Dr. John Gustafson, who is a mathematician. It's called POSIT. So this is where we started from, right? So trillion-dollar decisions on math are now in the hands of floating point, and it is not 100% trustworthy, right? So the simplest example I can give you is A plus B plus C is an associative operation. So no matter in what order you do A plus B plus C. You can even be more adventurous, you can do A plus C then plus B. Whatever you do, it should give you the same result. In integer world, that works. But in floating point, it's not always guaranteed. Because your A plus B, if you do first, the result gets rounded off. And then the rounded off result gets added to C. Right? So similarly, if you do B plus C first, that result gets rounded off. And then the B plus C rounded off result gets added to A. And then that result gets rounded off. So every stage when there is a rounding off, there is a variation in arithmetic. And this becomes even more pronounced if you do parallel processing, right? You give a job, split it into, let's say, 4, give it to 4 different cores. One core is doing A, B, C in different order, another core is doing it in different order. Then you put it all together, the result may be very different. And if you think about clusters, where you are now sending it to different kinds of machines, some machines may be running on Intel, some may be running on AMD, right? And each of them have their own implementation of floating point. So all these problems were identified long time back, but it was still okay for us to live with it. So till John came and said, okay, you know what, there is a number system which solves a lot of this. So that is mathematics on paper. It's been debated, proved, again debated, right? So there is a lot of articles, white papers on POSIT. So what Caligo has achieved? Okay, this is the mathematics. Yeah. So what Caligo has achieved is that we have taken that mathematics from paper and created the world's first POSIT-based octa-core RISC-V numeric coprocessor. Right? This is the world's first. We had about 50 boards manufactured for POC, and those are the only 50 of POSIT-based numeric coprocessors today existing in the world. And this is completely made in India, completely made in Bangalore, from scratch, founder, engineer, software, hardware. It's a small team of about 30 people who have achieved this. Right? So today, Tunga is the chip, is the numeric processor. And for access, we have mounted it on a PCI board. So we call it Tunga, which is the peak, right? And the only reason the PCI board is there is because we need some channel today to send data to the numeric processor, right? So the numeric processor ideally sits very close to the core processor. And then, you know, the core processor, whenever it needs arithmetic or a floating point operation done, it will offload to the numeric coprocessor. So today I can't go to Intel and say, boss, you know what, take out that FPU, put this POSIT inside. Right? Even the watchman from the Intel campus will not let me in if I go with that. So what do I do? How do I prove, or how do I first convince myself that the max on paper, which has converted to a fully functional chip, is actually doing what it's supposed to do, right? So that's the only reason where we have put the chip on a PCI board, plugged it into the PCI bus. And very similar to how NVIDIA started CUDA offloading, we are now offloading arithmetic to this chip. And all of your existing scientific applications, any small programs you write, which you are able to build and run on float, can directly be built and run on this Tunga board. So that is one of our design philosophies. The user should not change their code. Right? The code which is today running, so if you download a CFD application like GROMACS, if you go for OpenFOAM, if you go for CP2K, any of those scientific applications, which are all open source, you are taking it, building it, running it on an existing machine. All you have to do is take it, build it, cross-compile for RISC-V with the Caligo compiler, which will generate numeric instructions for the POSIT unit instead of floating point instructions. That's the only thing you have to do. You take it, compile it with our compiler, you can run it on our POSIT board. Right, so this is a bit of a roadmap that we had. At 2026, we are working on Tunga 2. So the Tunga 1 that we have today, which is functional, is a 400 megahertz chip. Right, so I don't know. Maybe your Fitbit tracker runs at a faster gigahertz. Right, so world has moved so much, and we closely engaged with some professors in IISc. One of their research scholars wanted to run something on our chip and see how is the result compared to x86. You won't believe me, it actually ran for 3 months before the result came out, right? Now, is that a good thing or a bad thing? I will say it's a very good thing, because now I know my chip can run for 3 months without crashing, right? Now, the result good or bad, that is not my problem, because it's a domain-specific answer, right? If somebody says, like my previous speaker, right? So if he says the tire pressure should be this, it should not be this, that is his area of expertise. Now, all I want to know is this, yeah, my chip is able to give that number. So we proved it can run for months together without crashing. And then the domain experts came back and told us, you know what, we like the results coming from your chip better than the floating point results. So that is the kind of validation we have got today. So now we are going forward with the next more commercially viable product, which is a Vega core based chip. We are going for 64 core, expecting each core to run at 2 gigahertz with a net speed of 128 gigahertz. So from 400 megahertz is octa-core. But frankly, we don't do a lot of parallelization, because at this point we are trying to do only the proof of concept of the maths. And we have currently started doing parallelization. So at some point we'll be running 400 into 8, 3.2 gigahertz. From that we are ambitiously aiming to jump to 128 gigahertz, right? Plus the proto board we have today is only 2 GB RAM. So your big scientific applications cannot run on that. So we are looking at the second version, which has an addressable space of 1 TB, but based on the DIMM size, it can have either 256 or 512 GB. So those are the configurations we are looking at for the next version, which is currently under development. We are hoping that by next April it should be ready to be given to our partners and interested people. So yeah, so 2 examples where I am not just throwing statements at you just to prove that we have actually seen functional results. So Hyphen Software is a CFD company that works with some aerodynamics establishments, and we had one of their software run on our system. So the first graph you see is the regular run on a FPU 64-bit. The second one is the run on PNU 32-bit. It's a different story, it took 1 month to run, but finally the answers came and we were able to plot. And we are seeing that the plot looks very similar to, of course with human eyes it looks exactly same, but the reality is there is a little bit of a small difference variations, but the domain people said, yeah, this is completely acceptable, but we are achieving the same thing with 32 bits, which means half the number of bits, which means half the number of gates and operations. So even if you have a 64-bit register and first 32 bits of it is 0, And if you add two of those, the circuit is still going to do 0 plus 0, 0, 0 plus 0, 0 for all the zeros in the register, which is going to take power, right? So the way you avoid that is you should have a 32-bit register only. Having a 64-bit register with leading zeros is not going to save power, right? So it's half the power, and the result comes at half the time because the number of bits being processed is less, which means less heat, which also automatically means less cooling expenses, right? Where does this all give advantages? So that is something the domain people will be very inventive about, but we are at least thinking that edge AI will be one area where this can be very useful, because your cameras or your phones, which are all chargeable and run on limited power between recharges, if we say, use POSIT instead of float. See, today we all know the highest power consumption in our phones are the screens, right? So if you dim your screen, your phone can last longer, right? So, and what if I say you use POSIT instead of float? And somebody in my company earlier was a doctorate in hardware, right? So he made the statement, the best way you can make non-technical people understand is that if you use POSIT instead of float in your phone, instead of charging every day, you can charge every week, right? So that is the level of power efficiency we are expecting to achieve with the new chip coming up. This is another very famous molecular dynamics software. So we just took it and we ran it with, so there's a Professor Devnath Pal in IISc. So he's the person we engaged with, and we ran this. This one took 3 months, right? And this is run on a data size of 1 nanometer cube, right? So, then finally they said, can we do a 10 nanometer cube? Then it's like, okay, 1 nanometer takes 3 months, so 10 nanometer, I don't know, will it be a linear into 10 or will it be exponential into power of 10? I don't even have that much domain expertise to know how the domain is going to respond to increasing the size of the data by 10, right? So when I say 1 to 10, it is not just linear 10 on one direction, right? So it becomes 10 cube. That's like 1,000 times bigger data. So how long it will run, what will happen to the system? We have proved chip runs for 3 months, so are we going to try and prove it runs for 3 years? No. He said, let's not play that game with this chip. We'll wait for the next one. So, and they said, yeah, 1 nanometer results are very good. We are happy with that. Right? So that is where we are today. And it's very exciting to see so I am the software head of the company. The hardware head had to leave yesterday, so he is not here with us. And it's very exciting for me to see that, okay, I am writing stuff that is going to make something very useful for every end user, right? As a chip which can save power, which can, right? And yeah, I think I had it on the slide, right? So it's a RISC-V octa-core, right? But today it's a Psi-5, but next we are going full.
There are a lot of people who are waiting to leave because they have trains. That's the reason why.
I'm done. So, right. So I just wanted to reiterate that this is RISC-V. The new board is going to be Vega, which is homegrown in IIT, and we are waiting to see, excited to see how it all goes forward, right? So, thank you. You can all look up our websites, LinkedIn, email, we will connect.
So sorry for yeah. We'll just felicitate you. Just give us. Yeah, check. It's off.
Thank you, sir. Please accept the memento given by Patanjali, sir.
We have arrived at the conclusion of this event. It has been a journey of deep inquiry and remarkable creativity over the last 2 days. Just a note for the participants, e-certificates will be provided to all delegates, Grand Challenge participants in your registered emails within a week. And finally, once more, can we just get a massive round of applause for the participants and the sponsors? Thank you. This symposium was just the beginning, but as ever, all good things must come to an end. To deliver the closing address for the symposium, we are honored to invite Professor Patanjali on the stage. Over to you, sir.
Good evening, everyone. So I have a piece of good news. I'll not keep the speech long, right? I know most of you are eager to go out and collect the event kit and get back to your trains, planes. So I'll keep this very, very short, right? I'd like to start by thanking our partners, MeitY, Pravartak, India Semiconductor Mission, and RISC-V International. All the efforts that we do will not be possible without their support and their timely help. And I would also like to thank our silicon sponsor, Mindgrove Technologies. I'd like to thank Sharan and Shashwat for their valuable insights during the panel discussion, and I'd also like to thank Kapil for his insightful tech talk. And I'd also like to thank our platinum sponsors, NXP Semiconductors, for organizing the workshop on 31st, and also to Mr. Saurav for the insights during the panel discussion yesterday. And I'd also like to thank our gold sponsors, CDAC, Incor, Tenstorrent, and Mirabilis. And I'd also like to thank our startups who participated in this event, Vyoma, Guvi, Yantra, and Caligotech, right? And everything that we do at Shakti is born out of the vision of someone, right? So first, I'd like to thank our director, Dr. Kamakoti, because without his vision, all of this would not have been possible today, right? Because at one point, I was a student like you sitting in some workshop wondering how do companies like Intel, TI build all of this and what is this all about, right? Because I was learning 8085 in school and in college, and then companies like TI, Intel would be talking about these like newer generation of processors, and I don't want to give away the names because then I'll be dating myself. I'll be revealing how old I am. I don't want to do that. But I used to wonder, right? And it was through attending Dr. Kama's lectures or Dr. Chester's lectures, right? And Rice Lab essentially gave me the platform that to, take my interest and turn it into reality, right? It gave me the platform to try out 100 different things and to fail safely before I found the thing that I truly wanted to do, right? And that's what put me in this path today. And I hope that this symposium does the same for you, right? And I would also like to thank Dr. Chester and Dr. Gopal for organizing the panel discussions. And I'd also like to thank Lavanya ma'am and Madan sir for their valuable inputs. The symposium would not have gotten to where it was today. And I promise I'll start the preparation a little bit earlier next time. I'll not leave it till last minute. But thank you for the valuable insights and inputs. And thank you for taking care of a billion different things that would have gone wrong otherwise. And thank you for SciStar for their valuable participation and contribution in organizing this symposium. And thank you for Nitya ma'am and Anand sir for organizing the Shakti stall. Again, I know it was like super last minute, but I saw the stall and it looked fantastic. I don't know how you pulled it off, but it was a miracle. And again, like I said, I won't wait till the last minute, right? And before I get to the crucial part, can we all have a round of applause for our organizers and also for our volunteers? Thank you to all the volunteers who stepped up. So I've been getting a lot of feedback that the whole symposium was run like clockwork. And I know that all of it would not have been possible without the efforts of all of you guys, right? Thank you for stepping up. Thank you for helping us make this 2 days a huge success, right? And so before we go on to what is our vision for the next year and how can you all be a part of it, I just want to take a couple of minutes to thank the Grand Challenge 2025 Shakti team. I'd like to start by calling out the team members, the Shakti team members on stage. I don't want to miss out anyone, so I had it written down. So first is Puru sir. Please come on stage. And then Koti sir. And then Nambi sir. Do we have Nambi sir here? And Puvarsan. Please come on stage. So for those of you who are wondering what Shakti can do for your careers, Puvarsan is a shining example. So Puvarsan was our project associate and his tireless support during the Grand Challenge Hackathon, right? It's okay, come on stage, right? And now he has recently joined Qualcomm, right? So yeah, Puvarsan is one of our superstars. So you have to be on stage, right? And Jayant. Where is Jayant? Jayant, I know you are hiding out there, so you need to come. Yeah. Anand sir. Yeah. Umesh, you also have to come on stage. Right? Sridevi, Giri, right? And Giri is also one of our shining superstars, right? The C-class, anything with regards to C-class, I think there are only, at this point, 2 people in the lab who know the C-class, like the back of their hand. One is Lavanya ma'am. That's because she was one of the initial designers for C-class. And then the next is Giri, right? And then Sridevi, yes, Varun. Yeah. I know some of you are hiding, but please come on stage. Right? Nitya ma'am. Ma'am. They have listed you. Vignesh. Satya. Right? So I know all of you saw these 13 teams out there presenting their products today, but at one point they were just, Varun, come on stage. At one point they were just concepts, right? And the entire team, right? I still don't see Anand sir and Umesh. Oh, Umesh. Yeah. So the entire team spent painstaking hours, countless hours interacting with the teams, right? Answering every single question that they had. And I mean, at all times, right? So sometimes I used to walk into the lab and then at 6 p.m. during the day, they'll still be having meetings with the teams, trying to answer all doubts that they had, right? And whatever products you saw today, from the Shakti team, it would not have been possible without the tireless efforts of all of them. Can we have a big round of applause for them, right? And as a token of our appreciation, we would like to present a small memento. Yeah, so we'll wait for the memento. But in the meantime, yeah, I'll just give a quick outline of what we are planning for the next year. So far, you would have seen, right? We have been dropping small hints. We have been, the panel discussions were sort of like a dead giveaway, right? So yesterday's panel discussion was about security, and today's panel discussion was about AI. And I mean, if you think about it, for the next generation, right? So right now we have shown that we can build like, So thank you once again to the Grand Challenge organizing team for the Grand Challenge 2025. So coming back to where I just left off, right? So as I said, we've been dropping some not so subtle hints that security and AI is going to be the next key milestone that we as a group are going to strive towards, right? So it's at this point we have shown that we can build, we have the capability to build world-class processors. We have the capability to tape them out. So, and we have the capability to develop processors for specific applications. We have shown that we can, work with startups. We can work with industry partners, to develop really custom applications, right? Now, the next challenge is how do you build, right, something that is secure by design, right? So, because as you saw today, there are, people who are building products using Shakti or the general RISC-V ISA ecosystem. So the next generation, so at this point, it's a given that the next generation of startups are going to be built on the RISC-V ISA ecosystem. So when they start building their products and when they start hitting the market, one of the crucial things that will define their longevity and their success is going to be how well can they adapt to the user's demands. And today, if you think of any digital device, right, your phones, your laptops, right, or your servers, or if you think about any application that is running on these devices, the first and foremost things that defines is not the performance, it becomes security, right? Over the last couple of years, we have seen what poorly designed applications can do. We have seen what can be the consequences of having security as an afterthought. So that is one of the cornerstones, right? In fact, the next generation of processors that you will see coming out from our lab is going to be the security class of processors, right? So, and the cornerstone of those, the cornerstone of the design principles of those processors is going to be, can we do security by design instead of security as an afterthought, right? Instead of designing it first and then throwing in security later, right? So can we enable security by design? And the second class of processors that you will see us coming out with is, can we have processors that can enable us to run large-scale AI workloads, right? As you see today, one of the larger or broader challenges that hampers our country's AI ambitions is the lack of compute, right? If you go take a look at any educational institution, one of the things is you have talent that can develop AI applications, right? But the challenge is, where do you deploy it and how do you deploy it so that you can handle the needs of 1.5 billion people, right? That needs compute at scale, right? So how do you enable this technology? And that is going to be the focus, right? So we are going to have workstation scale processors, server scale processors, right? And custom AI accelerators coming out of the lab, right? Now, one of the questions that you might have as a student is, okay, all of this sounds exciting. How can we be a part of it, right? So how many of you visited the Shakti stall? Oh, this is quite a significant number of hands. And so in that, you would have seen this QR code where it says join us, right? So those of you who are interested, right? So if you are in your second and third year, we do have internship opportunities that where we host students every summer, right? And the students do get a chance to work on really interesting projects. And again, I'm not making stuff up. You know how I know? Because I was an intern at the lab. I started my research journey as an intern at, it was not called Shakti Lab, it was called RISC Lab back then. So that is where I first got a chance to try out what industry grade VLSI designs, like, or what it takes to, design something that is industry grade, right? So if you are in your second and third year, I would say, please consider applying to us for internship. We do have internship openings on the software, hardware, and physical design team. Those of you who are in your final year, we have project associate positions open. So the way it goes is we'll have a couple of rounds of interviews, and then we do take you on. You will have a short probationary period where it's not just about your interest, it's not about your skill, it's also about your commitment, right? So, but after that, you will get to work with us on some of our critical projects, right? And yeah, so those of you who are interested in higher studies, IIT Madras does offer a chance to apply for MS and PhD programs. So I would say, please check out the IIT Madras website for the appropriate deadlines, right? So, but if you are considering a startup, right? So we do have the RISC-V Knowledge Center of Excellence, which enables us to work with startups, right? So if you have a product where you feel that, okay, I've been trying it out on some commercial grade processor, and I want to swap it out with the open source RISC-Shakti processor, we can work with you, right? Any kind of support that you need, we can enable, right? In fact, we are trialing out a cloud FPGA platform, right? Because one of the common requests that we get from startups is, yes, I have engineers to build the RTL, but I don't have the necessary funds to, you have my own FPGA, right? So how do you bootstrap startups? So we have the cloud FPGA platform, which we are currently in the trial phase. We'll be launching it at a later date, right? Now, if none of this interests you, and if you want to give it a shot, if you are of the mindset that I really don't know if this interests me, but I would really love to have a chance at trying something out before I make up my mind, please do keep an eye out for announcements on our webpage. We have 2 hackathons planned, right? We have a security hackathon and a physical design hackathon, which is aimed at giving participants an exposure to EDA tools. The dates will be announced at a later date. So the hackathon will have a short workshop, which will give you an idea of what the tools do, right? And then a couple of days where the participants, which is you will be given some designs, some academic, some industrial, and you'll get a chance to get an idea of what it means to take the design to GDS2, which is almost pre-tape out, right? What does it mean to say when we go through the physical design process to tape out a design, right? So the dates will be announced at a later time, right? So we have all of these initiatives planned out. So feel free, but if you feel that we can be of help or we can be of service in any other way, feel free to reach out, right? If you have questions, feel free to reach out, right? We are always here to answer, right? Don't hesitate. That's the only thing that we cannot do for you, right? I cannot ask a question on your behalf, right? But all of these initiatives that you do see us trying to do right now were born because someone in the audience wrote to us saying, it'll be nice if you can do something like this for us, right? That's how we plan the Cloud FPGA. That's how we planned our hackathons. That's how we plan our workshops. So please do write to us, right? And we'll be happy to meet your requests, right? But thank you all. Thank you for being a part of this symposium. It's really heartening to see, a significant crowd on a day 2, which is a Sunday, right? So thank you for taking your valuable time and being a part of the symposium. Thank you.
Thank you, Patanjali sir, for those inspiring words. And thank you everyone for making the 3rd edition of Digital India RISC-V Symposium a grand success. Your contributions are greatly instrumental in keeping us going. Please collect your event kit at the desk. We wish you a safe journey home. Thank you.
One final announcement before everybody gets up. We have blocked the side doors on account of crowding at the reception desk where event kits are being collected. We request you all to take the back exits, take the refreshments, and then go to the event kits so that you also have a less crowded experience at the end. Thank you so much.